to the academic community. Last year, ACT brought out a special volume called ACT's Footprints, edited by Principal Dr. Umesh Chandra Jain to celebrate 20 years of ACT. So this is the volume which was brought out. ACT started in 2000 due to the initiative taken by Homi Bhabha Center for Science Education. And all these years, Homi Bhabha Center for Science Education has extended strong support and guidance to all our activities. I am grateful to all the HBCSC directors, right from Professor Arvind Kumar to the present director, Professor Arnab Bhattacharya, for their unstinted support and help in all our activities. Thank you, sir. We have a large network of active members all over the country, as well as several institutional members. ACT is fortunate to get the guidance of the leading chemical scientists of our country, including Bharat Ratna Professor C.N.R. Rao, the former scientific advisor to the Honorable Prime Minister of India. One of the focus of this year's NCCT is to attract the teachers from the eastern and the northeastern parts of our country to become the members of ACT and actively participate in its activities. One of the interesting features of this year's NCCT is the participation of 7 speakers from abroad, in addition to the eminent experts from our own country. I am grateful to all of them for sparing their valuable time for us. Professor Nayan has already mentioned the speakers. They are from all parts of the world: USA, Spain, Germany, UAE, etc. Apart from the usual activities for students and teachers, like organization of national and international conferences, training workshop, chemistry competitions, National Chemistry and National Science Day celebrations, newsletter, and Chemistry Olympiad, ACT has in the last 2 years started some new activities which we call flagship activities, like ACT Chemistry Research Convention under the convenership of Professor Rakhi Gupta, which focuses on the various aspects of research in chemistry. A week-long workshop on designing quality questions under the convenership of Professor Subhash Prasad Singh in collaboration with the faculty of the Homi Bhabha Center for Science Education. This workshop focuses on how to prepare good quality questions of the Olympiad level. Web-based chemistry orientation workshop for competitive examinations, coordinated by our treasurer, Professor Hemant Khanolkar, Professor Subhash Prasad Singh, and Professor Amar Srivastav, who are all very senior members of ACT. A national web workshop on chemistry orientation for UG and PG students, coordinated by Professor Amrit Mitra, our very young dynamic ACT office bearer. Webinars on women in science under the convenership of Professor Helen Kavita, which focuses on contribution of women to the development of science. A concept test in chemistry has been successfully organized for the last 5 years under the dynamic leadership of Professor Subhash Prasad Singh, and I am happy to tell you, every year the number of students appearing is increasing. Association of Chemistry Teachers is collaborating with the international organizations like IUPAC and Royal Society of Chemistry London for some of these activities. Since last 2 years, we are organizing the IUPAC Global Women's Breakfast, under which several activities are being organized all over the globe. Under the convenership of our president, Professor Brijesh Pari, we have been able to contribute the highest number of entries. Last year, we contributed 70 entries, which was the highest number all over the world. This year, The Global Women's Breakfast is planned in February, and I'm sure we will also have a record number of entries. The association is lending academic support to a peer-reviewed international chemistry journal, GP Globalized Research Journal of Chemistry, which is abstracted and indexed in Chemical Abstracts CAS of USA. The journal is a peer-reviewed journal with an international editorial board and panel of reviewers, and does not charge any fees for publication of papers. Every year, ACT honors the outstanding chemistry teachers of our country by presenting 8 awards. This is a recognition of the distinguished services of our chemistry teachers. Coming back to NCCT 2021, there will be deliberations on several frontier areas of chemistry and chemical education, and I'm sure all the participants will benefit immensely from these lectures. I would like to thank Professor Ashish Sharma, Director of Sikkim Manipal Institute of Technology, Professor Nayan Kamal Bhattacharya, Convener, Professor Sangeeta Jha, General Chair, all their colleagues, teaching and non-teaching, of the Department of Chemistry for organizing NCCT 2021 on such a grand scale, and for their dedicated hard work. I hope sometime in the future, we can have a meeting in Sikkim in the offline mode to see the beautiful state of Sikkim, which is one of the most beautiful states of our country. In the end, may I request the director of the SMIT, Professor Ashish Sharma, to enroll your prestigious institution as an institutional member of ACT. We'll be honored to have SMIT as an institutional member of ACT. I wish NCCT 2021 great success. Thank you very much.
Sure, sir, we'll do that.
Yeah.
Thank
Good.
you.
Thank you. Thank you, sir.
Thanks, sir.
Okay, good.
Thank you so much, sir. There is a small correction. The name of the director is Professor G.L. Sharma. May I now request Professor Brijesh Pare, President ACT, to address the delegates.
Thank you. And once again, very good morning to all of you. Mr. Vice Chancellor, Lieutenant General Dr. Rajan Grewal, Professor G.L. Sharma, the Director of Smith, Professor Arnab Bhattacharya, the Director HBCSC Mumbai, Professor Prabhu, Dr. Sangeeta Jha, and of course, Dr. Convener, Dr. N.K. Bhattacharya, and all the participants from across India and abroad, and my dear SCT life members and executive members. It's a matter of great pleasure and privilege that Association of Chemistry Teachers is organizing a National Convention of Chemistry Teachers, NCCT 2021, which is our annual program for the last 20-21 years. And together with the International Conference on Recent Trends in Chemistry and Chemistry Education, we always strive for doing something for chemical education, and therefore in all our conferences it is always there. So now the 3 days, from 28, 29, and 30th December, this association between ACT and Smith, will going to bring fruits to the all researchers and the faculty members. I wish this congregation would provide a potential platform to all the participating researchers, faculty members, and researchers, not only from academia, but from industry as well, and an opportunity to showcase their research work, and at the same time get an opportunity to interact with many stalwarts of the field. And as you know, like the N.K. Bhattacharya have mentioned, Professor Claudia will be speaking from the British University, Germany. Then we'll having the Fadi Hassan from UA University, Professor Bays from NEHU. Then we'll be having Professor Ruiz, from the Ray Jewel Scholars University, Madrid, one very senior fellow from industry, Dr. The Paniswamy, will be from Millipore Sigma from USA. Then Mohammad Al Salah, who is a fellow from Harvard. He will also be speaking. We'll have our own Professor of Paul, Director ICER. So such a, the battery of the speakers will, so for the participants, it's going to be a great opportunity to listen to them and interact with them. The content of the conference, is quite wide, that is just for the purpose of, so that you can incorporate the researchers and workers from the various fields, So, the nanotechnology is there, then environmental science is there, organometallics is there, even computational science is there. So there is a basket of various topics and subjects that will be deliberated upon. As far as Association of Chemistry Teachers is concerned, as Professor Prabhu has already told, that last 21 years, the SCT has been doing its best to bring, the best mind, working for chemistry education at one platform, and that we do through various programs and various conferences and events. Recently, SCT has been doing a research convention that is, some 7 to 8 events we do into that, and that is for promoting research among the young student, even at undergraduate level and postgraduate level. And that program is going on very well. So I just take this opportunity to thank the director, Dr. Arnab Goswami, for giving all the support at HBCSC. And so I just welcome all the speakers from India and from abroad, all the participants, all the SCT members and executive members of SCT. And in the end, on this occasion, I congratulate once again Professor Nayan Kamal Bhattacharya, who is the convener of NCCT 21, Professor and Head, and all his team, Dr. Sangeeta Jha, for having given this opportunity. And as expressed by other speakers also, when the occasion comes and everything would be normal, definitely we would love to come to Sikkim Manipal University and have a similar program on site. So once again, I congratulate the organizers and I wish them all the best. Thank you very much.
Thank you, sir. May I now request Professor Dr. Arnab Bhattacharya, Director HBCAC, to share a few words.
Good morning and welcome. I'm going to change the order a bit. So I'm going to first thank the respected and honorable teachers, because this conference is for you, and then the students, and finally, all the honorable dignitaries from SMU, ACT, and others who are here. So thank you all. Thank you for having me here to speak at the NCCT, especially Brijesh. You have been very insistent, and thank you so much.
Thank you
for having me here. I hope you will not be disappointed that you have a very fake chemists among your midst.
No.
Okay, I have an undergraduate in engineering. I have a PhD in physics, and most of my life has been at the interface of material science and electrical engineering, and I grow semiconductor materials in my lab. But for the past 20 years, there has been one reaction which has defined my life, which is happening in what you see behind me. It is trimethyl gallium plus ammonia giving me gallium nitride and methane. So in a way, I do some chemistry. But of course, as I have diversified, I've been working with tungsten sulfide, rhenium selenide, copper antimony telluride. Currently, we are doing vanadium doped gallium oxide. So, the periodic table is a great friend of mine, and I lead a dual life. I'm a science communicator. I take, science out to the public. I love to do these very easy to do or very dramatic chemistry experiments. So I do collaborate a lot, both in my professional life and in my outreach with, the proper chemists of the world. And in the last 20 years, if there is one thing I have learned, is that, being at the fringes of chemistry, if like somebody like me at the fringes of chemistry, is actually that the most exciting stuff is happening at the interfaces of traditional chemistry with other disciplines. Now, if you just have to look at the chemistry Nobel Prize, okay, this year it went for catalysis, fine. But otherwise, most often for our chemistry Nobel Prize, we have to bring a biologist to explain it. Because anyway, biology and chemistry, I think, have very seamlessly merged over the last few years. See CRISPR, for example. In this thing, Unfortunately, I find that most of our chemistry curriculum, both at the school level and the undergraduate level, as well as the way we teach chemistry in class across India, is still very ancient and also very disconnected from what is happening at a fantastic pace in the world we live in today. You know, chemistry is the stuff that drives our world. And chemistry labs in UG colleges, etc., are not the places where, you know, the students would love to spend extra time. They're almost these, you know, they've been the same for many years. They're smelly. They're people who just like to do their experiment and go. Okay. So of course, there are two things I want to highlight. One is how exciting it is. But the other is, let me start with the harder one first, lab safety. Okay. Yes, chemistry is an experimental science. The fun is in doing experiments. You know, we do all these experiments. We do crazy experiments. You know, if there's stuff blowing up, that it's all okay. We cause a mess, that's fine. But we do it carefully. And if it is a teaching or research lab, we just have to be careful. No, you know, nothing. There is no way around it. Issues like ventilation, exhaust, disposing solvents, chemicals, you know, minimizing the amount of stuff we use. I think we have to be careful today for the planet's sake that we do our chemistry experiments properly. But that's the thing. The main thing I want to rather tell you is that, you know, that you will take care of, I'm pretty sure. I want to talk about exciting stuff. And let me give you two examples to tell you how chemistry is just connected to everyday life and the things we do, which you often miss. You know, this year itself, 2021, let me take two things which you definitely haven't missed. You must have watched the Olympics. You must have watched the Paralympics. Indian athletes excelled, javelin, high jump, you name it. You know, it was all in the news. Now I say, what is this thing? What's he talking about? This is a chemistry talk. Where's the chemistry? You know, the javelin thrower, if you saw the video of him throwing the thing, the track he's running on, those are polymer granules. The high jump, the mat the person lands on, that's a polymer foam. Okay, these things have to be out in the open. They are in the rain, they are in the sun. They cannot degrade. You have to engineer the polymers properly. This is chemistry. Many of these sports companies actually hire chemists to work on, you know, really cutting edge problems where practically how do you get these polymers to survive on racetracks and wherever else they're putting them. The other thing which all of us definitely know, even if you haven't watched the Olympics, you have used a mask, right? Now, whether it is an N95 mask or a surgical mask for COVID, most of the high quality masks depend on melt-blown polypropylene fibers that do the heavy duty job of filtration, right? You want to filter 0.3 micron particles, but your gaps are large, you know, micron size gaps. Otherwise you couldn't breathe. And what saves you is electrostatics. These polypropylene fibers have electrets. They have, you know, built-in charges in them. Now, what happens when the charge goes away if you try to wash the mask or something? How long can the charge be there? How do you maintain a good electret? What happens? Why do people with magnesium stearate in it? How do you control the crystallinity of the polymer? Is it an isotactic polypropylene that's better or an atactic version or something in the middle? There is so much chemistry going on before you can make a mask. And now people are trying to make better masks, which are more breathable and everything, thanks to chemistry, right? And it is up to us as teachers to connect the chemistry in the syllabus or in the textbook to what is happening in the real world outside. Today, there are a zillion opportunities for somebody with a chemistry specialization. You could be studying astrochemistry in a galaxy far, far away. You could be studying on what is happening in the chemistry of a hydrothermal vent at the bottom of the ocean, right? You could be figuring out how the functional group on the isocyanate molecule that's going to react with a glycol to make a polyurethane foam that's going to be a memory gel in a running shoe or in something else, right? You could be in a law office working on a process step for a pharmaceuticals patent. All these things are done by chemistry people, right? We as teachers need to tell people how versatile the field of chemistry is, how it appears everywhere, and all the opportunities that exist beyond being a mere researcher in a lab or a teacher or something, which is also good, no doubt. We need people in that thing, but there is just so much in the world today. And on that note, I am sure I've seen the thing. There are some lovely lectures you're going to be able to listen to. There's going to be lots of fantastic discussions, and I wish you all success for the conference this year. And hopefully next time, please do it somewhere. Let's hope this COVID goes away so we can all meet and discuss this in person. Thank you so much.
Thank you, sir. May I now request Honorable Vice Chancellor, Sikkim Manipal University and Chief Guest of today's function, Dr. Lieutenant General Rajan S. Grewal, to say few words to bless us in this occasion.
Good morning, ladies and gentlemen. Professor Brijesh Parekh, President, Association of Chemistry Teachers, Professor D.V. Prabhu, General Secretary, Association of Chemistry Teachers, Professor K.S. Sherpa, Registrar, Sikkim Manipal University, Professor G.L. Sharma, Director, Sikkim Manipal Institute of Technology, Professor Sangeeta Jha, General Chair of this conference, Professor Nayan Kamal Bhattacharya, Professor Chemistry and convener of this conference, eminent invited speakers, esteemed members of the Association of Chemistry Teachers, learned faculty members of SMIT and SMU, and dear research scholars, students and participants. Team Sikkim Manipal University joins me to acknowledge the praiseworthy endeavour of the Department of Chemistry, Sikkim Manipal Institute of Technology in organizing the National Convention of Chemistry Teachers and International Conference on Recent Trends in Chemistry and Chemical Education. This noble venture is in collaboration with the Association of Chemistry Teachers as also the reputed Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research, Mumbai, and happy to note that we are organizing it from the 28th to 30th December of 2021. We are also pleased to learn that this conference encompasses various disciplines of pure and applied chemical research. We are sanguine that this convention will provide promising avenues and opportunities to deliberate on the recent advances in chemistry research, to share contemporary knowledge and its applications in various scientific frontiers and fields. This convention should also be an ideal launchpad to widen the horizons of the participants and create a collaborative framework between the academia, research fraternity, with the industry and the community as stakeholders. It is indeed heartening that we have a galaxy of distinguished invited speakers, out of which 7 are from reputed foreign countries, as also reasonable participation from India. Moreover, 92 researchers will present their papers and publications in this conference. I am confident that this conference will bring together scientists, researchers and faculty members to discuss modern academic and industrial aspects of various fields of development and recent advances in chemistry. I would like to take this opportunity to thank Professor Brijesh Parekh, President, Association of Chemistry Teachers, and Professor D.V. Prabhu, its General Secretary, for the collaboration with our Department of Chemistry of the SMIT. We hope this collaborative venture will continue in the foreseeable future to strengthen our bonds. Our heartiest felicitations go out to the head of the Department of Chemistry, Professor Nayan Kamal Bhattacharya, who is also the convener of this conference, and faculty members of the Chemistry Department for taking this praiseworthy initiative along with the Association of Chemistry Teachers. We take this opportunity to extend a warm welcome to each one of our distinguished invited speakers, esteemed guest faculty, learned delegates, and also wish the conference and convention a splendid success. Thank you. Jai Hind.
Thank you, sir. May I now request Professor D.V. Prabhu, General Secretary, ACT, to announce ACT awards to the best teachers in various categories.
Thank you. Dignitaries and friends, it's my honor to announce this year's ACT laureates. 8 awards have been instituted since 2012 through endowments received from the well-wishers of ACT. These awards are presented during National Convention of Chemistry Teachers to recognize the contribution of chemistry teachers to education and research. The awards comprise a cash award and a certificate. There are 8 awards which we give annually to recognize the services of teachers to education and research. The first award is Association of Chemistry Teachers Lifetime Achievement Award, which is presented to a superannuated chemistry teacher in recognition of his or her distinguished services to chemistry education and research. It's my pleasure to announce that this year's recipient is Professor Sapan K. Saha, former Professor of Chemistry and UGC Emeritus Fellow, Department of Chemistry, North Bengal University, Darjeeling. Professor Saha has guided 15 students for PhD, published 62 research papers in prestigious journals, published 3 books and 3 chapters in books. He is the recipient of the Commonwealth Academic Staff Fellowship Award to work in United Kingdom during 1988-89, Emeritus Fellowship Award from UGC New Delhi for 2016-2018, and Outstanding Reviewer Award from Elsevier Publishers in 2015. ACT congratulates Professor Swapan K. Shah on winning the Lifetime Achievement Award. The second award is the ACT Sri Anupam Sinha Best Chemistry Teacher Award, instituted by ACT Vice President Professor Shraddha Sinha. This year's recipient is Professor Dr. Susmita Sen Gupta from the Department of Chemistry, BN University, which is affiliated to the Guwahati University, BN College affiliated to Guwahati University, Dhubri, Assam. She has a rich teaching experience of 24 years at the undergraduate level. She has published 39 papers, 6 books, and has completed 4 research projects. She has a very good contribution to education. She has organized subject-related activities, research activities, history popularization activities, and has given several popular lectures on chemistry. ACT congratulates Professor Susmita Sen Gupta on winning this year's Sri Anupam Sinha Best Chemistry Teacher Award. Congratulations, madam. Usually these awards are given in person, but this year, because of the pandemic situation, they are being given online. And after this function is over, the certificate and the cash awards will be sent to them by courier or by post. The third award is the Association of Chemistry Teachers Best Woman Chemistry Teacher Award. This year's recipient is Professor Dr. Jyoti Rekha G. Handik, Director, HSB School of Science and Technology, KK Handik, State Open University, Assam, and Professor, Department of Chemistry, Dibrugarh University, Assam. Professor Handik has guided 5 PhD students and 6 MPhil students. She has presented 33 papers in prestigious conferences, published 35 research papers, and 25 popular articles. She has to her credit 9 Best Oral and Best Poster Awards in various conferences. Association of Chemistry Teachers congratulates Professor Jyoti Rekha Ji Hande on winning Best Women Chemistry Teacher Award. Congratulations, madam. The fourth award is the Association of Chemistry Teachers Professor P.R. Singh Award for outstanding contribution to chemistry education. And this year, the recipient is Professor Dr. B.S. Balaji, Associate Professor, School of Biotechnology, Jawaharlal Nehru University, New Delhi. Professor Balaji has contributed a lot to popularizing the chemistry education. He has served as a resource person at 73 faculty development programs. Just imagine, 73 programs. He has 26 presentations in conferences, 3 patents, and has published several research papers. His contributions are innovative and has served a large number of students and teachers. Congratulations to Professor Balaji on receiving this year's Professor P.R. Singh Award for outstanding contribution to chemistry education. Congratulations, sir. Fifth award, ACT Dr. Umar Sai Prakash Chemistry Popularization Award, instituted by our former president, Professor Sai Prakash. This year's recipient is Professor D. Ramachandran from the Department of Chemistry, Acharya Nagar Arjuna University, Nagarjuna Nagar, Andhra Pradesh. Dr. Ramachandran is a versatile, prolific researcher. He has guided 37 PhDs, 2 patents, 4 books, and has published 150 papers. He has given several invited talks and has organized several chemistry popularization activities by way of workshops, training workshops, etc. Association of Chemistry Teachers congratulates Dr. Ramachandran on winning this year's Dr. Umar Sai Prakash Chemistry Popularization Award. Congrats, sir. All these prizes are decided by selection committees, which are appointed by the ACT Executive Council, and the decision of the selection committees is final. The 6th award is Professor Lalan Singh Award for Best PG Chemistry Teacher of State Universities, issued by the students of Professor Lalan Singh, initiated by Professor Subhash Prasad Singh, our ACT Secretary. This year's winner is Professor Dr. Ajay Taneja from the Department of Chemistry, Dr. Baba Saheb Ambedkar University, Agra. Dr. Taneja has guided 17 PhDs, published 139 papers. He has 5 research projects to his credit, 17 chapters in national and international level books, 36 invited talks, and has presented 75 papers in the proceedings of conferences. From my personal experience, I know Professor Ajay Taneja is a very popular teacher of chemistry at the MSc level. Congratulations, Professor Taneja, for being the recipient of this year's Professor Lalan Singh Award for Best PG Chemistry Teachers, State Universities. The 7th award is Professor Dr. Bhupendra Sahai Saxena Award for the Best PG Chemistry Teacher. It's a general award, and this year's recipient is Professor Dr. Naveen Shimpi from the Department of Chemistry, University of Mumbai, Mumbai. Professor Shimpi has guided 11 PhDs, 8 research projects, 95 research papers, 50 invited talks. Professor Shimpi has published 2 book chapters and has 4 patents to his credit. Professor Shimpi is again a very popular teacher of our university for MSc and PhD level. Congratulations, Professor Naveen Shimpi, on receiving this award. The last but not the least, Professor Pinky B. Punjabi Award for Outstanding Contribution to Research in Chemical Sciences. This was instituted 2 years back. This award has been instituted by the students of Professor Pinky B. Punjabi, led by Professor Rakshit Amita. This year, the award goes to Principal Professor Dr. Anna Pratibha Nikalche of Department of Chemistry, Wilson College, which is an autonomous college under University of Mumbai, Mumbai. She has 116 research papers to her credit, 32 presentations in international conferences, published 20 articles. She has organized 70 conferences and symposia and has served as a resource person at 16 international conferences. And she has published 8 international level books. A well-known administrator, she has been the principal of Wilson College for the last 3 years. And already we are seeing the improvements which are going on in the college. Professor Nikalche has been awarded 2 patents by the Government of India. These patents are useful to society for treatment of epilepsy and 8 types of cancer. Principal Nikalche is a member of International Science Committee of Spain, member of the editorial board and panel of reviewers of several journals. She has transformed conventional synthetic chemistry practicals into green chemistry practicals using innovative tools, and her main areas of research are medicinal chemistry, green chemistry, and development of analytical methods. We congratulate Principal Dr. Anna Pratibha Nikalche for being the recipient of this year's Professor Pinky Punjabi Award for Outstanding Contribution to Research in Chemical Sciences. Let me, on behalf of the ACT, congratulate all these very distinguished teachers coming from all over India for winning these awards. To us in ACT, it's an honor to felicitate you and give you these awards. Congratulations once again to all. Thank you.
Thank you, sir. May I now request Professor G.L. Sharma, Director SMIT, for his presidential address.
Yeah, thank you very much. Good morning to all present here in virtual platform who have joined us for this international conference. At the outset, I extend a very warm welcome to all for this conference, and in particular to our chief guest, Dr. Lieutenant General Rajan S. Garewal, Vice Chancellor, Sikkim Manipal University. Our guest of honor, Professor Arnab Bhattacharya, Director, HPCSC. Professor K.S. Sherpa, Registrar, Sikkim Manipal University. Professor Sangeeta Jha, General Chair of the conference. Professor N.K. Bhattacharya, Convener of the conference. Professor Brijesh Pare, President, Association of Chemistry Teachers. Professor D.V. Prabhu, General Secretary, Association of Chemistry Teachers. Our revered invited speakers, faculty members from SMIT and other colleges, members of Association of Chemistry Teachers, research scholars, participants, and my dear students. It's a matter of great pride for SMIT that Department of Chemistry is organizing National Convention of Chemistry Teachers, NCCT 2021, and International Conference on Recent Trends in Chemistry and Chemical Education, that is ICRTC CE 2021. In collaboration with Association of Chemistry Teachers, care of Homi Bhabha Center for Science Education, TIFR Mumbai, for next 3 days. I'm sure that this conference will provide a platform for the scientists, academicians, industrialists, students from various fields in the chemistry to present their original research work and share their ideas and benefit from each other's knowledge and expertise. Well, ladies and gentlemen, we human beings are knowingly or unknowingly surrounded by the chemistry. Right from morning to evening, life to death, it is a big aspect of our daily life. One may think that chemistry is a branch of science that deals with chemicals and in the labs only. But unknowingly, we are applying it in daily work. We find its use in the food we eat, the cleaning chemicals, the air we breathe, and every object that we touch. Literally, students' chemistry education takes place in lectures and books, and lab playing with instruments and chemicals, and they don't see the relevance in their daily life. I think this is incumbent on us, on teachers, to apprise them that what is the importance of chemistry, and the previous speakers have brought it very aptly, that how chemistry is applicable to each and everything. Well, understanding the importance of chemistry in our regular life is, of course, very important. And in our technological and competitive society, we need not to overemphasize its importance. It also helps us to understand the world issues arising currently. One might get surprised when we say that our body is also made of chemical elements and compound. So we can say that we are the products of chemistry. Our emotions like love, respect, jealousy, frustration are also the aspects of chemistry only. And I can tell you, being a naval engineer, I have served on ships for good 26 years. I have definitely understood the importance of chemistry when it you see that a ship made up of steel is in water which has a high salinity, the perfect environment for rusting. So all this is again chemistry is playing there, but then we are also able to prevent it. Well, I am happy to note that there are 7 invited talks from foreign countries, including US, Germany, Spain, and 5 are from India, which will definitely encourage our researchers, faculty members, and students, and bring them together to have good chemistry in the days to come out with something which is useful for the humanity. Moreover, it is also very encouraging that 92 researchers have come forward to present their work. I think this is phenomenal. And I am also delighted to learn the names of best teachers and the awardees, which has been instituted by Professor D.V. Prabhu, General Secretary, Association of Chemistry. And it is a very good initiative of the association. And I congratulate all the awardees, and I'm sure more researchers would be aspiring for these awards in the days to come. I would also like to congratulate Professor Nayan Kamal Bhattacharya, Head of Department of Chemistry and convener of the conference, and all his colleagues for their hard work to the success of this conference in collaboration with Association of Chemistry Teachers. I would also like to thank Professor Brijesh Pare, President, Association of Chemistry Teachers, and Professor D.V. Prabhu, General Secretary, Association of Chemistry Teachers, for the collaboration with the Department of Chemistry at SMIT for various activities. I'm sure that our faculty members from the chemistry department will continue this collaboration and collaborate with other institutes for improvement of research. I take this opportunity to extend my heartiest welcome to all invited speakers, participants, and delegates to this international conference. I invite everyone to visit our campus once the situation is normal, and let's take our knowledge forward collectively. I wish a grand success for the conference. Jai Hind. Thank you.
Thank you, sir. May I now request Dr. Satadrucha, co-convener of the conference, to propose the vote of thanks.
Good morning to one and all present in this inauguration functions. It is my privilege. Am I audible, sir?
Yes, sir. Please continue.
Yeah, audible.
Yeah. It is my privilege to propose vote of thanks in the inauguration sessions of the conference entitled National Convention of Chemistry Teacher, NCCT 2021, and International Conference on Recent Trends in Chemistry and Chemical Education, ICRTC and CE 2021, organized by Department of Chemistry SMIT in joint collaboration with Association of Chemistry Teachers during 28 to 30 December 2021. Firstly, I would like to thank our honorable chief guest, Dr. Lieutenant General Rajan S. Gravel, Vice Chancellor, Sikkim Manipal University, despite from his busy schedule to grace the occasion and providing constant motivation, encouragement, support, and freedom for organizing this international conference. Thank you, sir. I would like to thank Professor Karma Sonam Serpa, a registrar of Sikkim Manipal University, for his gracious presence in this inaugural function and his constant guidance and motivation for organizing this conference. Thank you, sir. I would like to thank our director, sir, Professor Gurda Manlal Sarma, for preside over this inaugural function and his constant guidance, valuable suggestions, and motivation for organizing this conference. Thank you, sir. I would like to thank Professor Brijesh Pare, President, Association of Chemistry Teachers, and Professor D.B. Prabhu, General Secretary, Association of Chemistry Teachers, for collaborating with the Department of Chemistry and support to organize this National Convention of Chemistry Teachers. I would like to thank Professor Arnab Bhattacharya, Director, HBCSC, for delivering his enlightening words. I would like to thank all eminent speakers from abroad and India for accepting our invitation to deliver a speech in this conference. I sincerely thank to all the participants who are going to present their research work in this conference. I would like to thank all heads, associate director, HOs of SMIT for their support to organize this conference. I would like to thank all faculty members, non-teaching staff of SMIT for their sincere support to organize the event. I would like to thank all the members of Association of Chemistry Teachers for their constant support to organize the event. I sincerely thankful to all the organizing committee members, especially Professor Sangeeta Jha, General Chair, and Professor Nayan Kamal Bhattacharya, convener of this conference, for taking the initiation and collaboration with ACT to organize the event. My sincere thanks to all research scholars of the Department of Chemistry for their hard work to support the conference. I would like to thank to all guests and participants in this inaugural session. Once again, thank you all. There is one announcement. Our next session will start from 11:30 a.m. All are requested to join the session.
Thank you, sir. We are now in the end of this session. Our first invited speaker is Professor Fatih Hassan, Chemistry and Biochemistry College of Science, United Arab Emirates University. He will be joining with us at 11:30 a.m. Therefore, all are requested to join in the same joining link. The session will be shared by Dr. Subhash Prasad Singh and Dr. Soumya Kanti Bishwas. Thank you.
Correct.
Thank you all. Now we have approximately 20 minutes gap since Professor Fatih Hassan will be joining at 11:30 as per our IST. I request Dr. Subhash Prasad Singh, please join in before 11:30 so that we can welcome Professor Fatih Hassan for the first invited talk. We will meet after 20 minutes.
Subhash sir is there, no? He has joined. Huh?
I think Subhash sir?
Yeah. The name is Galaxy something. No, it's not.
Okay,
yeah.
okay. Okay, sir, then we will be joining by 20 minutes.
Subhash, please unmute yourself, please. Subhash ji.
Paras, I am coming back by 20 minutes by taking
Yeah, definitely. We are also coming back. Okay, Prabhu sir.
Okay.
We'll see. We'll get
Prabhu
back
sir,
after 20 minutes.
I'll be back by 20 minutes after a cup of tea, sir.
Yeah. Sure. Good. Bye. Okay, Sangeeta ji. Okay, Dr. Sangeeta.
Chalo. हम कर लेंगे क्या कर लेंगे हाँ তোমাদের কি হলো আমার তো হয়ে গেল
हॉटस्पॉट कर दो बंद। हाँ अच्छा फिर लीव कसं होऊ मग असे
Hello, hello, can you hear me? Hello. Hello.
Hello. Hello, Professor Fatih Hassan.
Hello, Professor Bravo.
How are you, Professor?
Good. Good. How are you?
You are in Egypt, right?
Yeah.
So looking forward to your lecture now.
Yeah. Moving between Cairo, Alexandria, everywhere.
You will start very soon, 2 minutes now.
Yeah.
Okay.
So can the organizer allow me to share the screen, please?
Yeah.
Sir, I have provided you co-host rights. Now you can share your screen.
Oh, thank you very much. So right now, can you see my screen?
Yeah. Yes, we can see your screen.
Okay. So let me know when I can start.
Can you, sir, can you just go in the presentation mode to just to check out that PPTs are moving in a fine manner?
Yeah, like that.
Yeah. Can you shuffle between one or two slides?
Yeah, I'm in the second now and going third.
Yeah, sir. These are moving perfectly fine. Thank you so much, sir.
Oh, yes.
Yeah.
Good morning, Hassan Saib.
Good morning.
How are you?
Good. How are you?
Thank you. I'm fine. I'm fine. Also fine. We are waiting for you.
Welcome back, all. Can you hear me?
Yeah.
Okay.
Yeah,
So we'll now start the invited talk session 1. This session will be chaired by Dr. Subhash Prasad Singh and Dr. Soumya Kanti Biswas. I request both of you to kindly take over the session. Please, sir.
Good morning, ladies and gentlemen. Myself, S.P. Singh, along with my co-chair, Dr. Soumya, welcome you all to the invited talk session 1. Our beloved former Indian President, Dr. APJ Abdul Kalam once said, I quote, when learning is purposeful, creativity blossoms. When creativity blossoms, thinking emanates. When thinking emanates, knowledge is fully lit. When knowledge is lit, economy flourishes, unquote. In view of the same, such a convention, conferences, symposium, seminars, etc. are organized. We all are delighted to have with us today Dr. Fatih M. Hassan from United Arab Emirates University. Dr. Hassan is a physical chemist, and over a few decades, he developed competence in nanoscience and energy-related material research. His current research activities include dimensionally controlled materials for heterogeneous catalysis, exploring materials with new properties that can revolutionize the energy, environment, space applications, and developing new chemistry for developing future high energy batteries and supercapacitors. His publications span the novelty in material design and the state-of-the-art device, the Dr. Hassan is a holder of the Japan JSPS Fellow, Outstanding Achievement from University of Waterloo, Canada, and a winner of Park and Viva Medal of Proficiency in Chemical Engineering. Recently, he was highlighted by Elsevier on his finalist to RegGes. Dr. Hassan published 60 research articles. 9 of them are in top 1% journals, and 1 of them in Nature Communications. His overall citation by Scopus is 4450, and his H index is 34 by Scopus. Dr. Hassan is going to talk about understanding electrocatalysis for energy and environmental impact. Professor Hassan, you are welcome now.
Thank you very much, Dr. Singh. I would like to thank the organizing committee for inviting me for this fascinating conference with a special reference to Dr. Prabhu and Dr. Nayan. I am going to introduce the topic, understanding electrolysis for energy and environmental impact. And when we look around, we use the oil everywhere as a major source of our energy. However, the oil reserve is declining, and within few decades, we may suffer that lack of oil. In addition, the burning of fossil-based fuel like the oil or coal damaged our environment by providing the global warming like greenhouse gases. And these can also have an adverse effect of our environment, like what we see around us during some occasions of flooding or like the melt of snow in the bowls. So the solution for that is we need alternative energy sources that are sustainable and green. There is several ways for that, like wind energy and solar energy and geothermal energy, tide and wave, a lot of them, but all of them or most of them are localized and not portable. And our new technologies, our new lifestyle rely on portability. We need portable, we need to drive cars, we need for power for laptops, for phones. We need another special types of energy to utilize the alternative green energy. And that is the energy storage and conversion, mostly the electrochemical energy storage and conversion. One of these is the fuel cell. Fuel cell rely on hydrogen and air or oxygen from air to produce a very like green source of energy. The only like output product is like water, byproduct is water. And we receive clean electrochemical energy, and that can drive cars, and nowadays becoming practical. Also, there is other types of batteries, like well, lithium-ion batteries are dominating the market right now. However, chemists is always like optimistic to produce new technology, new science that like satisfy the demands for the world. Well, if everyone using the lithium-ion batteries continue using lithium will diminish, and this means we need always to think ahead. So new family of batteries that's actually has high energy density. This called metal air battery. People call it the battery that breathes air. So this battery uses metal and uses air as oxygen, so oxygen reduction reaction on the cathode, and the metal dissolve at the anode and produce energy. And during charging, the battery release the oxygen back to the environment, and the metal is deposited back. And this type of battery can use the several metals, zinc, lithium, aluminum, and some of them is very, very optimistic, but still need a lot of research, like magnesium, calcium, and iron. The theoretical energy density for iron air battery, for example, can reach, well, close to the gasoline. But still, to be practical, we need a lot of work. Also, other type of research is that the way to reverse what we damage to the environment. We released a lot of carbon dioxide during combustion of fuels. So electrochemists also developed a new way to make a research in converting carbon dioxide into more valuable chemicals like carbon monoxide, formic acid, ethylene, methane, or etc. All of these types of energy rely on a catalyst, and this electrocatalyst is a critical issue for these devices. And that type of electrocatalyst, or that type of how these devices rely on electrocatalyst, still need developments, need understanding, need awareness. This awareness is actually a type of integrating the knowledge and the research together for all ages. We need to educate our children at school. What are these devices? We need also to teach it in depth at the university. We also need to do ourselves to do further and further research. So awareness is very, very important, because awareness lets the governments provide funding for research and make that challenging as a fact. So this problem led me to outline my presentation as following. I will introduce the topic and then discuss the fundamentals of electrochemistry and electrocatalysis, where I will check or discuss the thermodynamics, the kinetics, methods in electrocatalysis research, figures of merit for electrocatalyst development, and I will at the end guide with two examples of applications. That's hydrogen evolution reaction and the carbon dioxide reduction reaction. So the word the catalyst came from the Latin name, which means like it's a substance that can enable a reaction to proceed faster. Also, it can mean we can operate that reaction at a lower temperature, because as we know, as we increase the temperature, reaction become faster, but increasing the temperature sometimes is a challenge in industry because it costs more energy and more money. So that's why if we develop the catalyst to operate some reaction at lower temperature, this also is a kind of a benefit and catalyst. So the catalyst normally speeds the rate of reaction by providing a route with a lower activation energy. Almost all of the reaction, there is a minimum amount of energy need to be supplied in order for the reaction to proceed. This amount of energy is called activation energy, and the catalyst actually job is to lower this activation energy, so it provides a pathway for the reaction with a faster way than the high energy required to start the reaction. So the several classes of the catalysis or research in catalysis apply. One of them is biocatalyst or biocatalysis, and this is basically like enzymes. And when we say enzymes, people is not just use this enzymes in human or in animals, but they also developed some enzymes to make a reaction like enzymatic fuel cell, etc. So enzyme-based catalyst, where we can use that enzyme for water oxidation in photosynthesis, similar to photosynthesis or artificial photosynthesis. And this reaction involves hydrogen ions and electron transfer in the rate determined step. And this reaction can apply in ambient temperature and pressure and in aqueous medium. Another type is generally a homogeneous reaction. And homogeneous reaction, it's like similar to the medium in a solution, for example. So these can be a transition metal complex or compound. And this is used to produce fine chemicals or olefin metathesis, and also involve hydrogen ion and electron transfer, thermochemical, and low to intermediate temperature. So it can apply to moderately higher temperature, but not very high. And wide range of pressure. And for the medium can be aqueous or non-aqueous medium. And our concern is the electrocatalyst, Electrocatalyst, an example for that is the platinum nanoparticle, where it's the main catalyst in a fuel cell, and also water electrolysis. The reaction in fuel cell is oxygen reduction and hydrogen oxidation. And water electrolysis is doing the reverse. We call it electrolyzer. So we bring the oxygen and hydrogen from water by electrolysis. And also it can apply for wide range of temperatures and pressures, and it can be in aqueous or non-aqueous medium. And we know, as we know, the conventional heterogeneous catalysis like rhodium nanoparticles that's applied in the catalytic converters and also in ammonia synthesis. This is just examples. So this also can apply in a wide range of temperatures, including high temperature, because catalytic converter, like in car, can be at higher temperature, and also wide range of pressures, and also can be in gas phase and liquid phase. So, and another type of catalysis is ultra-high vacuum catalysis, like in surface science, ruthenium. And these can like apply in a fundamental basis to study adsorption or desorption reaction, thermochemical, and also can be very wide range of temperature and apply at very low pressure. And this is like gas on surface, gas phase on surface. Our concern today, the electrocatalysis, where we use them for energy-based or environmental-based applications. So these types of electrocatalysis comes in different forms. So one major form is photocatalyst or photoelectrochemical catalyst. Photocatalysis is a wide field. However, in photoelectrocatalyst, one of the major field for that is water splitting, photoelectrochemical water splitting. So we use a catalyst that's actually photoactive, that help splitting water into their elements, hydrogen and oxygen, and that could be the source for hydrogen for fuel cells or other applications. Some other catalysts, like solution-based electrocatalyst, like some molybdenum disulfide catalyst that can catalyze the hydrogen generation or hydrogen evolution. And this work has been published in Science, so it's very interesting work. And molybdenum disulfide actually is one of the most important material for its hydrogen evolution reaction. And for other types of insight for reactions in electrocatalysis is the conversion of carbon dioxide into valuable chemicals. And there is several catalysts for that. However, copper has been proved to be a very, very good catalyst to convert carbon dioxide into valuable chemicals. Of course, we'll discuss later that these chemicals will depend on the nature of the catalyst itself and topography of the catalyst as well. So three main reactions that's actually like moving around in these types of devices, that's very, very important. These reactions in both ways, like hydrogen reaction could be hydrogen evolution reaction or hydrogen oxidation reaction. If we are operating these three reactions in the reverse direction, this means we consume fuel, like hydrogen incorporated into fuel cell to produce energy, or combustion of hydrocarbon to carbon dioxide, or oxygen reduction also in fuel cell. If we operating in the forward reaction just to produce fuel, like in electrolyzer, we produce hydrogen, it's called hydrogen evolution reaction, or for the environmental issue, we reverse the reaction of combustion by converting carbon dioxide into valuable chemicals. So it's like artificial photosynthesis. We take carbon dioxide from the environment and we fix it into valuable product. Or water splitting, where we can get oxygen from water, also can get hydrogen as well. So this reaction, as I mentioned, is a fundamental in many devices. This types of devices, like I said initially, it's like one of them is metal air battery. Metal air battery, we have oxygen reduction reaction. That's during the operation of the battery, during the discharge of the battery, and oxygen evolution reaction, and that is during charging of the battery. So these very, very fundamental reactions. And the other side, the zinc dissolution and deposition, it doesn't need a very, very specific catalyst. But in this type of devices, oxygen reduction reaction and oxygen evolution reaction is very sluggish and need a very, very decent catalyst to operate the device efficiently. Also for the fuel cell, well, I am mentioning snapshot, but in reality, there's a lot of types of fuel cell. Also, there is a lot of types of metal air batteries. For the most common fuel cell is PEM fuel cell, or polymer electrolyte membrane fuel cell, that operate by hydrogen and by air or oxygen from air. So it's also operate oxygen reduction reaction and hydrogen oxidation reaction. So here the medium is acidic, and the catalyst, well, the commercial based catalyst is platinum, but as we know, platinum is expensive. That's why people need to know how to operate and what are the alternatives, and how can we get high efficient other catalysts that can economically viable. And these metal air batteries, in most of them operate in alkaline medium. Some of them, in case of lithium, it needs a kind of organic based medium, because lithium is active in aqueous medium. So either we use hybrid electrolyte or we use a brotic based metal air battery, rely on organic electrolyte. And the other one is the carbon dioxide reduction. This is not a galvanic cell. It's not producing energy. As I said, it is reversing back the carbon dioxide from the environment into a valuable chemical or a valuable product. And this can be a very, very fascinating future of our Earth environment. If we make this like a kind of practical, this can reverse what has been done to the weather or environment. So as a fundamental basis, we need to go through what is essential for the electrochemistry or electrochemical catalyst. It's actually electron transfer, electron loss and gain. So what is oxidation and what's reduction? Oxidation is defined as its loss of electrons. Loss of electrons means oxidation, and gain of electrons is reduction. And both processes occur during the operation of the electrochemical cell. So if we are teaching our students, or if we are introducing the topic to someone who is not in the field, the very, very fundamental thing he need to label in his mind what's oxidation and what's reduction. There is different way for that analogies, like Liu and Gear. So loss of electron is oxidation and gain of electrons is reduction. That's anomaly. The other anomaly is actually oil reg. Like oil, oxidation is loss, reg, reduction is gain of electrons. And in all cases, reduction happens at the cathode. So at the cathode, the reaction always a reduction reaction, and at the anode is always oxidation reaction. So always the anode is oxidation and the cathode is reduction. So when we go through the thermodynamic, we need to link between the normal chemistry thermodynamic and the electrochemistry. The electrochemistry, we have the potential, and the normal chemistry, we have delta G, and the relation combining delta G with the potential is delta G equal minus NFE, where N is the total number of electrons when we make overall reaction of oxidation and reduction, or anode and cathode. So if we assume we have a reaction that has delta G around minus 100 kilojoule per mole, This means the minus 100 kilojoule per mole will be minus NFE, and N is the number of electrons, Faraday is constant, and E will be the potential of the cell. So if you are developing a battery between two reactions, we can predict the potential of the cell. Also, in a reverse way, we can use the electrochemistry. If we measure the potential, we can calculate accurately the delta G of the reaction. That's very, very good avenue for measuring delta G, just measuring the reaction cell potential. We put the reaction in a cell and we accurately measure the potential. And if we know already the reaction, it's easy to measure the free energy. So if we look to the half reaction, one half is oxidation at the anode and one half is reduction at the cathode. And we'll learn later in the next slide that every reaction has its own potential. So it's called half potential. So half potential reaction for the oxidation and half potential reaction, half potential for reduction reaction. And together we make cell potential when we add them together. So in literature, all of the half reaction have been measured and tabulated. And in the standard form means the unit concentration and room temperature and 1 atmospheric pressure, and the value measured to standard reference hydrogen electrode. So when we look at, say, lithium ion plus electron giving lithium metal, the potential for this half reaction is minus 3.04 volt. This means this reaction is not spontaneous that way because the potential is negative. Because if we substitute it with the potential negative, this will make delta G positive. So this means reduction of lithium ion into lithium is very, very difficult. But if we look down this list, when we find a positive potential, it means this reaction is very feasible because its delta G gonna be negative. So when delta G is negative, the cell potential will be positive and vice versa. For example, fluoride is like to gain electron to form fluoride ion. So fluorine gas convert into fluoride ion very spontaneously. And this we know already, non-metals tend to gain electrons and metals tend to lose electrons. So if we reverse this reaction, lithium goes back into lithium ion. That's quite easy because the potential will be the opposite of this value. However, for the sake of fixing the IO back, and people working in chemistry and electrochemistry decided that the standard electrode potential will be placed as the reduction potential like that arbitrarily. But when we handle a reaction, we need to figure out if it is reduction, we use the equation like that. But if it is oxidation, we reverse the reaction, we also switch the value of the potential. So we mainly study the half reaction because it will be the unit when we build a full cell reaction, and the thermodynamic of half reaction defined on the absolute potential, its absolute value relative to hydrogen scale, and also at a standard condition. So these are very, very standard values. Potential scale can be shifted for convenience, like if we have other, reference electrode, then we can convert between reference electrode. However, the standard values are listed versus SHE or standard hydrogen electrode or reference hydrogen electrode. The cell voltage is calculated or measured as a combination between two reactions. So in the next slide, I will show how do we do that. So, well, if we have a coin that form from zinc and copper, or two different metals, iron and copper, or the Statue of Liberty where it's made from some different alloy, different metal, so it undergoes corrosion. That type of corrosion actually is a kind of a galvanic reaction where the more active dissolve. But how this happen? If we want to know how this happen, and if we assume that example where we have iron and copper, and we need to figure out if we have these two reactions, can we assume or can we predict which one gonna dissolve? Then we have iron reduction, same as came from the table, and copper reduction, and here we have the two potential. Then we need to assume one of them as a reduction and one of them as oxidation. We will assume and we calculate based on that. And if the value of the potential positive, then our assumption is a spontaneous valid. And if the value is negative, this means the opposite of our assumption will occur. So if we assume that, and after our assumption, the E of the cell, we need to have the E node of the cathode minus E of the anode. And we need to remember E of the cathode means the reduction. So it will be same as taken from here. But E of the anode is the one that we assumed it's gonna be oxidation. And this means we need to reverse that reaction. So if we did that for our assumption, and we got 0.36 volt, this means it's positive. This means that can be assumption that the oxidation will be for the iron and reduction will be for the copper. And based on that, we can, based on this value of the cell potential, we can get the free energy of the reaction. But before we get the free energy of reaction, we need to log this to this reaction, and we need to switch the one that's gonna be oxidation. But one step more we need to proceed. It is the equalizing the number of electrons, because the number of electron lost will equal the number of electron gained. When we do that, we'll find that the number of electron will be as a total, and then we can substitute in this equation and calculate the delta G of the reaction. And that is overall view how people calculate the overall potential of the cell. And here is some of the reaction that can be competing for each other. And how can we predict, is there any other reaction can be obtained or not? For example, this is the list of hydrogen reaction and different scenarios for carbon dioxide reduction. So there is a scenario that reducing carbon monoxide and methanol and methane and ethane and ethanol or propanol. So all of these can have different potential. And we have at the end here, the water formation from oxygen or oxygen reduction reaction. There is a gap between them. When we do reaction in electrochemistry, there must be one anode and one cathode, and the cell potential is the difference between them. If we assume in doing carbon dioxide reduction reaction, for example, we can see these values is very, very close to the value of hydrogen evolution reaction. So this means whenever we do carbon dioxide reduction, we'll have hydrogen evolution reaction as well on the same electrode. This makes some difficulty because we need the specificity of the reaction. We need it to focus on carbon dioxide reduction, whereas the other reaction on the other electrode is the oxygen reaction. So here is the role of the catalyst, how to make it selective for the carbon dioxide reduction and minimizing the hydrogen evolution reaction. So this diagram showed, based on the previous discussion in the two slides, we have a cell potential, for example, for oxygen, it's 1.23. If we adjusted this reaction at this potential, it's like an equilibrium reaction. Then if we need to force the reaction to go oxidation anodic, we need to shift the potential to higher value. So if we shift the potential, we force the reaction to go into oxidation. And if we decrease the potential, we force the reaction to go into reduction. So oxygen reduction reaction and oxygen evolution reaction operate only at a higher voltage than the one specified or the one at equilibrium. This is called overpotential. And the good catalyst reduce this overpotential. So at a lower overpotential, if we got higher current, this means this type of catalyst is very good. In the other side, for hydrogen reaction, whether hydrogen evolution reaction or hydrogen oxidation reaction, we note this point, which is equilibrium. There is no much gap. Here, there is a lot of gap. So this means this reaction is very difficult compared to this reaction. This means this reaction needs a very good catalyst compared to this reaction. So this measure value is called the overpotential. And we have here 4 reactions, like for oxygen, reduction and oxidation or evolution. For hydrogen, the same. The lower one is reduction and the upper one is oxidation. So if we making a fuel cell, we couple the oxygen reduction reaction with hydrogen oxidation reaction. And this will bring to us positive potential and negative delta G and spontaneous, and consequently can be used for producing energy, like in fuel cell. But if we used the other 2 reactions, this will be non-spontaneous and delta G is positive. So we need to drive this reaction to occur by applying external energy. It's like reversing the fuel cell or reversing the battery by an electrolyzer. We still need catalyst, but we need also energy to do that, to obtain oxygen from water and also hydrogen, or also we can apply for the carbon dioxide in this coming slide. So oxygen reaction, both evolution and reduction, and also carbon dioxide reduction. We note here carbon dioxide reduction reaction is also like a not easy reaction. It is very ambiguous and sluggish, need a very, very strong catalyst to obtain. So if we applying carbon dioxide reduction with oxygen evolution reaction, it's non-spontaneous and it need energy, but through that we bring oxygen from water and we convert carbon dioxide into a valuable chemical. But if we use this, that's a normal galvanic way. If we oxidize fuel like methanol and also reduce oxygen like methanol fuel cell. So any device couple oxidation and reduction reaction. If the output is positive potential, that's galvanic cell and we can use it as a source of power. But if the coupling of the potential is negative, this means it's non-spontaneous and it needs external power to proceed. But why we do that? Because it's gonna be valuable for us. It's fuel production. We produce fuel from carbon dioxide, which contaminate the environment. We also produce oxygen at the same time from water, which we can use in other applications. So how this is measured? We normally use like 3 electrode cells where we put the working electrode and reference electrode and the counter electrode. The working electrode normally is glass-based glass carbon electrode, and it is rotating because we do hydrodynamic. Hydrodynamic help us to measure the kinetics of the reaction. So we place our catalyst on this glassy carbon, and we start by measuring several like linear sweep voltammetry measurement. From the values obtained in this diagram, we can figure out the good catalyst. The good catalyst will lead to a smaller overpotential and will lead also to higher current. This is called limiting current, and it's basically like mass transport limited reaction. And it will increase, of course, by increasing the rotation of the electrode. So which is best for the catalyst? If you have like a catalyst, is its activity or stability or selectivity? Actually, all of them are important for us. Activity of the catalyst is very, very important. And selectivity, especially when there is more than one reaction is taking place, is very important. And stability or durability is also very, very important, because it's need to be sustainable. We need it to be long lasting. So we need different tools for measurement all of these merit of figures or activity based one. So for the kinetics of the electrode reactions, we rely on Butler-Volmer equation. And this Butler-Volmer equation is very big equation, but it's correlate the current with the exchange current density with the transfer coefficient that and also the number of electrons in the reaction for this constant, the over potential and the gas constant and temperature. This for the anodic term, and this for the cathodic term, for the cathodic reaction. And at a certain, like here, this equation can describe the whole range of the reaction, but we can specify this one by determining the range. So if you are exactly at the equilibrium, so this is just the equilibrium reaction. And if we shift by certain value of over potential in the anodic direction, so this equation will only apply for the anodic, and the cathodic term will be cancelled. And in that case, if we are before the mass transport value, this means we can apply approximation. It's called TOEFL approximation, where the equation is simplified as this one or this one, depending whether we are working on the anodic area or the cathodic area. So this can give us a way to measure the different parameters from this equation. So the most important parameter when we study electrochemistry is the exchange current density that can be depicted from the slope and intercept of the TOEFL, and also TOEFL slope itself, and also the current density given at certain over potential. Of course, the higher the current density and the lower over potential will be the most important of the catalyst. This means that catalyst will give us a very good values. Over potential and also this area. The current normally measured per specific area or geometric area, or electrochemical based surface area, which need a special measurement. So as I mentioned, the over potential need to reach a given current density, and we need lower over potential that produce this value or this amount of the current. So now we go to quickly to few of the reaction, hydrogen evolution reaction and carbon dioxide reduction. So again, to study the hydrogen evolution reaction, we use the rotating system where we use 3 electrodes, and we measure in presence of the catalyst and in absence of the catalyst, and we find that the hydrogen evolution catalyst is performing very well if it provide high current density and lower over potential. These different catalysts we measured, for example, chromium and aluminum and vanadium and cobalt and platinum and iridium. These are the best catalysts, and these are not good catalysts because higher over potential. But the most one that's non-precious, most are present range. So in some to understand the catalyst well, we need to study the mechanism, but I will skip the mechanism because of the timing. And we go here to this diagram, which shows that one important thing is the binding energy, the binding of the hydrogen to the catalyst itself. It doesn't need to be strong, very strong, or very weak. It needs a certain value intermediate, and that can produce a very good performance similar to platinum and palladium catalyst. And some like trials to prepare molybdenum disulfide, they prepared with very, very much controlled edge of the molybdenum disulfide. And this is the scanning tunnel microscope image shows the edge. And based on the result, they found that molybdenum disulfide showed lower overpotential and high geometric current density compared to the other catalyst. And also the exchange current density of the catalyst increased with the edge length. And this also a very, very specific result. Molybdenum disulfide mixed with molybdenum oxide, and when prepared as nanowire, it showed a very competing performance. It's not as much as the precious catalyst, but it's much better than the non-precious catalyst. So it's economically viable. So if we compare in general, the best catalyst for hydrogen evolution reaction are platinum and palladium, but the problem is the cost. And we have other catalysts, but they have either poor activity or they are inactive in or unstable in acidic medium. But the best so far is the molybdenum disulfide. It's inexpensive and it's stable in acid medium and very active. It is not as much as a precious metal, but it shows acceptable performance. And the carbon dioxide, as I mentioned, there is competing mechanism to produce different material, different product. But the problem is selectivity, and the selectivity will come with the proper catalyst. So as you can see here, the different catalysts can produce different product. For most of them, hydrogen produced because its potential close to these other compounds. But we can see here, we can have certain percentage of these compound depending on the potential. So at certain potential, we can get one more than the other. In addition to some catalysts can also change this scenario and make more selective material. This is the schematic of the device that is being used to like for carbon dioxide reduction. And at the end, I would like to just go through what we did. Like we explored the electrocatalysis, starting from the fundamentals, thermodynamic kinetics, and method for electrocatalysis research, and what are the most important parameters in the catalysis, especially in HER and carbon dioxide reduction. And here is some reference. And I would like to thank you very much for inviting me, and it's time for questions. Any questions?
Yes, yes, Professor Hassan. It's a very good lecture indeed. I just want to know that you told that molybdenum disulfide reduces the over potential. Why it is so?
Yeah, it's in the catalysis, the electrocatalysis over potential is like the reducing the activation energy in the normal compound.
Right.
So
right.
molybdenum disulfide, based on the mechanism, the different mechanism for this reaction, actually bind the hydrogen, the intermediate hydrogen, with the proper binding energy, neither very high or neither very low. That's very, very much suitable for the conversion into hydrogen. So the binding energy for that molybdenum disulfide is very similar to the platinum and the palladium. So it's like it controlled the mechanism of that hydrogen absorption on the catalyst and then conversion into hydrogen gas. That is number one. Number two is molybdenum disulfide as a catalyst, in addition to the critical value, which is the binding energy, it also can be prepared in a different way, either the 2D structure or one-dimensional structure or particle-based structure. And when they found that they increase the edge size, the edge length, they found that they get higher exchange current density because the edge itself is the location where the hydrogen absorbed.
Right.
So it controls the mechanism of absorption, desorption of the intermediate better than the other competing materials.
Okay, thank you, sir. Thank you.
You're welcome.
Okay, thank you, Dr. Fatih, for your well-delivered talk on the topic. The talk of Fatih Hassan involved the primary emphasis to introduce a tutorial overview of the electrocatalysis process and its potential involvement in critical clean energy and environment pathway. Clean and efficient energy storage and conversion via sustainable water and carbon dioxide reduction reaction have attracted considerable attention to address the energy and environmental concern due to the overuse of fossil fuel. Catalysis facilitate charge transfer and mass transfer at the interface between the electrode and electrolyte. It plays an important role in the performance, energy conversion efficiency, and providing sufficient performance and durability for these energy technologies. Understanding how the catalysis work is necessary to overcome the challenges of the processes related to water and carbon dioxide reduction reaction. Really well delivered. Dr. Fatih, thank you.
Thank you.
And
thank you very much.
Now the floor is handed over to Dr. Soumya to chair the next session. Dr. Soumya.
Thank you, sir. Good afternoon.
Thank you very much. Good afternoon.
Good afternoon. I am Dr. Soumya Biswas, Assistant Professor of Department of Chemistry, SMIT, chairing this session with Professor S.P. Singh. Thank you, Dr. Fatih M. Hassan, for gifting us an excellent lecture. Now we have our next speaker, Professor Ghanoshyam Bej. He is a professor in the Department of Chemistry. Am I audible?
Yes, sure.
So now we have our next speaker, Professor Ghanoshyam Bej. He is a professor in the Department of Chemistry at Northeastern Hill University, Shillong, India. Dr. Bej started his professional career as lecturer in Dibrugarh University in India in 1999. He pursued postdoctoral research as research associate in University of Texas at San Antonio, Texas in 2002-2003, and at University of Kansas from 2003-2004. Then he joined Northeastern Hill University, Shillong, as reader in 2006. He became associate professor in 2009, and currently he holds a position of professor since 2012. He is a member of TAIR, Teacher Associateship for Research Excellence Screening Committee, CRB DST, New Delhi. He is a guest editor, Current Organic Chemistry, Bentham Publications, subject expert, Union Public Service Commission, New Delhi. Professor Bej is an organic chemist, and his group works on asymmetric synthesis, solid phase synthesis, heterocyclic synthesis, synthesis of simple 1,2,4 trioxane systems, employing recyclable resin-bound organocatalyst to avoid chromatography technique for isolation and purification. His group has published more than 70 research papers in reputed international journals. Few of them are Chemical Communication, Organic Letters, Journal of Organic Chemistry, ACS, Sustainable Chemistry and Engineering, European Journal of Organic Chemistry, etc. Under his supervision, 10 students have received PhD degree and 6 research scholars are pursuing their PhD research. I like to welcome Professor Bej to our conference. Today's topic of his presentation, synthesis of 1,2,4 trioxanes and their efficacy against cancer metastasis. I request Professor Bej to deliver his talk.
Thank you, Chairman. First of all, this screen sharing is disabled. I don't know from the host. Can you make it enable screen sharing? When I'm clicking screen sharing.
1 minute,
just-
please.
Okay. Yes, I got it. Okay. Thank you. Thank you, Mr. Chairman, for very nice introduction. At the very outset, I would like to thank ACT as well as SMIT for giving me this opportunity to share our research work in this August gathering. And especially, I would like to thank Professor D.V. Prabhu, who is basically the engine of this ACT. And I was very fortunate to meet him in maybe year 2014 in his office in SBCSC, and I found that how hardworking and dynamic person he is. Thank you, sir, for being always there for ACT. And with that, so I would like to thank Professor Noyan Kamal Bhattacharjee for inviting me to present my work. This work potentially we are going to discuss about, although this title does not reflect much, but it is basically, we are going to talk about some synthetic derivative of artemisinin. Artemisinin, maybe I am sure that most of you know about it. This is a very versatile drug. So this is artemisinin. It's a natural product. Actually, it was isolated in China back in 1972. And you know, this molecule has got another distinction, is that the discoverer got Nobel Prize for that. So this molecule, as you can see, that this molecule is very interesting. That is, of course, besides the molecule, I want to tell another interesting thing is that this molecule was used for maybe 4,000 to 5,000 decades in China to treat fever. So this was isolated from a plant called Artemisia annua. So this Artemisia annua, that local population, this local tribals, they use this medicine when they have high fevers and all. And then when China took up that one, conscious decision that, okay, all the, medicinal plants available in China, they should, explore their, proper, they should identify that, what kind of mechanistic pathways or what kind of pharmaceutical properties they have scientifically. Then they found in 1972 this particular molecule, and it was basically, they found that active against malaria. So this, as you know, this malaria parasites, they were earlier treated with mostly nitrogen heterocycles, starting from quinine and so on. So most of them were nitrogen heterocycles, but in this particular case, you'll find that they had only oxygen heterocycle. And interestingly, this is, of course, a sesquiterpene lactone. Okay, it has got 15 carbon. That means you have 3 isoprene units in this molecule. So this is a sesquiterpene lactone, and this sesquiterpene lactone, later it was analyzed that this particular unit, which is shown by red color, this particular unit, which is called 1,2,3,4, 1,2,4-trioxane. So this particular unit is actually the pharmacophore unit, which is responsible for its activity. So this, as you know, that this, most of the natural products, they are, isolated from the plants or any other sources. their actually amount is very low. In this case also it is no different. Here it can be isolated up to 1%, that is only in China. So although this particular plant, Artemisia annua, it is available in my own campus itself in Nehu, but here I could not even find even zero, any artemission in. Okay, so it is 0% availability here. So that means that in China, in which locality this particular plant is there, so there must be having some kind of soil microbes, which is finally contributing to the formation of the secondary metabolites. As you know, this soil microbes, they used to form some kind of complex, which we call it siderophore. These siderophores are responsible for formation of different secondary metabolites. Now, in this case, here in Nehu, probably those kind of microbes are absent. As a result, despite having this plant, so we are not getting it. So that's why, because of this nature, they are, you cannot get artemisinin here. That means it is only localized in China. So entire market is controlled by Chinese. It is that. So as a result, its price is necessarily very high, although this molecule is very efficient for treatment of malaria. But problem is that its availability, because of its low availability, so its price is very high. And second point also, of course, it is there that this particular molecule, it has got solubility issues. That is another major issue for this molecule. Because as you know, any drug, if you want to have a drug, it has to be either soluble in water or it has to be soluble in lipid. But in this case, this particular artemisinin molecule, it is sparingly soluble in water as well as sparingly soluble in lipid. So that is biggest drawback of this molecule. As a result of that you need to give that dose, number of doses in a particular cycle, you will have to increase. Okay, because of its poor absorption, you cannot take it as a tablet. Because of poor solubility in water, you cannot give it as an intravenous injection. So as a result, that means you need to derivatize this molecule to either increase its lipophilicity or its hydrophilicity. Either way you can move. So that has been of course done. As a result, is overall cost is increasing, after every derivatization. So idea is that, can we make this simple pharmacophore, which is 1,2,4-trioxane, which can have almost equal efficacy to that of artemisinin? That is the goal for the scientists all over the world, and we are also trying a bit from our side. So this is, as I have already noted, that it is isolated from Artemisia annua. It is available in China, and it's of course antimalarial as well as anti-tumor. Now this is also another very interesting thing, because this molecule was used as an antimalarial drug, which is very efficient. And its interesting part was that almost all antimalarial nitrogen containing antimalarial drug, they used to have a lot of toxicity. But here in this case, toxicity was very low, almost nil. So that was the another advantage, because it does not affect normal cells or the host. So that is the advantage for artemisinin. So, but there's a reason why it happened. Because what happens is that this artemisinin molecule only works when you have high physiological concentration of iron. Because these malaria parasites, they used to have high physiological concentration of iron in comparison to its host. So it is activated only in that environment. That means high physiological concentration of iron only is get activated. So as a result, it does not affect the host. So that is the same case actually for tumor. Tumor, what happens? Tumor cells always they used to have a high iron concentration, tumor cells. Because what happens is that in tumor cells, actually they used to these tumors, they used to activate transferrin 1, okay, which allows the entry of iron inside the cell in a higher concentration. So as a result, in cancer cells also you have high iron concentration. So they have compared this analogy that in anti-malaria, malaria parasites have got a high iron concentration, and in tumor cells also you have got high iron concentration. If it acts as an anti-malarial, why can't it act as an anti-tumor? So then they tested it as anti-tumor and found yes, it works, and it does not have any toxic effect for normal cells. That is the most exciting part about it. That means on today's date, you can find no cancer drug which does not have toxic effect on normal cells. But artemisinin is one. But it has got a lot of problems, as I have already discussed. That solubility issue. One is the major issue. Cost is second issue. Because when solubility issue is there, you know that it will have lower plasma half-life. So it will have lower absorption. So those kind of issues will be always there. So that means your bioavailability is poor. You have poor bioavailability. As I have already noted that because of this, Professor Tu Yu, she got Nobel Prize for isolation of this compound. Now, this is the pharmacophore unit, which is responsible for its activity, be it anti-tumor or is anti-malarial. In both cases, it, modus operandi is almost similar. So, to improve the solubility issue, as I have already noted, that to improve the solubility issue, you can either make it more lipid soluble or you can make it more water soluble. Both way it works. So these are the two extreme examples. This is artesunate. What they did is that there is a electron ring in this molecule. As you can see, this is the electron ring. This carbonyl was reduced with sodium borohydride to alcohol. So that we call it dihydroartemisinin. Then this alcohol, you can make it esterification, you can make it etherification. Those are the common, ways to easily make it derivative. So this is the artemisinin. They have made it, dihydroartemisinin first, then they made it artesunate. It is basically artesunate, and this is another that hydroxy group was converted to a methyl ether, and you have ethyl ether as well. So those are like, this is to make it more lipophilic, and this is to make it more hydrophilic. So these are the atoms they did, and there are many such. And this is also another drug which may have got another issues, potential issues there for this molecule, is that when you have got this kind of ester and ether, then it undergoes metabolism inside the cell to give you again OH, which is dihydroartemisinin, which I told you. But this OH is a neurotoxin. This OH is a neurotoxin. So when that is another, disadvantage of making this kind of derivative, although it becomes more active in comparison to artemisinin, but it does generate dihydroartemisinin during the metabolic process, so making it neurotoxic. So that is a problem here. So what people did is that they wanted to get rid of this carbon-oxygen bond finally, and they converted it to carbon-carbon bond, which is pretty stable. It does not, breaks down out here. So that is completely removed. Okay. So this is basically, this is basically the mechanism how it works. You see, it reacts with the hemoglobin to break this bond, to make OH, and this is called carbon-centered radical. It makes a carbon-centered radical, and this carbon-centered radical basically binds with DNA, and then finally, it generates peroxyl free radicals, reactive oxygen species, and then finally it does its job by oxidative stress, DNA damage, apoptosis, and entire bunch of process it can carry it out. So interestingly, it is found that this artemisinin, this pharmacophore, 1,2,4-trioxane pharmacophore, it can bind with different proteins. That is like, it's binding, because as soon as it forms this radical, it can bind with various species. So this is the paper, it is 2015 in Nature Communication. They found that this malaria parasite Khalsa in the blood cell, then they hooked it with technique reaction to the, to cells, and then finally they added some diazides along with this one so that they can detect it very easily. That's a dye as well as biotin, and they have finally found that this particular thing, it binds with as high as 25 different proteins. So that means its mechanism of action basically in terms of molecular mechanism is very difficult to predict yet. So these are some of the derivatives which are already known for its anti-tumor activity. Suppose this is RT ether. If it is methyl and ethyl, RT methyl and RT ether. This was reported in 2007. Okay, this is as an anti-tumor. Similarly, this Udenberg et al., they were the first group to study this anti-tumor activity of artemisinin dimer. As you can see, that they have made a dimer out of it, and they found that cytotoxicity towards tumor cells with IC50 like 1.4 micromolar, which is pretty good. So then some other groups also, they found that this particular molecule artemisinin, so they found that they have got longer half-life, because this is another serious issue because of poor bioavailability. So because of poor solubility issue, their half-life, that means plasma half-life was very short. But in this particular molecule, they have replaced this carbon-oxygen bond with carbon-nitrogen bond, and they have found that it has got longer half-life and low toxicity. And finally, Posner group, who is the major worker in this area, they have desynthesized artemisinin dimers, okay, by putting some kind of spacer in between, and they have also noted, this kind of activity. Then Kim group, they have made a trimer out of it, okay, and they found that this compound is 20 times more active than Taxol against P388 cell lines, 20 times more active than Taxol. As you know, Taxol is very commonly used for breast cancer, but it is cytotoxic and it's very costly. So in comparison to that, it is cheaper, and it is in this particular molecule, they have found that 20 times more active than Taxol itself. So then they made dimers, trimers, different stuffs, and they have found that these compounds, IC50 value is, you see, 0.49 micromolar against multi-drug resistant cell line CEM ADR500. And where in comparison, this is, anti-tumor drug doxorubicin, which is 1.61. As you can see, it is, 3 times less, more than 3 times, more, active than doxorubicin itself. So now, ideally, major issue with breast cancer is that most of the time people fail to identify cancer in initial stages, and most of the time, and of course for other cancers as well, most of the time, people find it when it is in final stages, which we call it stage 4, right? So stage 4 means cancer has already become metastatic. It has gone to all parts of the body. So suppose here I am giving you, see this is the primary cancer position, colon cancer. Then when it becomes metastatic, it has gone to liver, it has gone to lung, it can go to any other part. So how it goes? Because these primary cancer cells, they used to enter the blood system, okay, and then finally they undergo seeding to other places, okay, by some mechanism. So then they become metastatic tumor. Suppose you can see this is the primary tumor. Then what happens? That it becomes angiogenesis takes place. That means angiogenesis means creation of new blood lines. You see, blood capillaries. You have got new blood capillaries. So this blood capillaries is going to the tumors, primary tumor sites, and as a result, they can enter to the blood system now, and because of that, it can, and go to any parts of the body where your blood artery reaches. So finally, it can, come out by extravasation, and again, it can, seed in another place. So this entire metastatic processes, it is found that there is a particular protein which is, we call it osteopontin. Okay, this osteopontin, it is expressed and secreted by numerous human cancer. So osteopontin protein expression is increased in a variety of cancer and reported to correlate with enhanced tumor progression and metastasis. So that means if you have, tumor, especially under metastatic stage, then you will see that overexpression of OPN will be there. Okay, so in OPN also there is a very interesting thing that full-length OPN, it is always required, because full-length OPN, what it does is that it in presence of a psychological, physiological amount of calcium, it works as a cell adhesive, okay, and which inhibits the tumor cell dissemination, okay. But it's, its splice variant, especially shortest splice variant C, what it does is that it, express in cancer cells, but it does not express in normal cells. So that means if you can detect OPNC, then you know that you definitely have cancer. So what we did is that we studied that 1,2,4 triaxon system for, osteopontin expression in MDA-MB435 breast cancer cell. It is actually triple negative breast cancer cell. That's why it is very difficult to cure it. So we wanted to study that one, osteopontin expression in NDA-MB435. So for that, we thought that why to go for artemisinin and its derivative, which are really costly, can we, because it is 1,2,4 triaxon system is there, that without remaining backbone, can we synthesize that part, simple 1 to 4 triaxons, and see how they behave. So here, there were some examples of synthesis of 1 to 4 triaxons, especially Sandan Singh, who is a retired scientist from CDRI. He worked a lot on, synthesis of 1 to 4 triaxons. Okay, there are a few examples of this kind of synthetic 1 to 4 triaxons. Interestingly, these 1 to 4 triaxons, they tried only for antimalarial study. That is the most interesting part. And they never tried for whether they can be effective as an anti-tumor. They never studied. Nobody has studied. Nobody studied this case. So we thought that why can't we study 1 to 4 triaxon as anti-tumor, synthetic 1 to 4 triaxon as anti-tumor. So why synthetic 1 to 4 triaxon as anti-tumor? The inhibition of tumor metastasis in cancer cells by artemisinin and their derivative has not been tested by OPN expression studies. Artemisinin as a drug is not cost effective due to poor natural abundance, and its derivation makes it even dearer. Anti-cancer efficacy of synthetic 1 to 4 triaxon has never been studied. Since many artemisinin dimers and trimers have shown better anti-tumor activity to their monomeric counterpart, synthetic 1 to 4 triaxon dimer trimers maybe have similar potential. So only a few libraries of 1 to 4 triaxon dimer trimers are synthesized so far. So that's why we undertook the synthesis of 1 to 4 triaxon. So for that, we took a naturally, isolated, that is citronellol. Okay. Then the citronellol, we thought that we can, manipulate this part, and as well as this double bond is there where we can make the triaxon system. There are two diversity points, as you can see. So where we are going to make the diversity. Okay. So here to start with, what we did, we took citronellol, then we simply tosylated 2 OTS, then sodium azide DMF, if you put it, then it becomes azide. Okay. Then you have got this double bond. You just put osmium tetroxide NMO to make it a diol, right? Then you go to that, we make it, in presence of hydrogen peroxide. It gives you this compound. In situ, it forms this triaxon. This triaxon now you link to any number of this olefin, okay, or this alkyne, because we have got the azide group, azide alkyne cycloaddition will take place to give you this kind of compounds. So, Mr. Chairman, how much time I have?
Sir, 10 minutes more.
Okay, thank you. So what we did is that we have synthesized this various, this kind of alkynes, various alkynes, and then we added this part. Okay, so I will not discuss about these things, because how we got a particular, because this is a mesodiastereomers, which is actually formation was controlled by restriction of conformation only. So then we took this particular thing that we wanted to make some sugar derived thing as well, because if you now this acetonide, as you can see, if you remove the acetonide, because this one is derived from fructose, and if you remove the acetonide ring, then it becomes highly water soluble. So we wanted to see that how it affects as well. So we made this kind of 1 to 4 triaxon derivatives. Okay. So I will not go for this analytical data, but here you come where we have got that this triaxons, it is a triaxon monomer basically. It's a one triaxon unit is there where we have manipulated only R and R1, what it can be, and most of them are aldehyde. Okay, so you can see out here is that this is the control. Okay, and when we started this one, and only two compounds, they only control the OPN expression to some extent. Okay, they 10G and 10K, they control the OPN expression to some extent, but other things could not control. Okay. So if you go to them, what we did is that we thought that, okay, can we make similar, trioxane and 1,2,3 triazole complex? Here we converted this into dihydroartemisinin, then we did propylation, then with benzyl azide, we treated a click reaction, then we got this compound. We wanted to compare this one with our synthesized compound. And then we have found that, you see, this is in case of this one, in artemisinin, it is like, OPN expression was around 0.8, but with DHA, as you can see, it is very good. It has come down to around 0.5 and at that point, but only problem in DHA is that it almost killed all entire cell because this beta-actin, presence of beta-actin was found to be very low. Okay, so then what, as I showed you my last slide, this slide, that only these two showed better activity than normal control. So we thought that, can we explore some other thing, dimers? Here we have made some dimers. Okay, this side also it is 1,2,4 triagonal system, other side also 1,2,4 triagonal system is there. Now I'll go here directly. Now as you can see it out here, that this is the control. Okay, so here you can see that where you have D, B, C, A. So here in most of the cases, you have seen that they are not, reducing the, OPN expression. Only 12B and 12L. 12B, that means meta-bromophenyl ring is there, and 12L means para-chloromethyl as well as methyl. That is a ketone system. So these two cases only it shows prominent behavior. Okay. So then we thought that maybe, because that benzene ring is there in between, because it is making some, system is too rigid. That's why maybe it is not giving us, good activity. So we wanted to change it, and we started with diethanol amine as this linker thing. So when we edit this diethanol amine out here with same groups only, no difference as such, but you will see here that here in most of the cases, you see, this is the control, and all the other cases, they are showing very good control of OPN expression. That means they have down-regulated the OPN expression to a great extent in this case. So then we thought that, okay, this is dimer. Can we move one step more? Then this is a very initial study. So what we did is that, I don't know what happened. Okay. So we synthesized some trimer, tetramer, and hexane. Okay. So this is we took trithanolamine, then propyl again same azide moiety only we have added, and here we have found that this particular unit where you have got a paramethyl phenyl group, so which has shown us very good activity. Now this paramethyl phenyl trimer, which was found to be very active, so we wanted to study its other parameters, that how it is working. So in this one, you will see that we studied that oxidative stress and apoptosis in ambient 435 and 231 cancer cells. You will see in this case, this is the control, as you can see, 13.82 plus minus 1.19. And when we have got this one 6.23, this is to calculate reduced glutathione level. Reduced glutathione level, it means it is showing the signal that this cancer progression is, it is going through apoptotic process. You see, this is 13, this is 6.23, and artemisinin, you see 16.73. That means it is much better than artemisinin in this case in 435 cells as well as in 231 cells as well. In this case, you see reduced glutathione level is reducing to a great extent, but zero activity as well as G6PDH activity both have found to be increased. That is basically to maintain to protect the cell from death. Because if this level is not maintained, then cell will undergo death. So that means it working both way to regulate the apoptotic process. I think there is a problem. Okay. Okay, so here you can see that we have studied some more things. That another very interesting point is that we studied this caspase-3, cleavage of caspase-3. Cleavage of caspase-3, that means caspase-3 actually gives you an idea that whether cell apoptosis is taking place or not. If suppose, if say, there is actually inactivated caspase-3 is there, and when there is a proteolysis takes place, then it becomes two parts and they dimerizes to make it activated. Okay, make it activated. So this cleavage of caspase-3 also indicates that it is, it is contributing the apoptosis of the cancer cells. If you see out here that this is the control and this is 50 micromolar 40, that means our compound, and this is artemisinin. And in this case only, in the middle one only, you can see that this cleavage of caspase is very evident, while artemisinin is not working, which is as good as simply control. And similarly, BCL2 also, that the beta cell lymphoma cells, so which also regulates, cell death actually. It sometimes works as anti-apoptotic, sometimes it works as pro-apoptotic, so that BCL control also, BCL2 also control the apoptosis. And in a case, it definitely, BCL2 also, it was cleaved out here in the middle case, as you can see, that means in both these cases, they have shown that, this 40 is, doing the apoptotic apoptosis. Okay, so I think I have some more data, but there is hardly any time. So overall, what I want to tell is that means it is not that artemisinin from natural sources can be effective, but we have established out here is that simple 1,2,4-trioxane, synthesized in the lab from simple starting material, they can be sometimes very interesting and they can show very interesting properties. And in this case, they are showing better anti-tumor activity than artemisinin itself. So with this, I would like to close today, and I would be happy to give any clarification if you require. Thank you so much.
Thank you, Professor Bej. So can you take few questions from audience? Any questions from audience?
Okay, I think it can be both ways. Okay.
Thank you, Professor Bej, for your excellent informative lecture. Your research work in your group will definitely contribute significantly to the development of 1 to 4 trioxane-based systems for combating against the cancer metastasis. We wish all the best for your future research. Thank you.
Thank you. Thank you so much. Thank you so much.
Thank you, sir. We will now begin the first technical session of the conference. This session will be chaired by Dr. Manoranjan Pandey, SMIT, and Dr. Mozam Ali, SMIT. I request both to kindly take over the session. Please, sir.
Good afternoon, all of you. Today, I will first call, and some guideline was there. How many time you have to give? So, good afternoon, all of you. In this session, we have allotted the 10 minutes and kindly try to complete. Yeah. So, all of you try to complete your part within the 10 minutes. So, first I will like to call Bisekanu Tatsu. Some pronunciation, I think. He is here.
Vishekanu Kotsu.
Yeah. Are you here, sir?
Okay.
Then we.
Is the first speaker here? Sir, so we will go for the next one.
Yes.
Okay,
So we'll
the next speaker will be B. More. Is the presenter here? Okay. So third one, Parita, are you there?
Yeah, Dr. Ali.
Yes, sir.
Yeah.
Maybe presenter right is not given to all the participants. That's why they are unable to respond. Just a minute, let me speak. Mr. Sani, can we give the presenter right to everyone for a moment for this 1 hour?
This may be one of the reason.
Mr. Sani, are you getting my voice? Just a minute, let me.
Yes.
Yeah, Dr. Ali, now they can unmute. The right given to everyone. That's why you can now start.
Okay.
Everyone can now unmute and everyone can share their slide now.
Okay, then start from first one.
Is the first presenter ready? Rishikanu? Okay.
Then we'll proceed to second one.
Yes, sir.
Mr. B. More is there. Sir, Nayan sir, is it possible? Immediately you share the phone number.
Doctor, you please go ahead. You can come back later on. No issue. You go one by one. You can go ahead.
Okay, Dr. Parita Basnet, presenter number 3. Are you ready? Dr. Parita. Okay, and
then we'll go the third one.
From 1 to 8.
Good afternoon,
Asa
sir.
Subba.
Good
Yes.
afternoon, sir. Am I audible?
Yes, you're audible.
I am presenter number 8, sir.
Yeah, you can go ahead, ma'am.
Okay.
Okay, so
sir,
we'll start with, yes.
Miss S. Kalyani.
Yes, sir. We
Okay.
are a team of 3 people. Dr. S. Kalyani is my supervisor. I am Prashanti presenting the paper, sir.
Okay.
Okay. Anyway, this is presenter number 8, right?
8, sir. Yes, 8.
Okay, no problem, no problem. You can go ahead. You get
Thank
10
you.
minutes.
Thank you.
for the
Yes, sir.
presentation.
Thank you so much. Sir, can
Okay,
I
all the way.
share the screen? Is that option available for me?
Ma'am, you can share your screen. The option has been allotted to everyone. You can share your screen.
Yeah. Sir, is my screen presented?
Yeah.
A very warm good afternoon to the gathering and our esteemed chairpersons of this technical session, Dr. Manoranjan Pandey, sir, and Dr. Muazzam Ali, sir. I consider it a privilege, sir, to be part of this 3-day international conference conducted at Sikkim Manipal Institute of Technology. This present work is carried out by myself, Ms. Prashanti, Assistant Professor, Department of Chemistry, St. Francis College for Women, Mary Naiji Kurian, Assistant Professor, Head, Department of Chemistry, Bhavans Vivekananda College, Hyderabad, under the guideship of our supervisor, Dr. S. Kalyani ma'am, Assistant Professor, Department of Chemistry, Mahatma Gandhi University, Nalgonda. Our work focuses on design, synthesis, and biological activity of a few novel PNA building blocks, that is peptide nucleic acid building blocks. Before I actually present the scheme for our synthesis, would like to throw some light on the valuable applications of PNAs. As mentioned here, PNAs are new biomolecular tools which have very wide range of applications. But usually we take inspiration from nature to synthesize a synthetic molecule. But these are not naturally occurring. They are invented by Peter E. Nielsen in the year 1991. So very recent advances we are working on, sir. And as mentioned here again, the activity of these amino acid derivatives depend on the configuration of the chiral center. So our intention in this work is to retain the chirality maximum. So we choose 2 routes to synthesize the same scaffold so that we can compare how much is the percentage of retention of this chirality. And this PNAs major application is they are antisense and anti-gene agents. They can be used in gene therapy. And one more challenge we face in the present day situation with antibiotics is development of resistance. These PNAs also possess this antimicrobial activity. So they are called as AMPs, antimicrobial peptides, which are actually new alternatives to the antibiotic threat we have. So these oligonucleotide peptide nucleic acids, they have combined properties of both peptides and the nucleic acids. But as chemists, we are more interested in their structure, and their structural study reveals that they are more closely related to peptides than nucleic acids. As I was mentioning about their synthesis, sir, they were invented in the year 1991. They were first synthesized, which are like actually DNA mimics. And these can bind very well a complementary RNA and DNA. Their affinity and specificity is also great. So here is also some literature survey which is talking about the applications of these peptide nucleic acids are as very powerful agents. And I've tried to put it in a nutshell, sir, of the 2 slides, what I'm presenting in this literature survey. They could be developed into gene therapeutic drugs. Their antisense activity is already reported in nerve cells, and it is demonstrated effective in Escherichia coli. These PNAs form very stable duplex hybrids with Watson-Crick complementary DNA and RNAs. They are chemically much more related to proteins than nucleic acids. But however, the amide bond in these PNAs are sufficiently different from that of our alpha amino acid peptide bonds. They are biologically stable and do not degrade by normal proteases and peptidases, which is of greater significance to exploit them as drugs. But however, though we are not experts in biology, there is one upper limitation which requires more research. They have limited diffusion over lipid membranes. So probably certain structural modification, if done, could make them suitable for treatment in eukaryotic cells. And here I'm also presenting some of the antibacterial activities reported with a specific kind of bacterial strains using these PNAs. Other than antibacterial activity, they have also been reported to possess antifungal, anti-inflammatory, and anti-cancerous activity. Here are some of these amino acid derivatives which have been synthesized already, which were our inspiration. And this is our proposed scaffold, sir, where we have taken an amino acid, both the isomers, and we try to retain the chirality. We are successful in synthesizing the scaffold and the derivatives, sir. So the scheme goes about like this. The amino group of the amino acid is protected using FMOC protection. After a series of reactions have been carried out, the protected amino acid was converted into an aldehyde. And this aldehyde is unstable. So it was immediately reductive aminated to give us the corresponding intermediate. This intermediate, again on sequence of reactions, yielded successfully the desired scaffold. And this scaffold was treated with a series of 10 different carboxylic acids to give us 10 different analogs, whose structures also have been characterized. So we are successful, sir, in synthesizing the scaffold and the 10 new analogs. Also, the characterization is done based on IR, proton NMR, C13, mass, and for few, we have even done chiral HPLC. I would like to add a point here, sir. As I mentioned, we have chosen 2 routes to synthesize the same scaffold. The reported route was giving 70 to 89%, and the yields were poor. The novel route is reporting more than 95% of retention in chirality, and the yields are best. So we also hope and pray that we still have, this is ongoing work, sir. So the docking studies and biological activities for the same have to be yet determined. Hope and pray we get good results. Thank you is a very small, these are the, I'm sorry, sir, these are the references which helped me actually to do my work and also make up this PPT for this seminar. And thank you would be a very small word. Thank you so much for the organizers who have given us this opportunity to be part of this prestigious seminar today. And I would also like to acknowledge my place of work, that is St. Francis College for Women, Hyderabad, which always encourages its faculty to carry on active research. And my work is incomplete and impossible without my supervisor's support, Dr. S. Kalyani ma'am, Mahatma Gandhi University, and this university where I am a research scholar. A big thank you to all the audience for their patience listening.
Okay. Ali sir, any question from the group?
Okay, thank you very much for the brief, timely presentation. You completed it within the time. Thanks for that. Now the presentation is open for questions. If anyone has some questions, you may ask. Okay, so in absence of any questions, we would like to thank you, and we will. Yes, sir. Sir, Pandey sir.
No. I'm
Anyone
not.
else?
Thank you so much, sir.
Okay, welcome. So now we would like to move to the next speaker, and the next speaker. Okay, do we have the first forum presenter present here?
Yes, good afternoon, sir.
Yeah.
Yes.
Sir, I am
Parinita.
Parita Basnet. Yes, sir.
Okay,
I am
Parinita.
Okay,
available.
so Dr. Parita Basnet is here with us now. So Dr. Parita, you may start your presentation, and the time limit for you will be 10 minutes. Okay.
Sure, sir. Thank you very much, sir.
Okay.
Sir, is this visible?
No.
You kindly share your presentation first. Yeah.
Sir,
we can
now?
go with the full screen. Yes, it's good. Okay.
Sir,
Yeah, go ahead. All the best.
Thank you very much, sir.
Yeah.
So, a very good afternoon to the respected convener, session chairs, all the distinguished guests, and my dear friends. I am Dr. Parita Basnet, and today's presentation is based on a small part of my PhD thesis. I have recently completed my PhD in nanochemistry under the guidance of Professor Dr. Somnath Chatterjee, and the topic is entitled Effect of Various Experimental Parameters on the Morphology and Photocatalytic Activity of Guanine-capped zinc oxide nanoparticles. So let me first start with a brief introduction of this work. Now, we know that photocatalytic activity of any nanomaterial is basically a surface property. Thus, it has been observed that the morphology possessed by the photocatalyst or the nanomaterial under consideration plays a crucial role in its photocatalytic property. Furthermore, it may be added here that the higher the surface area, more will be the photocatalytic activity of the nanomaterial. Now, the morphology of the photocatalyst may be tuned by controlling or modulating the experimental conditions as maintained during synthesis. Therefore, keeping these facts in mind, in this study, the role of experimental parameters in manipulating the morphology of zinc oxide nanoparticles was investigated. The experimental parameters being the method of synthesis, reaction temperature, reaction duration, pH of the reaction medium, the ratio of the precursors, and the nature of the zinc precursor. Furthermore, capping agent used for this synthesis was guanine. Now, the requirement of a capping agent in nanomaterial synthesis cannot be neglected as it controls agglomeration and even directs the morphology of the nanomaterials. Now, the choice of guanine in this study was based on two important factors. The first one being it is a biomaterial and hence it is environmentally benign. And the second reason is that it has a very high or very good absorption ability. It was for this reason that guanine was used as a capping agent in this study. Now, before moving forward, I would briefly like to explain the solid state and hydrothermal procedures which were used in this study. So this is the pictorial representation of the solid state method. In this method, in a mortar and pestle, zinc precursor was ground for 5 minutes, after which sodium hydroxide powder was added and the grinding was continued for another 15 minutes. The capping agent, that is guanine, was then added and the resultant was ground for approximately 50 minutes until a white paste was obtained. This paste was then transferred to a beaker using deionized water. The precipitate was collected through centrifugation, which was then washed thoroughly with deionized water and ethanol. The resultant was then dried in a muffle furnace so to obtain the zinc oxide nanoparticles. Likewise, this is the representation of the hydrothermal process. In this, to a solution of zinc precursor, guanine solution was added in a dropwise manner, and after addition, the mixture was stirred for 30 minutes. To this, sodium hydroxide solution was added dropwise, and the resultant was left under stirring condition for 2 hours. Afterwards, the contents of the beaker was transferred to a stainless steel autoclave and placed in a muffle furnace, which was maintained at 90 degrees centigrade for 3 hours. The precipitate was then collected, washed, dried, and or calcined so to obtain the zinc oxide nanoparticles. Now, I would like to show you all the designations and details about the experimental parameters used in this synthesis. SZNO in this case refers to the zinc oxide nanoparticles prepared by the solid state method. In this, the zinc precursor was zinc acetate, pH of the reaction medium was 7.5, the zinc guanine hydroxide mole ratio was maintained at 1:1:5. In a similar experimental parameter, HZNO was synthesized, but in this case, instead of the solid state method, hydrothermal method was used, wherein the hydrothermal temperature was maintained at 90 degrees centigrade with a reaction duration of 3 hours. In the sample designated as NZNO, all the experimental parameters are similar to HZNO, except in this case, the zinc precursor was zinc nitrate and not zinc acetate. Likewise, in PZNO, the zinc precursor used was zinc perchlorate. In case of BZNO, all the experimental parameters are similar to HZNO, except in this case, the pH was maintained at 12 by increasing the hydroxide mole ratio from 5 to 10. In case of CZNO, the mole ratio of guanine was increased from 1 to 3. In case of ZZNO, the mole ratio of zinc precursor was increased from 1 to 5. In the sample designated as TZNO, the temperature of hydrothermal treatment was reduced from 90 degrees centigrade to 60 degrees centigrade, while in case of DZNO, the hydrothermal duration was increased from 3 hours to 6 hours. Therefore, these 9 samples were compared based on their morphology and photocatalytic degradation activity against methylene blue dye. I would like to mention a point here that I have not given the XRD spectra, instead only the FEACM, EDX and application spectra have been given. So in order to make the comparison more precise or to make it more concise. Therefore, to sum up, these are the 6 different subtopics I will be covering in this presentation. So the first subtopic is the effect of synthetic approaches on the morphology and photocatalytic activity of guanine-capped zinc oxide nanoparticles. In this, zinc oxide nanoparticles were synthesized using the solid state method. The sample has been designated as SZNO and the other sample by the hydrothermal method, and the sample has been designated as HZNO. Figure A represents the FEACM image of SZNO, which shows that most of the particles have agglomerated as shown by the white circle, while some of the particles have formed quasi-spherical morphology marked by the red circle. On the other hand, the FEACM image of HZNO, represented in figure C, reveals the formation of quasi-spherical particles, very small but quasi-spherical particles. This means that the extent of guanine capping agent was precisely insufficient to adsorb throughout the surface of zinc oxide nanoparticles in the solid state method, whereas the hydrothermal method must have led to the proper disbursement of guanine throughout the zinc oxide surface and hence helps in controlling agglomeration. Figure B is the EDX spectra for SZNO and figure D is the EDX spectra for HZNO respectively. Now from the EDX spectra, it may be observed that the composition of zinc and oxygen in these samples is approximately similar, indicating the formation of proportionate zinc oxide nanoparticles through both these methods. Further observation is an unassigned peak that belongs to the gold coating during FEACM sample preparation. Now, these are the results of methylene blue dye degradation by SZNO and HZNO. In case of SZNO, as we can see in figure A, only 22% of adsorption, that is methylene blue adsorption, was calculated, while in case of HZNO, approximately 93% adsorption was observed. Now, this may be attributed to the highly agglomerated and lightly agglomerated structures of SZNO and HZNO respectively, which was evident from the FEACM images. Further, it has been previously reported that the adsorption ability of guanine molecule is quite high. Now, thus it may be inferred that the amount of glycine moieties adsorbed at the surface, guanine moieties adsorbed at the surface of the HZNO is higher than in case of SZNO. Likewise, the degradation of MB dye, that is methylene blue dye, by these samples may be explained. As I already stated, that photocatalytic degradation phenomenon, being a surface property, is directly proportional to the amount of dye molecules adsorbed at the surface. It is for this reason that HZNO exhibited a higher efficiency than SZNO due to the synergistic effect of smaller surface area of the nanomaterial and high adsorption property of the guanine moieties. Thus, in the subsequent comparisons, hydrothermal method was kept as a constant parameter. So, the next study is the effect of zinc precursor on the morphology and photocatalytic activity of guanine cat zinc oxide nanoparticles. In this study, zinc oxide nanoparticles was prepared using different zinc precursors, that is, zinc acetate, giving us the sample HZNO.
Please, Parita, maintain the
Yes, sir?
time.
Almost time.
Oh. So in this case, as you can see that the samples have been prepared using the zinc acetate, which I've already explained, that is HZNO. Figure A represents the FEACM image prepared by using the zinc precursor as zinc nitrate, and figure C is the zinc oxide nanoparticles prepared using zinc perchlorate. So here we can see that in case of zinc nitrate and zinc acetate, the morphology is quite similar. Only in case of zinc perchlorate, the morphology has changed, and it is because of the different affinities of the interfering ions towards the zinc oxide nuclei. So these are the results of methylene blue dye degradation. From these results, we can see that NZNO has a degradation efficiency of 99%, while PZNO only 90%, which is due to the higher specific surface area of the former as compared to the latter. So these are the results. The second, the figure C is the FEACM image of BZNO, that is the zinc oxide nanoparticles prepared. Yes.
Time is over.
Yes, sir.
So within 1 and 2
So
sentences,
thank you very
please.
much. So can I conclude from here?
Yeah.
Only a few lines. So from these experimental findings, what we observed is instead of solid state method, hydrothermal synthesis is a more efficient method. The second thing is zinc acetate as the precursor gave a photocatalyst, which is highly efficient. The pH should be neutral. 1:1 zinc to guanine ratio is more preferable, and moderate hydrothermal temperature and longer duration is favorable for preparing highly efficient zinc oxide photocatalyst. Thank you.
Okay, thank you, Parita.
Yeah.
Yes,
Thank
sir.
you very
Adi,
much,
sir.
sir.
Okay, close it. Now we'll call the next one.
Okay, is there any questions? I don't think we'll be able to take the questions, okay, this time. So because of time limits. Anyway, one question we can take. Anyone? We just have time for only one single question. Okay, sir. Then we can move to the next one, sir.
Yes. So,
Good afternoon, sir.
yeah, who is?
Sir, I am the fifth speaker, Suveksha Tamang.
Suveksha Tamang. Okay. So, Suveksha Tamang, you have to complete within 10 minutes of time.
Yes.
Okay. Start your.
Yes, sir. Sir, is my slide visible?
Yes. Just use slideshow, make it slideshow.
Yes, sir. A very good afternoon to everyone. My name is Suveksha Tamang. I am a PhD scholar in Department of Chemistry, SMIT. I will be presenting our paper titled Analysis of Dipyridine Dipyrrole-based Molecules for Solar Cell Application Using Computational Approach. So introducing the topic, growing energy consumption has increased the demand for generation of sustainable source of energy. So photovoltaic cells provide an efficient way for the conversion of solar energy to electrical energy. Recently, the fields have been shifted towards organic-based optoelectronic devices, especially the bulk heterojunction solar cells, because of their low cost, easy fabrication, along with reasonable efficiency. So these are the structures of the 6 proposed molecules. Basically, they are the derivatives of dipyridine dipyrrole-based molecules. The structure of these molecules have been studied along with their properties, and then they have been related to the power conversion efficiency in a bulk heterojunction solar cell. Moving on. These are the structures of the 6 molecules which have been optimized. The computation was carried out using time-dependent density functional theory with B3LYP functional and 6311GD basis set. So based on the theoretical analysis of the optimized geometries, their properties have been reported. And then these properties have been analyzed for the light harvesting efficiency. Moving on, this is the working principle of the bulk heterojunction solar cell. So usually a bulk heterojunction solar cell consists of a cathode, an anode, and then between the cathode and anode, we have an active layer. In the active layer, we have considered the donor molecule to be the 6 dp-dp molecules, and we have taken the acceptor atom as the PCBM. So what happens is when the solar light strikes the HOMO of the donor molecule, it excites an electron to LUMO, and then there is a generation of exciton, which will then break into electrons and holes, which are then going to the respective electrodes. So when electron moves from anode to cathode, they generate photocurrent from cathode to anode. These are the structural properties which have been studied for the 6 molecules. Here, the properties which have been studied are illustrated in the figure. D1, D2, D3, D4 are the bond length, and θ1 to θ5 are the dihedral angle. So we can see here that nearly all the bonds of the molecule from D1 to D4 are similar to 180. So this shows that carbon-carbon bonds are partial double bond character. And we can see here that from θ1 to θ5, all similarly in dp2, 3, and 6, they have deviated from planarity in θ5 because the θ5 values are not equal to 180. This can be attributed to atropisomerism. However, in dp-dp1, 4, and 5, θ5 value is also equal to 180. So we can say that there is a planarity in these molecules, so which will increase the electron conjugation and then will generally increase the charge transfer. We have also studied the electrochemical properties. The electrochemical properties have been studied theoretically, which have been listed in the table. This property defines the ability of a system to generate photocurrent. So the chemical potential values for the derivatives are lower than PCBM molecules. We can say that there is an easy commencement of electron. Also, the low value of chemical hardness indicates easy liberation of electron from the donor atoms, and electronegativity of PCBM is high, so we can say that it can attract electron from donor atoms. The optoelectronic studies have been studied in terms of E-gap. Here we can see that the low value in the figure, the low value of LUMO of acceptor than the donor, we can say there is we can say that it facilitates ICT, that is interstate molecular transfer. So the E gap has been calculated theoretically using the formula E LUMO minus E HOMO. These values of E gap for all the 6 molecules are very small. Basically, DP-DP2 has the highest E gap and DP-DP4 has the smallest E gap. This is the contour plots of HOMO and LUMO orbitals, which have also been completed theoretically. The HOMO and LUMO contours show that the capability of transferring electrons and holes for photocurrent generation. The HOMO, as we can see for all the 6 molecules, is localized over the central electron donor subunit. The contribution of electron-rich donor group, that is pyrrole, which is the central part of the molecule, is significant, especially in DP-DP3 and DP-DP6. The LUMO is more localized in the central part of the electron deficient region. The contribution of donor groups in the LUMO is negligible. This is the electrostatic potential map, which has also been determined theoretically. The blue colored region denotes the electron deficient region, whereas the red color is the electron dense site. The electron rich areas are located near pi bonds of aromatic regions, as is shown in the figure, and especially near nitrogen. However, it was found in the figure that nitrogen present in the pyrrole ring will act as donor atoms, thus they are considered to be electron deficient regions and are shown in blue color. The photovoltaic properties have been studied, open circuit voltage and light harvesting efficiency. So open circuit voltage is the maximum voltage which is available from a solar cell at zero current. It has been determined using the expression VOC is equals to E HOMO of donor minus E LUMO of acceptor. The higher value of donor and lower value of the LUMO of acceptor will increase the VOC, which is very good for efficiency in BHE solar cells. LHE is the fraction of light energy that has been converted to electrical energy, which has also been calculated theoretically. In the expression of LHE, the F is the oscillator strength. This is the plot of LHE versus VOC. The plot of LHE has been given in blue, whereas the plot of VOC has been given in red. DP-DP2 has the highest efficiency and DP-DP4 has the lowest efficiency. The trend is of the following order: DP-DP2 greater 3, greater 6, 4, greater 1, and then finally greater 5. So DP-DP5 has the lowest efficiency. Absorption properties have been studied. The table shows the value of E gap, lambda max, EX, that is the excitation energy, oscillator strength, transition, and then the transition percentage. Here in the figure, that is the plot, we can see that there is a single peak for all the absorption spectrums, and this single peak will correspond to HOMO to LUMO transition of electrons. The wavelength of all this peak lies in the range of 342 to 354 nanometers, which is in the visible region. So we can say that sufficiently large conjugation in these molecules have resulted in bathochromic shifts. So all of these peaks are lying in the visible region. So in conclusion, we can say that all of these proposed molecules are eligible for the use of PHF photovoltaic cell as donor atoms, and they show great and efficient electron injection to accept a PCBM. Thus, all the 6 proposed DP-DP derivative molecules generate high photocurrent and thus have high LHE values and are promising candidates for donor molecules in BHA solar cells. This is the paper that has been published. We have published it in the Journal of Computational Electronics. Thank you.
Okay, thank you. You have
Okay.
completed in time. So any question from?
Thank you, Suveksha.
Thank you, sir.
In time. Okay, so if you have, the house is open for discussion. If you have any questions, then you're welcome. Okay, so okay, Suveksha.
Yes, sir.
Just the figure before the conclusion. Can you show it? Since we have time, you completed it before time, so I'm just.
Yes, sir.
Yeah, so I was wondering about the units on the left hand side. What is it? This is absorbance, right?
Yes, sir.
And this here, this 1.4 into 10 to the power of 5.
Yes, sir.
Yes, this is it okay?
Sir, I can't hear you, sir.
No, the unit on the left hand side, the y-axis.
Yes, sir.
So you see 1.4 into 10 to the power of 5.
Yes, sir.
Yeah, is it okay? That's what I'm asking.
So the unit is atomic unit.
No, the unit, not the unit. The numbers there, 1.4 into 10 to the power of 5. 1.2 into 10 to the power of 5.
Yes, sir.
Is it okay?
It is okay, sir.
Okay, that's what I want. Okay, any more questions? Okay, thank you, Subeksha, for the presentation. So we'll move to the next speaker. Pandit, whom should we call now?
Now, just Asha Subba is there.
Okay, the next Asha Subba, presenter number 4. Are you present? Are you there?
Or B More. Navnita Sarkar.
Yes, sir. Yes, sir, I'm present.
Okay,
Navnita.
presenter number 6 is present. Okay, so
Yes.
you can go ahead with your presentation.
Okay, sir. Yes.
And the time allotted to you is 10 minutes.
Yes, sir.
Okay.
Okay, sir. So, good afternoon to one and all. Today, I, Navonita Sarkar, along with my partner Sharnak Roy, is going to present on the topic that is DFT and molecular docking studies of a set of bispyrimidine dihydropyridine derivatives as melatonin receptor agonists. In the current scenario, we all have known that due to COVID-19 pandemic, people are thrown behind the four walls of the room. Thus, they had been spending most of their time alone due to social distancing. The recent surveys have also shown the exponential rise of people suffering from depression and sleep disorders. The main objective of our project is to design some bispyrimidine dihydropyridine derivatives and study its activity against melatonin receptor MT1, which controls our circadian rhythm. Now, in this slide, we will know how we fall asleep and how insomnia is caused. First of all, the darkness stimulates the pineal gland to release the melatonin hormone. This hormone then goes and binds to the MT1 receptor. Because of this binding, the guanine protein, they get activated. As it gets activated, the alpha unit dissociates from the beta and gamma unit. And this dissociation is catalyzed by the enzyme GTPase, which converts guanosine triphosphate to guanosine diphosphate, thus releasing energy. Now, this alpha unit, it activates the enzyme adenyl cyclase. This enzyme converts adenosine triphosphate to cyclic adenosine monophosphate. So, as the concentration of cyclic adenosine monophosphate increases, it goes to the regulatory subunits of protein kinase A. As it binds to it, it cleaves out the catalytic subunits, thus changing its nature from inactive to active. Now this catalytic subunits goes and binds to CREB. CREB is the cyclic response element binding protein. Now, as the name suggests, it needs to be bonded to something. It binds to Cre. Cre is the cyclic response element. The Cre, they are previously bonded to PER1 and PER2 genes, which controls our sleep, our circadian rhythm. As CREB gets binded to Cre, these genes, they get activated and a person falls asleep. Now, a person who is suffering from insomnia, the melatonin secretion is not very high, and therefore this entire cycle do not take place. What we do is that we introduce a ligand. Such a ligand which will bind to the MT1 receptor will activate this entire process and the person can fall asleep. So moving on, The question will always appear that why choose the bis-pyrimidine dihydropyridine as the ligands? This is because several other drugs like secobarbital and butabarbital were used for treating insomnia. If you have noticed, there is one thing in common, that is the barbituric acid. This compound is known to give very good hypnotic, sedative, and antidepressive-like behavior. So our motive becomes to design the molecules using the barbituric acid. Therefore, in this slide, the skeletal structures of all our derived molecules are illustrated. Next, we start with the DFT studies. The molecules are first optimized using the B3LYP6311G-DP basis set. This is done to attain the most stable configuration structure. So after the optimization, we need to check whether our computational work has been taken place correctly or not. So we check the vibrational investigation. In this slide, there are some computational and some experimental data for BPP3 and BPP6, where the values are quite near to each other or are quite the same. This highlights the fact that our experimental data is backing up our theoretical data, thus stating that our computational work has been taken place correctly and can be taken for further studies. Now, we need to understand the distribution of the electron density of our molecules. So we conduct the MESP, that is the molecular electrostatic potential. This is an important parameter to check for the electron density. It helps us to distinguish the most electrophilic and nucleophilic sites of a molecule. Therefore, in the two pictures given here of BPP3 and BPP6, we see that the blue atoms are the nitrogen atoms, and they are the region of in the region of blue, thus stating that they have low electron density. Thus, they are most electropositive potential and will have strong attraction. But over the red atoms, that is the oxygen atoms, they have high electron density. Thus, they have most electronegative potential and strong repulsion. Now, after this, in this slide, the MESPs of all the derived molecules are given. Now, from the next slide, my friend Sharnak will talk about the docking studies.
Thank you, Nabonita. Now, before docking, we first have to know the active site. That is where our ligand should be bonded and show its agonistic behavior. In this picture, there are 3 amino acids which constitutes the active site, a catalytic triad, that are glutamine 181, phenylalanine 179, and asparagine 162. Next slide. Thus, to analyze the interaction between ligand and the target, we carried out molecular docking. And it is a procedure where a ligand binds to a protein and the lowest binding energy is taken. The lower the binding score, the more stable is the molecule. Next slide. Henceforth, the docking study is conducted. It was then noticed that the 2 ligands, BPP3 and BPP6, has given us the best docking score, that is minus 10.6 kilocalorie per mole. Surprisingly, when compared with the docking scores of secobarbital and butabarbital, our molecules have tended to give us better results. Next slide. Now, we have to check the binding interaction of the ligand to the active site of the receptor. All the molecules present in this slide have bonded with all the amino acids of the active site depicted in pink color, which contains the best binding energy molecules, BPP3 and BPP6 also. Next slide. But in this slide, the bonding interaction of the ligands are with either of 2 amino acids of the catalytic triad. Next slide. Navnita, next slide. Thus, by concluding, we can say the optimization of the molecules was carried out, and then the higher data were verified by the experimental data. And it was also observed that the ligands tend to give pretty good docking results, out of which BPP3 and BPP6 gave the best docking score. Therefore, these molecules can be sent for further clinical trials and for further investigations. Next slide. These are our references from where we gathered all the knowledge. Next slide. Navnita, next slide. We are thankful to Amity University, Kolkata for allowing us to carry out this project. We would also like to extend our gratitude to our Professor Dr. Bandita Datta ma'am and Dr. Joydeep Bishya sir for their utmost guidance and support in completing our work, which have helped us in gathering a lot of knowledge, and we came across a lot of information. We would also like to thank the organizers of SMIT to offer the opportunity to present our work. Thank you so much.
Okay, thank you to both the presenters. Okay, you are just in time. Okay, no problem with the time. Okay, now the house is open for discussion. If you have any questions, you may ask. If anyone has any questions,
Yes.
you may ask.
Hello. Are you hearing me?
Yes.
Yes, sir.
Yes, I have one question.
Yes, sir.
You have used 6 ME, that is protein, for your
Yes.
molecular docking
Yes.
study,
Yes,
right?
Yes.
Have you done the bonding study with molecular docking study with their native ligand? Because you have written the bonding energy score is minus 10 point something for your pyridine
Yes, sir.
dihydroderivative, and what is the binding energy for the native ligand? What is the native ligand for this protein? What were you selected the protein?
Sir, the native ligand was JEY.
Yeah, JEY. What is the name of that ligand?
Sir, I think it was N dimethyl, sir. Sir.
That is something acetamide, right? One
Yes,
one
sir.
is
Yes, sir.
indole
Yes, sir.
3
Acetamide.
ethylene
Yes, sir. It was
acetamide
acetamide.
derivatives. What is the binding score for the acetamide? It is equal to your proposed derivative or proposed ligand, or is more or less, or
So it was when we have checked for the that inhibitor, I think it gave us little bit less score.
little
Lesser
bit
score.
less score?
Yes, sir. Little bit less than our ligands.
Okay, and your proposed ligand binding with the same amino acid which is giving the bonding interaction with the native ligand, or your derivative or your proposed ligand giving the binding interaction with the different amino acid?
No, sir. The binding interactions in this case, like we have mentioned, that this is the catalytic thread of the receptor, where it will show the agonistic behavior. So our
Yeah, it
ligands.
is showing the agonistic behavior. I agree that, because your ligand is showing the minimum energy. I'm just asking you your ligand showing the hydrogen bonding interaction with the same amino acid which is showing the native ligand, because
Yes, sir. Yes, I understand. With our inhibitor. Yes, sir. I understand. Yes, sir. It is showing the same interaction. The hydrogen bonding with asparagine, glutamine, they are showing the same interaction.
then what are that amino acid? Name of the amino acid? You have not
Sir,
mentioned that. You have not
yes, sir.
mentioned that name of the amino acid.
So the amino acids are the asparagine, phenylalanine, and glutamine.
Asparagine, phenylalanine, and glutamine. Okay. Okay, thank you.
Thank you, sir.
Any more questions? Okay, then we should move to the next one. Okay, Pandey sir, we'll move to the next one. Sir, can you hear me? Okay, so the oral presentation number 6 was just concluded, and now we have some more presentations. So, okay, anyone present who would like to give the presentation now?
Yes, sir.
Okay, what's your name?
Kanchan Singh. Kanchan Lata Singh.
Oral presentation number 7, right?
Yes, sir.
Okay, Kanchan, now you may start with your presentation.
Yes.
You'll get 10 minutes for the presentation, okay?
Okay, sir.
Okay, all the best. You share your slide. I think you haven't shared your slide. Please share your slide presentation. I think we have lost. Okay, I think there is some problem with the uploading. Okay, so Asha Shubha, are you there? Asha, are you there? Yeah, so you can upload your presentation and you can start. So presentation number 7 will start after this. You try with the presentation.
I think Asha volume is less.
Yes, we cannot hear you, Asha. First you upload your slide, your presentation.
Hello.
Yes. Who?
Sorry, sir. Sorry, sir.
Kanchan Lata.
Yes, sir.
Ali sir.
Yes, sir.
We think Kanchan Lata will give the time to Kanchan Lata.
Okay, sir.
Asha, you wait.
Okay, Kanchan, your time will start now. Okay, so you'll get
Okay.
10 minutes. Yeah, you can start.
Okay.
Asha, you wait. Huh.
Okay. Good afternoon, everyone. First of all, I would like to thank you, all of you, for giving me this opportunity. I am PhD from Deen Dayal Upadhyay, Gorakhpur University, under the supervision of Dr. Mrs. Afsan Siddiqui. And at present, I am assistant professor at HRPG College, Khalilabad. Today, I am going to present one of my paper The topic of my paper is physicochemical characterization and antimicrobial activity of mixed ligand complexes of antimony third with 3,2-hydroxyphenyl, 5,4-substituted phenyl pyrazolinates, and N-aryl dithiocarbamates. Yes, the interest in the chemistry of main group metal antimony third arises from their toxic nature up to varying extent. The trivalent antimony complexes have been found to be more toxic than their pentavalent complexes. So as you know, a common concept in ancient Chinese medicine was to use poison against a poison. As you know, the complexes of antimony compounds with nitrogen, oxygen, and sulfur donor ligands have been an active area of research due to their wide applications in various industries, agriculture, and medicines. Organoantimony compounds have received considerable attention because of their significant fungicidal, bactericidal, chemotherapeutic, and biological activity. The antimony drugs are still the most effective treatment for a number of diseases. For example, stibamine, ethylstibamine, and antimony fifth sodium gluconate are used for the treatment of all forms of leishmaniasis and kala-azar. In the formation of mixed ligand complexes, we use two ligands. First ligand is 3,2-hydroxyphenyl 5,4-substituted phenyl pyrazolinates, which is nitrogen oxygen donor ligand, and the second one is N-aryl dithiocarbamate, which is sulfur donor ligand. The pyrazoline ligand are used in agriculture as catalyst, as agrochemical fungicide, and as a potential antimicrobial agent. And the N-aryl dithiocarbamate are used as a potential antiviral agent, antifungal agent, and as a catalyst. So here, the ligand pyrazoline was synthesized in two steps. The first step, first of all, a dark yellow thick mass of chalcone. Here, chalcone was obtained by the reaction of orthohydroxyacetophenone and benzaldehyde. And in the second step, the chalcone is refluxed with hydrazine hydrate, and after refluxing and cooling, the solution finally get the ligand 3,2-hydroxyphenyl 5,4-substituted phenyl pyrazolinates. This ligand has been characterized by elemental analysis, molecular weight measurement, and spectral studies. The second ligand, N-aryl dithiocarbamate, this is prepared by the reaction of aniline with carbon disulfide in the presence of ammonium hydroxide. This N-aryl dithiocarbamate are also commercially available. Here, the dichloropyrazoline antimony third has been prepared by the reaction of benzene solution of anhydrous antimony third chloride with sodium salt of pyrazolene in 1:1 molar ratio. The synthesized compound has been characterized by elemental analysis, molecular weight measurement, spectral studies. This synthesized compound are found to be antibacterial and antifungal activity, and this is a potential antimicrobial agent. And next one, this compound in antimony third chloride, when both the chlorine atom is replaced by pyrazoline ligand, then the antimicrobial activity of this compound is increased. This both the compound, this compound is formed in 1:1, and this is in 1:2 molar ratio. Here, our aim is to designing and building system with specific and novel features whose property could be for beyond the simple sum of functionalities of the single entities. So, for achieving that, here we are preparing the mixed ligand complexes by the reaction of dichloropyrazoline antimony third with ammonium salt of parazoline in 1:1 molar ratio. All the synthesized compound here are characterized by elemental analysis, molecular weight measurement, and spectral studies. This compound is screened for their antibacterial, antifungal, and antiviral activity. This synthesized compound are found to be good antiviral activity, and here these are the spectral data which this compound is in the next here chloro antimony third dichloroparazoline is also screened is also react with ammonium salt of N-aryl dithiocarbamate in 1:1 molar ratio. Here in this compound there are two parazoline ligand are attached, and there is one N-aryl dithiocarbamate attached. So here it can be concluded that the complexation of substituted antimony third moiety with biologically active pyrozoline ligand result in increased activity of these complexes. It appears that when chlorine in chloroantimony third dipyrazolinates is replaced by sulfur containing N-aryl dithiocarbamate, there is increase in antimicrobial activity of these complexes. This already confirmed that the antimicrobial activity of these complexes arises from pyrozoline moiety, and antimicrobial activity increased when chlorine atom is replaced by N-aryl dithiocarbamate moiety, so that the synthesized compound may be used as a multidisciplinary prodrug after calculating their cytotoxicity. So thank you.
Yes, sir. Ali, sir. Thank you for completing within a time.
Okay, thank you, sir.
Now the time session is for the question. Anyone would like to ask the question? Please ask any question from your sides. No one? Ali sir, can we proceed for next one?
Yes, sir.
Yes, sir. Yes, sir. Asha Shubha is here. Number 4.
Okay, now Asha Supa is ready.
Yes, sir. Yes, sir.
Please, Kanchan Lata ji.
Yes, sir. Are you happy,
No,
sir?
first Kanchan Lata will cut.
Number 4.
Yeah. Okay. This she will. Now, 1 minute. Acha, Asha Subha, can you
Yes,
share
sir.
your screen, or I have to
Yes.
share your screen?
Sir, I will try, sir.
Okay.
सर यहाँ से नहीं हो रहा है ऐसे सर
Okay,
आपसे
okay, okay, I'm trying.
Sir, are you hear me, sir?
Yeah.
Am I audible, sir?
Just see the screen is visible.
Yes, yes. Yes, sir. Yes, sir. Yes, sir.
Okay, then you tell me the one I have to change the page. Okay.
Okay, sure, sir. Sure, sir.
Sir, Ali
Yes,
sir.
sir. Yes, sir.
Okay.
Okay. Very good afternoon.
Huh.
Very good afternoon, one and all. I'm here to present my paper topic on assessment of selected spring water in rural areas of Sikkim, and this is the part of my study research work. In the research, I am doing the entire Sikkim for spring water, but I'm presenting only the part of my study. The next slide.
Yeah.
This is introduction. Availability of safe drinking water is the basic need and plays a significant role for the development of better quality of human life due to its existence of its natural and unique properties. As we all know that pollution of drinking water is a global public health problem and pose a risk to human health. In fact, contaminated water sources has become a cause of concern as it is directly related to the health index of population in community. According to World Health Organization, we have seen that approximately 1.1 billion globally consume unsafe water, and nearly 88% of diarrheal disease are attributed to those polluted water, sanitation and hygiene condition. So in this challenging era around the world, drinking water should be free of pathogenic microbes and harmful metal. It's also most essential to access the quality of water and to reduce the risk of threat in public health. So safe drinking water is indispensable in life, and hence acceptable safe supply of water must be available for the various purposes to the public. As we have seen, even in India, yearly 37.7 million populations are suffered due to waterborne disease, and nearly 1.5 million deaths of children due to diarrheal disease only. So we have to assess a safe and quality of water for drinking purpose as well as other domestic purpose. So next slide, please. So study now the study area. For our study, we have selected rural areas of West Sikkim, where spring water used as their main source of water for their various purposes like drinking, irrigation, as well as other domestic purposes. And those water in those selected areas, their supply of water, which is from spring water, are totally untreated. Even we have seen in those selected area, there is lack of maintenance and hygiene system, as well as the population, those who are residing in those selected areas are unaware about the treatment and water contamination, which can cause human health. These are the our study area which we have selected in West District of Sikkim, like Rohtak, Sikkim, Boigune, Pipali, Sisne, Mabo, Resi, Leksip, and Naya Bazar. The next slide, please. Sir, back. Before this slide, sir. Sir, next slide.
Next one, no?
This one. Sir, anyway, materials and methods. For the material and method, we have collected spring water samples from West District of Sikkim. For phase 1 and phase 2, we have segregated our study in 2 phases, phase 1 and phase 2. A total of 54 water samples we have collected in phase 1 and phase 2 respectively during monsoon, post-monsoon and pre-monsoon season in the interval of 4 months a year. So in our study, we have analyzed the collected water samples based on chemical and bacterial analysis. For those analyses, we have collected 1 liter of water sample for chemical analysis and 500 ml for bacterial analysis. And after this collection, we have analyzed our collected water. For chemical analysis, we have used instrumental method like ICPMS, inductively coupled plasma mass spectrometry, and membrane filtration method for bacterial analysis. Sir, next slide. So this is the result of chemical analysis which we have observed in phase 1 and phase 2. In phase 1, we have observed calcium in highest percentage in monsoon, followed by pre-monsoon and post-monsoon. In phase 2, we have observed calcium maximum in monsoon season, followed by pre-monsoon and post-monsoon. Similarly, magnesium in pre-monsoon, followed by monsoon and post-monsoon in phase 1. And in phase 2, maximum concentration observed in pre-monsoon, followed by monsoon and post-monsoon. Similarly, iron in monsoon, followed by pre-monsoon and monsoon. And in phase 2, monsoon, we have observed highest in concentration, followed by pre-monsoon and monsoon. So, sir, next slide, please.
Yes.
Okay, sir. This is the bacterial analysis. Here we have detected, or we have isolated different bacterial species in phase 1 and phase 2. And here this picture shows that the highest percentage of bacteria which we have isolated is E. coli, that is 24.1% in monsoon season of phase 1, followed by Klebsiella, Cytobacter, Salmonella, Proteus, Pseudomonas, and Aeromonas hydrophila. Similarly, in phase 2, we have isolated highest number of percentage of bacteria, that is Klebsiella, that is 26.7%, followed by E. coli, Cytobacter, Pseudomonas, Shigella, and all. So next slide, please. This is for pre-monsoon and monsoon. Also, we have isolated highest percentage of Klebsiella and followed by E. coli, Cytobacter, Acinetobacter, and all. Similarly, in phase 2, we have isolated highest percentage of Klebsiella, E. coli, and Salmonella, Cytobacter. Next slide, please.
Yeah.
So this is the part of conclusion. In conclusion, I want to conclude that in our study, we have detected chemicals in water sample of West District, that is iron and manganese. We have observed iron and manganese in almost all the water samples beyond the limit. Whereas other than iron and manganese, like cadmium, chromium, nickel, they are all within the limit. However, the bacterial contamination in water sample, in all the collected water samples, we have isolated. So this study reveals the essential policies are to be needed and create for proper water management, sanitation and hygiene system in every individual to prevent the existence of human health risks and access quality of drinking water in the community of Sikkim. Hence, the study on the basis of this nature is further required more extensively. So next slide, please. And these are the reference which I have reviewed and to carry out my study. Next. Thank you to all the dignitaries present here and all team of organizing teams. Thank you so much, sir.
Okay, thank you, Asa. Anyone would like to ask the question? Ali sir, proceed.
Okay, any questions? Okay, so we can move to the next one. Thank you, Asa, for the presentation.
Thank you so much, sir.
So next stage.
We have only 2 more presenters. And
first and Biseka Kanuo and Kotsu. And second is B. More.
they are not present, sir.
Both of them?
Yes, sir.
Then we can.
Thank you, sir.
Okay, then we'll stop it.
I think they won't come.
Okay, so we are finished with the first technical session.
Yeah.
Okay, we thank all the presenters. Now we would like to hand it over to Ashwin.
Yes.
Thank you, sir.
Okay.
We will now begin the second session of the invited talk. This session will be chaired by Professor Prem Mohan Mishra, ACT, and Dr. Ramesh Sharma, SMIT. I request both to kindly take over the session.
Okay, we'll start the next invited talk, that is session 2 at 2:30. I think probably we have 8-9 minutes left. I hope the first speaker, Dr. Sapnali Hazarika, has already joined. Still, we will start at 2:30 as per the time schedule.
Good morning, Sudhakar Babu.
Good morning, sir.
How are you?
Fine. How are you?
I'm also fine.
Hello.
Okay, wishing the function a grand success. Good afternoon to Prabhu, sir. And
Yes.
all our members.
Premol Mishraji, good afternoon.
Good afternoon, sir. Good afternoon, sir.
Good afternoon, sir. Good afternoon, sir. Is it any break? No presentation is there?
3 minutes only. Only 2 minutes. After 2 minutes, we shall start new session.
Okay.
What about the Omicron, sir? Sudhakar Babu, sir.
Fine, sir.
What about Omicron in your state?
Our university?
Omicron.
Omicron, no, there is no impact. One case in Anantapur.
Oh, only one? Okay.
No, one. In AP, there are 2 cases. In Maharashtra, in your place?
No, I am in Bihar. Bihar, 0.
Bihar. I think Prabhu, sir, in Maharashtra, what is the situation, sir?
Few cases are there.
2 cases, sir. Okay. You please take care. Take all precautionary.
Yeah.
All are requested to take a booster dose, precautionary dose.
Yeah.
Booster dose, you make one appeal to all members to take the dose. Huh?
Yes.
Yes. The most important, better environment and health is most important.
So what is going on, Sudhakar Babuji?
So everything works a very tight schedule, academic schedule, because of there is a scare atmosphere existing in Andhra Pradesh. So simultaneously on online and offline classes are going on.
Okay, okay.
Online. So now, right now, third semester and first semester. First semester, no admissions in most of the universities due to COVID situation. Now third semester is going on, PG level.
Okay, thank you, sir.
Yeah.
Now
Okay.
we are ready for the next session.
Yeah.
Okay.
This is invited talk session 2. There will be 2 speakers. This session will be chaired by Professor Prem Mohan Mishra and Dr. Ramesh Sharma. May I request Prem Mohan Mishra sir and Ramesh Sharma sir to take over the session.
Yeah. We are ready, sir. Ramesh, you have joined?
Sir, please start, sir. He is joining, sir. Please start, sir.
Yeah. Should I start? Nanji, should I start?
Yes, sir. Please go ahead.
Oh, okay. Very good afternoon to all the dignitaries, resource persons, participants, organizers. First of all, I would like to thank our President, Professor Brajesh Pare sir, and General Secretary, Professor Devi Prabhu sir, for giving this opportunity to Nayan Kamal Bhattacharya ji to organize this NCCT 2021. I would also like to thank Rajanesh Grewal, Honorable Vice Chancellor SMU, and Director Mr. GL Sharma ji, Director SMIT, to give permission to NK Bhattacharya sir to organize this event. And I'm also thankful to all the team SMIT for organizing this ceremony in a very good way. This is invited lecture session 2. And we have 2 resource persons. First is Swapnali Hajarika and second is Santiago Gomez Ruiz. So first of all, I would like to introduce the first speaker, Professor Swapnali Hajarika. She is Principal Scientist and Group Leader of Chemical Engineering Group, Engineering Science and Technology Division. She is also Coordinator of Center for Petroleum Research, CSIR NEIST, Jorhat, Assam. Swapnali Hajarika obtained her MSc degree in chemistry with specialization in physical chemistry from Dibrugarh University, Assam. And after completing PhD degree from NEIST, she joined as junior scientist in Chemical Engineering Group in the same institution in the year 2005, where she is now working as principal scientist and group leader of Chemical Engineering Group, Engineering Science and Technology Division. She is also the coordinator of Center for Petroleum Research, and she established Industry Contact for Collaborative Research through signing MOU with almost all petroleum industries of northeastern India. Her research interests include polymer engineering, composite, nano-composite materials, membrane science, adsorption study, biochemical reaction engineering and mechanism, modeling and simulation, QSAR, QSPR, etc. She has completed 15 R&D projects as principal investigator funded by DST, MOEF, CSIR, etc. She has guided nearly 15 PhD fellows. 5 have been completed and 10 is ongoing. She has published more than 50 research papers with average impact factor 4.8 and more. She has also 74 conference papers, There are 2 books, 8 book chapters to her credit. She has developed 3 technologies and 2 have been already transferred to the industry for commercial production. She has visited Czech Republic, Spain, USA for her collaborative work. She has received various awards such as National VICAL Award in Chemical Engineering from IICHE 2015, Best Presentation Award in Indian International Science Festival 2019, Best Oral Presentation Award in ChemCon 2014, and Best Performing Women Scientist in Research and Development for 3 times at CSIR NEIST. She was a Fulbright Fellow under Women in Science program in 2013-2014. So we can see that she is doing real science. She has done research which can be commercialized, which can be patented, and which can be collaborated with the industries. So I should say one line for Madam Swapnali Hazarika: failure never overtakes if determination to succeed is strong enough. And she has done a tremendous work in the field of chemistry. And I invite Professor Swapnali Hazarika, Madam, to grace this occasion with her research work.
Chairman sir, thank you for your nice introduction. So let us share my slides. Is it visible?
Yeah, it's visible, ma'am.
Yeah. First of all, good afternoon, everybody. At the very beginning, I want to say that this SMIT has done a tremendous job for organizing this conference. I am grateful to the organizers for giving me this opportunity to present my work in this wonderful conference. I especially thankful to my friend, Professor Nayan Kamal Bhattacharya. He has contacted me for this invitation. So I am really thankful to whole SMIT team from the bottom of my heart. So nice. Now I want to start my presentation. The title of my presentation is Design and Development of Membranes for Different Applications. Yeah, this actually, if you gone through the membrane already, then you can say that membranes is a selective barrier, but it not necessarily a solid. It can be a liquid medium also. So they can separate 2 components in 2 phases, and using this membrane, it makes the separation of the component in a mixer possible. So actually membranes that was originated in 1748, that was the period of progress in membrane science. Then it developed a lot in 1949, and then from 1949 to till now it is developing, and if you go to a quotation from a membrane initiator, he is Professor Enrico Drioli. He is the director of Institute of Membrane Technology, Italy. So you can see what optimistic way he has given his opinion on this membrane. According to him, the earlier membranologists were very optimistic about the possibilities of membranes, but results achieved today are sometimes beyond their expectations. So this is the optimistic comment from one of the initiator, the Professor Enrico Drioli, that the results obtained in these days from membrane research, those are very beyond the researchers' expectations. That's why these membranes are now applied in many industries, from food and pharmaceutical, fine chemicals to petrochemical industries, and everywhere membrane is important. So we are working in this challenging area. So in my today's lecture, I just focused what we have done in this area at CSIR NIST. We have a small group working in this area. So we have tried our best to give something for the society as well as for the country. So from our knowledge, we have developed our product as well as processes. So these things only I want to focus here in these presentations. So if you consider, membranes are four types depending on the pore size of the membrane, and you can say the molecular weight cutoff. It generally membrane cannot work under the gravitational force, but it is always on pressure dependent, and it works only depending upon the molecular weight cutoff. So if a microfiltration membrane, its molecular weight cutoff is from 90,000 to 6 lakhs, and this type of membrane can permeate virus, microvalent ion, monovalent ion, water, etc. And it can reject the bacteria or suspended solids. As ultrafiltration membrane, you can see that virus and bacteria, suspended solids, it can reject, but water, monovalent ion, and multivalent ion, these things can permeate through this ultrafiltration membrane. And nanofiltration membrane, now researchers are working on this type of membrane. Its molecular weight cutoff is very less, 150 to 230 nm or 230 only. So this nanofiltration membrane can reject multivalent ions, virus, bacteria, and suspended solids. So for separating lot of compounds, we can use this nanofiltration membrane of molecular weight cutoff 150 to 230. And reverse osmosis, you all know that reverse osmosis for any water production plant, we can use reverse osmosis membrane, and these membranes are already in the market. So if you use any water purifying plant, small plant, household plant in your home, then those things you are reverse osmosis membranes only. So the membrane can work. One membrane can, you say this membrane is maybe polymeric membrane, maybe ceramic membrane, or maybe liquid membrane. This membrane can work either by dead-end filtration or by cross-probe filtration. So it is easy to separate or easy to purify the molecules using the membranes. So what is our work in CSIR NIST? Our work is we can design and develop membranes from polymers. We have done only polymeric membranes, that is based on commercial polymers. Sometimes we have functionalized some novel materials. Then we can design the membrane. Here we have designed and membranes for various applications. What are those applications? Our membranes we have already applied for gas separation work, for racemic resolution. Racemic resolution means isomeric separation. Two isomers we can separate in our using membranes. So wastewater treatment also it is used in oil and petrochemical industries, or if or for any industry for their effluent treatment. Reactive separation also we can use, or we can we have developed our membrane for separation of biomolecules from plant extract, and also for recovery of organic solvents. Suppose in some petrochemical industry they have some plant, there are some very less amount of organics are there, so we are developing membranes for the separation of organic molecules from their process effluent. Actually, membrane-based process separation processes are economical, safe, and eco-friendly. That's why nowadays industrialists are very much interested to use membrane technology for their separation plant. And always membrane is a pressure driven process applicable for separation of dissolved component. So but the thing is that how we can design the membrane. So membrane, for designing a membrane we need to know the molecular weight of that particular compound. After knowing the properties of that compound which to be separated, then we can design a membrane for that specific separation. For that we have to design we have to dissolve the polymer in a suitable solvent. After suitable solvent means we have to establish the solubility parameter of a polymer in a solvent. From the solubility parameter concept, we have to choose the suitable solvent for dissolving a polymer. Then we can cast the membrane using some small device or in glass plate. Then evaporation, then we have to choose a coagulating solvent for dipping the membranes, and that is called coagulation bath. Then after coagulation we will get the solid membrane. That solid membrane we can use for a specific separation, and if that solid membrane will not work for some particular compound, for separation of particular compound, then we have to go for another technique that is called interfacial polymerization technique. That technique, using that technique, we can develop a thin film on the on a support membrane. Then after getting the solid membrane, we have to go for characterization. Actually, for this type of membrane characterization, you need a sophisticated instruments or sophisticated instrumental laboratory that is there in our institute. So it is easy to design and develop membrane at CSIR NIST. We have to characterize the membranes in terms of pore size, in terms of morphology, thermal properties, zeta potential analysis, because we have to know the surge effect on the membrane. What is the surge behavior of that particular membrane? And then contact angle, we need to know the membrane is whether membrane is hydrophilic or hydrophobic. Then water permeability we have to know, then surface area, etc. Actually, for characterizing these techniques, we have lot of equipments we have required. Those are SAM, TEM, XPS, FTIR is small equipment, then zeta potential analyzer, then contact angle measurement instrument, then BET surface area analyzer. Everything we have required for characterizing these membranes. Yes, before, as I told you, what are the steps of the membrane? If you can see, for designing a particular membrane, lot of steps are involved, and those are selection of membrane material, we have to select the membrane material, then development of functionalized material. Sometimes we have to functionalize the membranes, then characterization of functionalized material, then selection of solvent. As I told earlier that we need to select the solvent from the solubility parameter concept. Then establishment of phase diagram. You see, we have to establish the phase diagram because we need to know in which region the membrane liquid solution will form a solid surface. That we need to know. Actually, there are metastable, the single phase region and two phase region, and in between single phase and two phase region, there are one region is there, that is metastable region. Only on at that metastable region, solid membrane will form. So for developing a membrane, we need to establish the phase diagram. Phase diagram, three-phase diagram for that particular polymer, solvent, and coagulant. So, and then after establishing the phase diagram, so the design of membrane is over. Then characterization of membrane we have to do. After characterization only, we have to go for application study. For which application this membrane is efficient or suitable. So design of after that, for suppose bench scale work is succeeded, we have successfully completed the bench scale work, then we need to design a membrane device for large scale separation. So that is called design of membrane module. We need to design a membrane device for large scale separation. And for designing a membrane module, we have to do for some design and simulation work from engineering point of view, then development of experimental prototype, then application of membrane for large scale separation, and simulation and modeling. These are the steps for designing a membrane. In our laboratory, we have considered these compounds for these materials for as membrane material. Lot of polymers we use for polysulfone, polyether sulfone, polyvinyl alcohol, polyvinylidene chloride, etc. And also these novel compounds, cyclodextrin, calixtrin, then remarsh, carbon nanotubes, graphene oxide, reduced graphene oxide, sometimes mesoporous and microporous materials, and cellulosic materials, of course, because we have used some cellulosic material from our local resources. So these materials we have used. Sometimes functionalization needed, we have done functionalization work. After functionalization, we have impregnated the functionalized material in on membrane, then the performance is very good. I will just show you some applications which we have done in our laboratory. First one is membranes for racemic resolution. Racemic resolution means we have separated enantiomers from a racemic mixture. So as you all know that why it is required, enantiomeric separation is why required. You all know that it is all drugs and pharmaceuticals. There are two types of enantiomers. One is effective for a particular disease, and other has some side effects. So we need to separate the bad isomer. And we have successfully completed our work. This is for separation of enantiomers. For this enantiomeric separation, we have designed our membrane from some novel materials like carbon nanotube, and sometimes we have combined the carbon nanotubes with reduced graphene oxide. Sometimes we have combined the carbon nanotube with carbon quantum dots. So these membranes we have developed. This is carbon nanotube, and this carbon nanotube membrane. Carbon nanotubes we have functionalized here, and after functionalization we have made a thin layer on a support membrane. Then this thin layer will this thin layer has worked very well for separation of isomers. And these are some characterization results. Only this is FTIR characterization for single wall carbon nanotube or functionalized single wall carbon nanotube. And also these are same image. You can see the difference of functionalized and single and non-functionalized carbon nanotube. And this work we have recently published in very reputed journals, and also we have patented this work. Similarly, this CNT partially reduced graphene oxide based membrane we have developed for chiral separation. This is the reduced graphene oxide functionalized single wall carbon nanotube composite we have prepared. And this is from this reduced graphene oxide functionalized single wall carbon nanotube, we have prepared the membrane using interfacial polymerization technique. For actually interfacial polymerization technique, we have applied to form a polyamide layer on our support membrane. And this is the polyamide layer. Polyamide layer works very well for separation purposes. It is in nanofiltration range membrane. So we have used this membrane for separation of beta hydroxy alpha amino acids. We have completed for 4 beta hydroxy alpha 4 beta hydroxy alpha amino acids for isomeric separation. And while designing a membrane, we need one disadvantage is for all the membrane. One disadvantage is that is anti-fouling fouling behavior. Membrane pores may block during the application test. So we have worked to develop anti-fouling membrane. Suppose the membranes or will not block during the application test. So while developing an anti-fouling membrane, we need to increase the hydrophilicity of a membrane. That hydrophilicity or hydrophobicity of a membrane can be determined by contact angle measuring instrument. So if the contact angle is less for that particular membrane, water contact angle, then the membrane is hydrophilic, and if it is more, then it is hydrophobic. So we have determined the water contact angle for our developed membrane, and you see after addition of functionalized nanomaterial, the water contact angle increased decreased to 49 degree from 89 degree. Earlier, if we used non-functionalized material, then it was 89 degree, and if we used this type of graphene, reduced graphene oxide nanomaterial, then water contact angle, it decreased to 49 degrees. 49 degree. That means if you use reduced graphene oxide carbon nanotube nanomaterial, then the fouling behavior of the membrane it will decrease to a larger extent because the membrane is hydrophilic. So these are some characteristics of XPS results. I have shown these things because we need to know how we have characterized or how we have developed our membranes. So these are some results of for our particular separation for chiral separation or enantiomeric separation membranes. And this is, you see, pH versus zeta potential curve. For this, depending on the streaming potential behavior of the membrane. So this is established. Membrane is surged membrane, and these are XPS results of some membranes. You can verify whether all components are present in your membrane or not. Those things we have verified with analyzing the membrane samples by XPS analysis. So these are some of our same data, scanning electron microscopic results of our membrane surface. These are a view of some membrane surface, and these are cross-sectional view of our developed membrane. So you see this from this pore size, you can see that the homogeneous pore size we have obtained in our membrane. So these are cross-sectional view. Cross-sectional view also you can see how nicely the pores are distributed in the membranes. So this is the image of the membranes, and this is AFM image. By using AFM image, we can see the surface roughness of the membranes, because roughness is very much important. If membrane surface is rough, then more absorb it absorb more molecules. So this is very much important to test the surface roughness of the membrane. And these are some permeation experiment. Actually, for this chiral separation work, for process from the point of process development, we have to study a lot of many factors. Suppose we have to optimize the process conditions. So those things also we have done because process development study we have to do, because to establish the membrane behavior in larger scale. So for different molecules we have done the experiment for 8 hours, and you can see the HPLC results. HPLC results. This is suppose this is L isomer and this is R isomer. Initially, you see this is racemic compound, L isomer and D isomer, and after membrane treatment, this is L isomer decreases and D isomer increases. This is the HPLC chromatogram, and you see how we have achieved the result of 99% enantiomeric excess using our developed membrane. This is for L-tyrosine. Tyrosine, we have separated the isomers of DL tyrosine. Then this is the small peak is L, and this is D isomers. This you see this is B is initial sample, our initial sample P, that is called fit solution for membrane separation experiment, and this is after permeation, after 8 hours permeation experiment, after 8 hours membrane treatment. Then this is the result, 99% enantiomeric excess value we have achieved. So, but thing is that as a chemist, we need to know how this works. What is the mechanism behind it? Why one isomer is rejected by the membrane and one isomer is permeated through the membrane? Because isomers have same molecular weight cutoff, right? So we need to know the mechanism. So for establishing that mechanism, we have studied the DFT analysis, density functional, by applying density. This DFT analysis we have done for interaction energy. We have calculated for different molecules, L isomer and D isomer separately. We have calculated the interaction energy value between individual isomers and membrane material. Then we have established a three parameter model. This is the three parameter model. If you see this model, you can get the picture how membrane will work. You see, with one isomer, membrane material interacted more. So another isomer, actually that isomer with the membrane material and isomer, it forms hydrogen bond. So hydrogen bonding interactions are there in this molecule. So three parameter interactions model we have established for this separation, and this work is also published in a reputed journal. And then next one is that is our chiral separation membrane, and next one is for separation of dyes from textile industry waste For this also, we have developed our membrane for separation of methylene blue, crystal violet, and rhodamine blue. For this work, we have functionalized the graphene oxide with some nanomaterial we have used here. This is called graphene oxide based membrane. This base polymer we have considered as polysulfone. On polysulfone surface, we have functionalized the graphene oxide. Then graphene oxide, using graphene oxide, we have developed a thin film on the surface of polysulfone. Then similarly, we have characterized all characterization technique we have done, and the material is membrane is very much suitable for separating these three dyes. So this work is also published in a reputed journal. And then another work, this is we have developed our membranes for biomolecule separation. You all know the demand of T-catechins. So T-catechins, some compounds are there: epicatechin galate, epigallocatechin galate. So catechin, these things. So this is a challenge for separating all the T-catechins. So we have developed our membrane for separating these T-catechins, and we have successfully completed our work for separation of epigallocatechin galate. Epigallocatechin galate, for separation of epigallocatechin galate, we have designed a membrane using ionic liquid. Using these two ionic liquid, we have used for developing the membrane, and in this work we have used our local clay material. First of all, we have exfoliated the clay material. Then for this exfoliation, we have used ionic liquid for this exfoliation. Then that organoclay, that functionalized ionic liquid functionalized clay, we have used as our membrane material. So same thing, and interfacial polymerization work we have done on the surface of our developed membrane. Then that polyamide layer we have formed on the surface of polysulfone membrane. Then this polyamide layer will work very efficiently for separation of epigallocatechin galate in aqueous solution. We have studied the pH behavior also because it is aqueous solution. So this is work is for epigallocatechin galate. We have completed the work, and for other catechins, suppose epicatechin galate, these things the work is going on. Again, as you told that I'm the coordinator of this Petroleum Center for Petroleum Research. NIST Jorhat established a Center for Petroleum Research, Center for Petroleum Research in February 2019. So this 2 year we have established collaboration with all the petroleum and oil industries. And for them, actually, they have assigned us the job to develop suitable process for treatment of wastewater. And so we have developed a membrane for separation of some organics like methanol and acetic acid, and also wastewater treatment. For you all know that in Assam Petrochemical Limited, they have methanol plant, and they have some acetic acid containing process effluent. So we have done the work for them, and we have developed our membrane for separation for recovery of methanol from less than 3% solution. So this membrane this work we have given, this results we have given to Assam Petrochemical Limited, and also this membrane we have transferred, this technology, this membrane we have transferred to Dark America, one acetic acid production company in USA. We have transferred the technology to them also. So recently we have established the collaboration work with Numaligarh Refinery Limited for the treatment of phenolic wastewater using our very cost-effective process technology. So the work is going on. The work is in final stage. So that is this is the NRL sponsored work. For actually they have some crude and also they have some oil in crude. So they have given us the job to recover the oil from their sludge, solid waste. Then we have to separate it, and this is the separated oil using our process. And you see this is water content, and this water also contains ppm level oil. So we need to separate that oil in ppm level, and they need the water, clean water for reuse. We already have given it to them. So this is another work with oil in the with NRL, and also we have done this work using the pipeline sludge of Oil India Limited. So gas separation membranes we have developed for carbon dioxide separation, that is patented work. And you all know that how NH2 group works with carbon dioxide. That actually that established process we have used in case of our membrane, and we have developed membrane, that is a patented membrane. Work is going on. So now those are the basic things. Only after developing these membranes in bench scale, we need to do the pilot scale work for giving the technology in technology for application in large scale. We need to design membrane module. These are our membrane module, membrane device we have designed and fabricated here, because this is needed. These modules are needed for large scale separation. So these are our some of our membrane module. This is membrane making machine. You see flat sheet membrane. We have flat sheet machine in our NIST laboratory, membrane laboratory. This is hollow fiber machine. We can design and fabricate hollow fiber membrane also. This is fiber like membrane, like this. These are hollow fiber membranes, and these are flat sheet membrane prepared in our laboratory, and these are hollow fiber membrane module for large scale separation. These are the specifications of our designed membrane module. You see, if I invite you all, if you have time or if you are interested with this work, then you please visit our laboratory. You can see the facility and you can see our work, how we can design or how we can develop, how we can prepare the membranes in our laboratory. And so somehow we have transformed our work to the technology level. And this is membrane technologies developed at CSIR NIST. This is dimolecule separation technology we have developed using these hollow fiber membranes. These are the product, and this is the process the work in 200 liter level. These are the these are the setup for pilot scale work. These facilities are also in our laboratory. We have membrane processing unit, and this is the another technology we have developed using our membrane technology for separation of biomolecules. These are the ultimate biomolecule. This is called oxyresveratrol, and from their waste product we have developed some fuel briquette or composite board also. This is transferred to Kerala based company only, and one production company of oxyresveratrol in India. So this is dye technology. We have developed this technology also using our hollow fiber membranes. This technology also we have transferred to Guwahati-based company. So these are our ongoing projects. 7 ongoing projects are there under me. So our future plan and challenges are product development. In a new or improved customized membrane, we can develop customized membrane, and the process development for membrane-based process or integrated process. We can develop integrated process for separation of any material, value addition, and environmental care, and a human resource development. So this 5 years we have achieved something. These are our development. We have patented some process and product, and also published some papers, produced PhD students, and we have some master students also. So I want to acknowledge this sponsoring agency, CSIR, mainly CSIR, DST, DBT, MOEF, and recently Department of Chemicals and Petrochemicals, NRL, ONGC, and Oil. They have sponsored some project, and our present director, Dr. G. Narohari Sastry, and of course SMIT, and all other distinguished persons and participants who are present here in this online online international conference. So my thing is that you say, this is actually, I want to say, you give us job, you give us job, we can develop membrane for your design. You can give any any job for separation of any molecule using membrane. We can develop according to your interest. So this facility or this expertise is with us. So we can design and develop customized membrane for you. And at last, some of our eminent personality, they have visited us, our membrane laboratory. This is my group. And recently, Dr. T. Ramaswamy, ex-secretary of DST, he has visited and he has appreciated us for our work. And also after that, Dr. Professor Samir Kumar Brahmachari, ex-DG of CSIR and secretary of DSIR, he also visited us. He also appreciated our work. And last year, some eminent personality, they have visited our laboratory. They have tweeted our work in their individual tweet. So those things actually encouraged us a lot. So at last, thank you, and membranes for a sustainable future. We are committed to work to develop membranes for a sustainable future. So thank you all. I think I have taken 5 minutes more, right?
It's all right, ma'am.
Okay. Any question?
Sir. Sir, you are muted, sir.
Mr. Sir, muted.
Mr. Sir, you are muted. Mr. Sir, please unmute yourself first.
Sorry. Yeah. Any question from anyone? No. If no question, then thank you, ma'am, for your
Thank you, sir. Thank you.
very stimulating speech in very lucid way, in very small sort of time. You have compiled all the parts of this membrane science, and we got a lot from your speech, starting from design to preparation, characterization, applications in different fields of chemistry and other department of science. So actually, I'm very delighted to hear your lecture, and I hope our participants are also. And I'm sure your lecture will bring new insight for current researchers, because your work is direct application based.
Yes.
And it will be beneficial for the society, for the scientific community, and humanity as well. So I wish you thank you. And I would also like to give you trouble to deliver more lectures in our programs in future.
Thank you, sir.
I can understand that you are very busy.
I'm ready. I am ready, sir. I'm ready. You please contact me at any time. I'm ready.
Yeah. But your lecture will be beneficial for our new generation.
Yeah. Thank you, sir. Thank you very much.
Yes. Thank you again, Swapnali Hazarika. And now I am sharing this opportunity with Dr. Ramesh Sharma ji.
Thank you, sir. Thank you, sir.
Session and introducing our next speaker, Dr. Ramesh Sharma.
Thank you, sir. Ma'am, it was a very enlightening lecture, starting from the conceptual stage to the application stage. It was very interesting. Our next speaker is Professor Santiago Gomez Ruiz. He is a full-time professor of inorganic chemistry at the Rey Juan Carlos University. He was a humble fellow between 2006 to 2008 and a Marie Curie training site fellow at Leipzig University in 2003. He has a lot of achievements at such a young age. So far, I think he has participated in 20 competitive research projects. He has published more than 164 articles in very high impact journals such as Angio Ande Simi, Coordination Chemistry Review, Carbon, and so on. He has presented more than 110 contributions in conferences, many of them in oral communication, and he has given more than 45 lectures as an invited speaker about his research in different countries. He is a reviewer of very prestigious journals such as Chemical Reviews, Chemical Communications, Journal of Medicinal Chemistry, Advanced Material, Journal of Material Chemistry, Chemical Society Reviews, and so on. Not only in research, he has also done a lot of work in the teaching side also. He has actively worked in 10 research projects on teaching innovations and has published 6 teaching books as co-author and 2 book chapters in teaching innovation books. In addition, he has presented 30 communications in teaching conferences. So his contributions are there both in research as well as in the teaching field. Today, we are very glad that he is with us, and today he'll be presenting a talk on nanomaterials in drugs, the special case of metallodrug functionalized nanostructured system. So I would like to request Professor Santiago to please give us our lecture.
Okay, thank you very much, Dr. Najan. Thank you very much for the kind introduction. Good morning, everyone here in Spain, and good afternoon there in India. First of all, I would like to thank the organizing committee for the kind invitation to give this talk about nanomaterials in medicine, in which I'm going to speak about the special case of metallodrug functionalized nanostructured systems. I am Professor Santiago Gomez Ruiz, full professor of inorganic chemistry at the Rey Juan Carlos University in Spain. And I'm really happy to have this opportunity to interact with you in this lecture and to show you a bit about nanotechnology and some of the research that my group, the Comet Nano Research Group of the Rey Juan Carlos University, is doing in this field. Well, I prepared this talk starting with a very brief and explicative introduction about the nanotechnology and some basic concepts and numbers of nanomedicine to continue with the description of the current context in cancer chemotherapy and also with nanomaterials. And subsequently, I will present the results of our current research studies on nanomaterials and titanium or organotin compounds, and also with other metals, to finish with the conclusion and outlook of the present work. Thus, as a very brief introduction, I would like to explain that nanotechnology is the design, characterization, and application of structures, devices, and systems by control manipulation of size and shape of the materials at the nanometer scale. In general, it's agreed that the nanometer scale is between 1 and 100 nanometers, and nanotechnology is focused on the design and preparation of nanomaterials with a wide variety of potential applications. However, the advances of nanotechnology are not possible at all without the development of basic science, which is the main really objective of my research group. Basic science is really important to determine the specific features and behavior of nanomaterials. Well, in this context, nanomaterial is considered a material which has at least one of its dimensions in the nanoscale. That means below 100 nanometers. And they usually have interesting properties due to the nanoscale structure that behaves in a very different way than when we are speaking about bulk materials or materials at a microscale. Therefore, nanomaterials are usually formed by the incorporation of or self-structuring of nanoparticles, nanocrystals, nanopowders, etc. So actually, in general, one can classify nanomaterials in 1D, 2D, or 3-dimensional nanomaterials, being clear examples of, for example, 1D nanomaterials species like layers, multi-layers, thin films, platelets, surface coatings, for example, and 2D nanomaterials, for example, can be nanowires, nanofibers, or even nanotubes. And of course, the 3D nanomaterials are known usually as nanoparticles and include precipitates, colloids, quantum dots, and some nanocrystalline systems. Well, there are several approaches for the preparation of nanomaterials, but all of them can be summarized in just 2 different synthetic pathways. Therefore, the bottom-up approach starts from the smaller components built up into more complex assemblies, while the top-down approach creates nanoscale devices or materials by using larger externally contoured ones to direct their assembly. When we speak about the top-down approach, it uses traditional microfabrication methods, like, for example, micropatterning, such as photolithography or inkjet printing. But when we speak about the bottom-up approaches, the use of chemical properties of single molecules are normally utilized to self-organize or self-assemble into useful particulated arrangement. This is the main basis of the synthetic methods that we are using in our group. So considering the different approaches for the preparation of nanomaterials, the properties may be tuned by simple changes in the methods, which usually result in very different properties. For example, a nanosystem may be interesting as a porous nanoparticle because it has a lot of surface area to, for example, be used as a drug delivery system. But the same composition, for example, a silica, if it is not porous, it's a solid non-porous nanoparticle, it may be really not important for the application of a drug delivery system. So simple variations of the morphology, particle size, composition, or surface area can transform a potential therapeutic nanomaterial into a not relevant material or even into a toxic system. And this is applicable to many other potential applications of the nanotechnology and the nanomaterials. In this way, the simple changes in the structure of the nanomaterials, the search of simple changes in the structure of nanomaterials is boosting the research in this field. Yeah, to have a look about the incidence of the nanomaterials and nanotechnology in research. For example, in an European context, nanomaterials and nanotechnology research have been a key field in the past European research program called Horizon 2020, with a dedicated program only for nanotechnologies and advanced materials. This has served to settle Europe in a leading position in nanotechnology. Nevertheless, in the current research program, the Horizon Europe, that is going from 2021 to 2027, nanotechnology is not anymore a single program, but is part of, is integrated in the different clusters of research associated with the big program. For example, global challenges and industrial competitiveness, that now in the cluster of research, they are also thinking about health. And health is present, and some calls of the European Union research program are now focused on the development of nanomedicine as a pillar of the current technology. Well, therefore, it's important to know some important concepts and numbers of nanomedicine to understand the incidence of this field in the current research systems. So nanomedicine is the application of nanotechnology and nanoscience to the prevention and treatment of human diseases, and has promoted the preparation of, for example, nanobiomaterials and nanotherapeutics against different diseases as diagnostic tools, or even in the development of medical devices. For example, nanotherapeutics are really interesting because of their very low toxicity, improved bioavailability, and enhanced pharmacokinetics and therapeutic effect, which have promoted the tremendous advances of nanomedicine in the last 50 years. So nanomedicine has been present in several discoveries in different therapy mechanisms, diagnostic systems, etc. And indeed, nanotechnology is now present even in the development of the last generation of vaccines, such as those of COVID-19, for example. However, nanomedicine, in comparison with traditional design of drugs, presents some disadvantages, as nanomedicine is a special market where the systems need of very demanding properties and very high safety to pass the clinical trials. Nevertheless, you can see here that since 2000, the number of documents, the number of research documents has increased a lot, up to around 20,000 publications per year in different fields of nanotechnology, or of nanomedicine and nanotechnology. Well, as you can see here, most of them are focused on drug deliveries, around 49%, and many of them are focused on cancer. Indeed, several studies based on different nanomaterials, such as, for example, protein-based nanotherapeutics, lipids, polymer-based nanomaterials, drug nanocrystals, or even inorganic nanotherapeutics are becoming a real alternative in the development of novel nanomedicines. However, if you look closer at them, only a few of them are focused on nanomaterials functionalized with metal drugs. And this is really very important because this is a niche of potential investigation at the moment. So this was the motivation of our current work, which is focused on nanomaterials functionalized with metal drugs for cancer therapy. You know that cancer is the second cause of death and will probably be the first one ahead of cardiovascular diseases in the next few years. At this stage, and joining the efforts of scientists, translational researchers, and medical doctors, cancer treatment is multidisciplinary and is going from hormonotherapy to chemotherapy, passing through radiotherapy, phototherapy, and even immunotherapy. When we speak about chemotherapy, that is the treatment that uses drugs to stop the growth of cancer cells by killing the cells or by stopping the uncontrolled division of the cancer cells, chemotherapy has been always associated with metal complexes. When we think about chemotherapy, we should think about the father of the therapy, of the modern chemotherapy, Professor Rosenberg, who unfortunately passed away some years ago, but who discovered cisplatin in 1969 while doing some experiments on cellular division in bacteria. This discovery was a revolution in the field, as only 9 years later, cisplatin was already approved by the FDA for its use against ovarian and testicular cancer. To see the incidence and the importance of cisplatin in cancer treatment, it is important to note that around 50 to 60% of cancer patients in the world have been treated with platinum compounds. Yeah, even though the use of platinum compounds is highly extended, the principal problems of this kind of metal-based systems is the very high number of side effects, the limited water solubility, and the resistant acquisition by the treated cells. So that several alternatives to cisplatin are being developed, although even being accepted by the FDA, they present similar limitations to the original cisplatin. Therefore, other metal complexes alternative to platinum compounds are being developed in the recent years with a special importance in the ruthenium complexes, such as, for example, NAMI-A or KP1039 or the TLD1433, which are in clinical trials from 2B to 3. And also some, for example, gold systems, titanium compounds, iron compounds, and even tin compounds, which are changing the rules of the game of chemotherapy against cancer nowadays. However, many limitations are still present, and thinking that targeting cancer is one of the most active and necessary research fields at the moment, we have thought in the possibility of using metal or drugs-based systems against cancer. Therefore, we wanted to know how could we use these systems selectively against cancer, trying to improve the limited water solubility, which we have been exploring using drug delivery systems, and also to overcome the resistant acquisition by treated cells while enhancing functionality by including, for example, imaging or other potential agents that make these systems more effective. Therefore, taking benefit of our previous experience in the design of silica-based systems, among all the possible alternatives in the field of nanostructured materials, in particular in the field of nanosilica, we decided to use the simplest system based on porous silica nanoparticles of different morphology, particle size, or textural properties as scaffolds for the incorporation, for the support, protection, and delivery of metal drugs in order to study their potential to be applied in anti-cancer chemotherapy. Thus, our studies started with the preparation of titanosin compounds and their conjugation with nanostructured silica. To settle you in a right context, it is important to note that since 2007, our group has published more than 60 different titanosin derivatives that have demonstrated a very high anti-cancer activity and a very high versatility against a wide variety of tumors. Therefore, we focus on the preparation of different nanostructured materials, such as, for example, porous and non-porous silica of different morphology and particle size, fibrous silica nanoparticles, and even other nanomaterials based on alumina and or hydroxyapatite to be functionalized with the most cytotoxic titanosin derivative synthesized by our group. During the last 15 years, we have carried out several studies in the field. However, one of the, for me, most interesting and most useful works in the field was when we used two different titanosin derivatives, this titanosin A and B in this slide, that has some alkenyl substituted cyclopentadienyl ligands, which was supported onto mesoporous silica nanoparticles via the formation of these silicon-oxygen titanium bonds through the elimination of hydrogen chloride in a basic medium to give the nanomaterials NMA and MAB. And we have then studied the biological properties of the four systems, the two free titanosin derivatives, this A and B, and the nanomaterials A and nanomaterials B against a wide variety of cancer cell lines, observing that both the free compounds and the analogous nanomaterials have very different anti-cancer mechanism of action. We observed, For example, very important in science on the anti-cancer mechanism that we could conclude that the systems, the nanostructure systems acted as non-classical drug delivery systems. What means non-classical drug delivery systems? The whole nanoparticles are the cytotoxic agents, and they do not need of the release of the metal compound to be cytotoxic. This was demonstrated by the fact that, for example, nanomaterials gave late apoptosis to the cancer cells was like on the other hand, for the free titanium compounds, early apoptosis was found. So we also observed that, for example, the tunable cytotoxicity of the nanomaterials according to the quantity and type of supported titanium metallodrag. Interestingly, we also found that the nanomaterials showed an increase of up to 40 times the quantity of titanium containing active species inside the cell. So the cell uptake, the cell titanium uptake is much higher when using nanomaterials, probably due to the EPR effect and the protection of the titanium species, which does not happen in the free titanium compounds. Furthermore, we have identified that some therapeutic targets like BAX alpha, pro-apoptotic factor, PARP1, and the tumor necrotic factor receptor 1. And finally, we have also observed that there is a clear influence on the particle size. In this case, the particle, or let's say the size matters, because the smaller the particle, the higher the anti-cancer activity. Well, now, all these mechanistic insights and all the results that we found for these systems based on titaniums encourage us to move to some other metal systems that have not been exploited so much in anti-cancer chemotherapy, such as, for example, organotin-4 compounds. It is important to note that one of the most interesting metals for being used against different cancer systems is tin. Tin usually targets the phosphates groups of the DNA and has demonstrated a very potent anti-proliferative activity in many different combinations, like, for example, carboxylates, thiolates, deuteriocarbamates, etc. In addition, and interestingly, it has demonstrated a very good selectivity towards cancer cells, and the most important is that tin complexes are not substrates of the PGP protein, overcoming, therefore, the potential multi-drug resistance. In previous studies of our research team in 2012, we were pioneer determining the ability of organotin-4 compounds to avoid the drug pump out promoted by the PGP protein of cancer cells, and therefore we were able to overcome the multi-drug resistance by using organotin-4 compounds. Furthermore, in the extensive number of reports of our team, we have synthesized more than 50 compounds, tin compounds, which demonstrated space-independent apoptosis and a slightly higher cytotoxicity against MCF7, which points toward an interesting selectivity of the systems targeting breast cancer cells. Some more recent studies of our team have also demonstrated that long-chain D3 and also tetra-organotin-4 compounds present a very high antiproliferative activity and also very high anti-metastatic properties and a good potential of derivatization, as they can be tuned for incorporation of other systems or other moieties by including a wide variety of functional groups at the end of the chain to be attached to nanomaterials. Therefore, in our recent work with organotin compounds, we have some specific objectives. The first one was the evaluation of the anti-cancer potential of the system based on tin complexes supported onto nanostructure porous silica. To carry out this objective, we first synthesized this target molecule. This target molecule, which is the triphenyltin for hexane 6-ol, which has two different fragments. First, this 3-phenyltene-4 moiety, which is associated with a high cytotoxic activity. And second, this hexanol chain for an easy entering onto the silica-based system. The synthetic pathway to support the tin compound onto a mesoporous silica is first the treatment with 3-chloropropyl trihydroxysilane and the subsequent reaction of the 1-hexanol tin-4 derivative in the presence of an organic base such as triethylamine to give the corresponding tin-supported silica-based system in which we had functionalization rates of up to 12% of tin in the material. We have also synthesized very similar systems, but changing the 1-hexanol chain by these 3-propanol derivatives, such as, for example, the 3-phenyltene-4 propan-3-ol derivative, observing that in all cases, these systems in biological matrices do only release around 20 ppb of tin to the medium, therefore acting, as in the case of the titanosin compounds, as non-classical drug delivery systems. So again, we do not need the release of the tin compound that just to be or just to create a cytotoxic agent. So the whole nanoparticles are the main cytotoxic agent and do not need the release of the organotin compound. Well, in the biological tests, these systems have demonstrated a decrease of the metastatic properties of cancer cells, which is probably due or caused by the fact that the motility of the cells is disturbed in the presence of tin functionalized systems. In addition, it is important to note that the systems promote the p38 mitogen activated protein kinase pathway, which suppresses cell survival and reduce the chances of the cancer cell to live. As we had already demonstrated a very good performance of this system in cytotoxic experiments, we wanted to explore the potential derivatization of the systems for improving the targeting activities. Thus, we have studied the influence of the incorporation of folic acid in the structure of nanomaterials to determine the potential targeting properties to evaluate if these systems might be useful for example, triple-negative breast cancer treatment. Well, for these studies, we synthesized different systems with and without folic acid. We have here without folic acid and with folic acid. And this folic acid was supported to the nanoparticles by a simple amidation reaction using a carbodiamide catalyst onto amino-functionalized mesoporous silica nanoparticles. Two different quantities of folic acids were incorporated, 10% and 25%, to determine the potential influence of the folic acid quantity in the biological performance of the systems. In addition, in a final step, the systems with and without folic acid were also functionalized with a cytotoxic thiolate or 3-phenyltene-4 compound to incorporate an anti-cancer metal drug. Of course, all the systems were characterized by many different solid state techniques, which confirmed the incorporation of both the folate and the organotin-4 fragment and validated our scientific methods. But the most important is what we found in the biological studies. We have demonstrated that higher amounts of folic acid lead to higher cytotoxicity and higher therapeutic potential, especially in cells which overexpress the folate receptors. The systems are able to modulate the folate receptor 1 by influencing the soluble secretion of this receptor of the tumor cells. And in this way, we are inhibiting the proliferation of the cancer cell lines. We had already demonstrated a very good performance of the systems in cytotoxic experiments, potential targeting to, for example, folate overexpressed cancer cells or triple-negative cancer cells, for example. We then focus on the preparation of multifunctional systems, for example, theragnostic systems. Well, we use a model imaging agent like this one here, the coumarin 343. We also use folic acid. So coumarin 343 here, folic acid as a targeting molecule, and also the organotin derivative as a cytotoxic agent. And in this way, the model studies in live cells, we have demonstrated a high internalization of the nanomaterials when adding folic acid. And we are also demonstrated that the systems are very easy to detect using confocal microscopy, which has opened up the possibility of changing coumarin 343 by, for example, Alexa Fluor 647, which is more suitable for potential in vivo image. And this is what we did, because the next step in our studies were focused on in vivo preclinical trials. So in this context, we designed several systems. The first one, this is the system A, first with the cytotoxic agent, the long chain tintiolate system. The second system is the system B, in which we have the cytotoxic agent, and also we have the folic acid as a targeting molecule. And the system 3, this is the system C here, incorporating also this fragment here, which is an enzyme responsive linker based on the GFLG tetrapeptide linker, which is highly sensitive to the lysosomal cysteine protease capsaicin B that is overexpressed in breast adenocarcinoma, for example. And this could lead to not only to the potential action of the nanoparticle itself because of the functionalization with the organotin compound, but also to the release of this therapeutic cargo here, of this organotin fragment here after the cell uptake. All these systems were also derivatized by the amidation reaction with the agent Alexa Fluor 647, which is coming, or it is expressed here as a blue ball here. Okay, then they were studied in vitro to observe that they present a very high cytotoxic activity against cancer cell lines, against breast cancer cells, and also triple negative breast cancer cells. And we have observed the very good performance of the systems with the enzyme responsive linker, these systems here, which target really very well the triple negative breast cancer. In addition, the systems were easily detectable and traceable under the confocal microscope. The last step was the imaging study and therapeutic study, the theranostics study in vivo, which showed the accumulation of the nanomaterials in the tumor area, and also that after 4 doses and 10 days of treatment, a very radical decrease of the tumor size was observed, validating the theranostic potential. Thus, we then wanted to further improve the results of our systems by using not only a metal-based drug, but also a cocktail of drugs supported onto fibrous silica nanoparticles. Therefore, we studied drugs, a combination of drugs like chlorambucil, which has been approved for breast cancer treatment before, and the experimental organotin 4 compound, were very well studied previously by our team. So we first prepare KCC type fibrous silica nanoparticles, as you can see here, of different sizes, which were subsequently functionalized with different polyamino ligands. So the next step, the system was co-functionalized at the same time in a one-pot reaction, amidation reaction, with both folic acid, which is found here as yellow, and also with chlorambucil by the simple formation of amide bonds. So the systems were subsequently functionalized by the incorporation of the organotin 4 cytotoxic fragment, and in a final step, with the addition of the imaging agent Alexa Fluor 647. All the systems were characterized by different methods. For example, TEM analysis, which showed that the system have a mean size of around 400 nanometers, with distances between fibers of up to 3 nanometers in the external part of the dendritic-like system. And the systems are therefore porous, and the surface area decreases a lot from 316 square meters per grain to only around 77 square meter per grain upon the functionalization with the different agents, indicating that the modification takes place between the fibers of the mesoporous system. Additionally, the confirmation of the functionalization and the proof of formation of amide bonds and incorporation of thin derivative were determined, of course, by infrared and diffuse reflectance UV analysis. In the infrared, one can see the signals associated with the amide formation, and in the DRUV analysis, we can see the bands associated with the incorporation of the different fragments, both the folic acid and the chlorambucil, and also the thin compound, validating also the formation of the study systems. But additional studies, for example, by multinuclear solid-state NMR spectroscopy, show also the signals in the 13 carbon NMR corresponding to the different fragments attached to the silica, coming from the polyamino ligand, the folic acid, and also the chlorambucil, and of course the organotin fragment. In addition, the appearance of different signals of silicon in the 29 silicon NMR spectra, as well as the changes in the potential in the let's say intensity of the previous peaks of the silica, are also associated with the incorporation of different agents in the surface of the fibrous silica, validating the functionalization with the different agents. Interestingly, the biological studies on an in vitro culture of triple negative breast cancers, such as MDA-MB231, show a synergistic cytotoxic effect of the system, which are more cytotoxic when using the cocktail organotin chlorambucil. And in addition, in all the studied cases, a good cell migration inhibition and good anti-metastatic properties were found, which are better for those systems functionalized with the cocktail of drugs. As in the case of our previous studies in vitro, in the in vivo studies, a synergistic anti-tumor effect of the systems was found. The decrease in the tumor size was higher when used the cocktail of organotin chlorambucil. In addition, the nanostructure system presented a selective accumulation in the tumor area and a low accumulation in other viral organs. Finally, we carried out a study of the vascularization in the tumor area, which demonstrated a reduction, a radical reduction of up to 60% of the flow flow compared to control non-treated mice, indicated very good anti-angiogenic properties of the study systems containing the cocktail of drugs. This additional study, a biochemical additional study of the blood of the different markers and parameters of the mice after the treatment, have demonstrated also a non-toxic profile in all the studied doses, which have also pointed towards low toxicity and good potential applicability of the systems in further clinical trials. And this is what we are working now. So also, to try to finish with the talk, I would like to very briefly show you some of the interesting results that we have obtained using nanomaterials with other metal compounds, not only titanium or not only tin. We have also used ruthenium compounds, and we have observed very high photoactivity of the silica ruthenium conjugates using photoactive ruthenium-2 compounds with just 10 minutes of radiation at 350 or 450 nanometers. And for example, in the case of using zinc, the incorporation of benzotiazole ligands into the silica or for example, in this case, also magnetite nanoparticles, have led to the detection of zinc in live cells. So this could be really interesting in the case of detecting diseases like ischemia. In addition, in the case of nanosilicas conjugated with certain copper compounds, we have observed a high antibacterial activity related to the potential in the generation of reactive oxygen species, and also in the potential damage in the peptidoglycan of the bacterial membrane. So, just to finish with this talk, I would like you to bring home this take-home message, that is that we have found very good cytotoxicity and anti-metastatic potential of these metallo-drug functionalized systems. Also that the functionalization with folic acid had a multifunctional road, not only targeting, but also the influence of the secretion of the soluble folate receptor 1, which is inhibited the cancer cell proliferation. That incorporation of potential imaging agents makes the systems therapeutic, and that the preclinical trials in vivo have shown very promising properties, which are improving when using cocktail of drugs. The anti-angiogenic properties of the system may control the potential vascularization of the tumor, and this would make really a bit easier the treatment of cancer. So I would like to finish just thanking you very, very much for this kind invitation. I would like, of course, to be in Sikkim Manipal Institute of Technology at the moment. That would be really great to visit this area, because I have heard that it's a really nice place in India, close to just the mountains, and in a very nice and green area of India that I don't know. But not only the pandemic, but also the help of Zoom is making us connected at the moment. So I don't want to finish without showing you where I'm coming from. I'm coming from Spain. This is my home city called Toledo, that is more than 2,000 years old. And this is the capital city where I'm working, which is Madrid. And we also have very, very, let's say, paradises in our country, like these very nice beaches that you can find everywhere. And this is my university, the Rey Juan Carlos University, that has a very nice green American campus style with a lot of space. And this is a part of my group, that we are really like a small family, and I would like to thank many people involved in this work. Not only me, I am just showing you the work, but the real actors of this work are all the people that is mentioned here. Collaborations with people from Universidad Complutense in Madrid, from people from Romania, from Argentina, and also all these students and doctors, or recently doctors of my team, and these other senior staff, and of course the financial sources of the government of Spain, and two foundations and my university. And of course, thank you all very much for your very kind attention.
Thank you, sir. Are there any questions from anyone in the house? Does anyone have any questions for Professor Santiago?
Maybe they are a bit asleep.
Good afternoon, sir.
Tell me.
Hello.
Hello.
Yes, sir.
This is Professor Sudhakar Babu, Professor of Inorganic Chemistry from Sri Krishnadevara University, Anantapur, Andhra Pradesh. I am also a member of Association of Chemistry Teachers. Sir, the lecture delivered by the Professor Santiago is very nice. He has given a brief, detailed review on the nanomaterials in medicine. So some research studies also mentioned. So I appreciate the deliberations made by the Professor of Inorganic Chemistry and chairing the chairman also. So have observed any environmental implications while using these ones, nanomaterials, especially, which finds applications in medicine.
Sorry, I didn't, it was cutting. I don't know what you really mean, because your voice for me was
Any environmental implications associated with this one?
Okay, you mean toxicity of the nanomaterials?
Yes.
Yes, okay. So most of the systems are that we have found here are based on porous silica nanoparticles. Porous silica nanoparticles in a small sizes, they are already evaluated by the FDA, and if covered by, for example, BGL or some other polymer, they can be applied in humans. So for the future, the next step would be, for example, the coating or something similar to try to make them more applicable. But as I told you at the beginning, the main motivation of our research is the discovery of basic science, because
When it poses the toxic, if it exceeds the limit, definitely it poses the toxic effects. Better environment is our prime concern, is it not? That's why I put it.
Yeah. Okay, but it's completely pertinent, the question. Yeah, of course.
Okay. Thank you, sir.
Yeah.
Thank you, sir, for chairing the chairman of the session, for giving me opportunity.
You're welcome, sir. And now I think it's time to move on to the next section of the program. I would like to first thank Professor Santiago for such a nice lecture, and I hope that you make progress for the benefit of all the cancer patients throughout the world. We wish you all the best, sir, in your endeavor.
Thank you very much.
And it was a very nice, illuminating lecture, sir.
Yeah,
thank you so much, sir. I would now like to hand over the dice to Subeksha to take care of the next phase of the program. Thank you, sir.
Thank you, sir. Now we will begin the technical session 2. This session will be chaired by Dr. Sotadru Jha, SMIT, and Dr. Santanu Gupta, SMIT. I would kindly request both of them to take over the session.
Yeah, good afternoon to everyone present in this conference. Now, am I audible?
Yes, sir. Yes, sir, you're audible.
Hello. Yeah. Researcher, now you have already prepared your presentation. Now you are ready for the presentations. So we are calling first Milind V. Gaikwad.
Yes, sir.
Your presentation, you will get 10 minutes, right? And try to finish within 10 minutes. And I hope there is a question answer sessions, at least 1-2 minutes for this, and then the next candidate will present. So you please start.
Sir, yes, share my screen, sir. Thank you, sir.
Yeah.
Sir, me audible?
Hello.
Oh, yes, sir. Good afternoon to all. Myself, Milind Gaikwad, working as associate professor in Dr. D.Y. Patil SS College, Pimpri, Pune. Today, I am going to give my presentation on the topic synthesis of thiazolopyrimidine hydrogen carbothiamide derivative and its anti-tuberculosis activity. Introduction. Heterocyclic compounds are cyclic compounds in which one or more member of the ring is heteroelement, such as oxygen, sulfur, and nitrogen, etc. The research on the heterocyclic compound attracted much consideration in the recent times because of their increasing importance in the field of medicinal and the industrial application. Heterocyclic compounds represent an important class of the natural origin compound and have the pharmaceutical importance. These are heterocyclic compounds having the wide range of the biological activity, such as antibiotic, anti-cancer, antifungal, antiviral, antimicrobial, antioxidant, anti-HIV, and anti-tuberculosis. So, to prepare such type of the heterogeneous compound, we have used PEG 400 as a green solvent and bleaching earth clay as a heterogeneous catalyst. These are the advantages of the PEG 400 solvent and bleaching earth clay. In the recent years, synthesis of hydrogen carbonamide derivative is gaining much attention concerning their extensive biological activity, including antiviral activities. The technique of combining two biologically active motifs in one single molecule pursuing the elevated biological silhouette is a well practiced these days. These are some of the examples of the bioactive thiazolopyrimidine hydrogen carbonamide derivatives. Objective of this research to synthesize thiazolopyrimidine hydrogen carbonamide derivatives, to study synthesize hydrogen carbonamide derivative and derivatives for antitubercular activity, molecular docking study of the synthesized compound with PDB1TG5 enzyme. This is the outline of the synthesis. We have prepared the compound 1, that is alpha beta unsaturated carbonic compound chalcone by reaction with 2-acetyl benzofuran and heteroaldehyde or aromatic aldehyde in the presence of, that is the pH 400 as a green solvent and bleaching earth clay having the pH 12.5. The stirring at 3 hours at 70 to 80 degrees centigrade temperature in the presence of hydrolia, it gives compound 3 to A, and further it reacts with 2-chloroacetic acid in the presence of pH 400 and bleaching earth clay at 70 to 80 degrees centigrade temperature for 2 hours. It gives compound 5-Al, which on further reaction with hydrogen carbothiamide derivative, hydrogen carbothiamide, it gives compound 7-A at 70 to 80 degrees centigrade temperature for 3 hours. The synthesized compounds, they are further confirmed by the spectral analysis. This is the H1 NMR of this compound 5A, which gives singlet at 4.3A, 34 due to 1 hydrogen, then multiplied due to 2 hydrogen between 3.75 to 3.63, and singlet due to 1 hydrogen at 5.77. This is the C13 NMR spectrum of the 5A compound. This is the H1 NMR of the compound 7A. This is the C13 NMR of the compound 7A. This is the physiochemical data of the synthesized compound, that is the carbothiamide derivative. The synthesized compound, they are further screened for the antituberculous activity. This is the graphical representation of the antitubercular activity of the synthesized compound. From the figure, it is clear that the compound 7C, 7D, 7F, 7G, 7 and 7J, they are found to be effective growth inhibitors and show excellent antituberculous activity. Further, the synthesized compounds, they are screened for the molecular docking. The molecular docking study of the synthesized compound performed with PDB1TG5 protein, which have native ligand LDPH, dihydrodianicotinamide adenine dinucleotide phosphate with 159 amino acid present in their binding site. The figure 1.9, the A and B, it represents the 2D image shows the hydrogen bond with ligand 7A with amino acid residue, and the figure C, this is the cartoon model represent the ligand docking in the cavity of the enzyme. The ligand 7, the ligand shows hydrogen bonding with amino acid and having the binding energy minus 9.53 kilocalorie per mole. This is the figure in which A and B represent the 2D image of 7C, indicate the hydrogen bond with the amino acid residue, and figure C is the cartoon model display the ligand dock in the cavity of enzyme. The ligand 7C shows hydrogen bonding with the different amino acids and having the binding energy minus 10.56432 kilocalorie per mole. In vitro data, along with the molecular docking study, it reveals that the synthesized compounds have potential of antituberculous activity. Conclusion: we have synthesized novel benzofuran thiazolopyrimidine hydrogen carbothiamide derivative. The synthesized compound screened for the antituberculous activity. The result reveals that the compound 7C, 7D, 7F, 7G, 7I, and 7J, they are found to be active mycobacterial tuberculosis. As per active result, the compound shows minimum binding energy with PDB ID 1Tg5. In vitro data, along with the molecular tracking study, it reveals that the synthesized compound have the potential of the anti-tuberculosis activity. Thank you, sir.
Hello, thank you for your presentations. Now it is the time for question answer. If anyone, you have any questions, you can ask, please. Hello.
Hello, sir.
Yeah.
Yes, sir.
Which is the standard used for the comparative study for the tubercular activity?
Sir, for the anti-tuberculosis activity, we have used rifamycin and isoflurane.
Okay.
Okay, I think there is no questions is coming. So thank you, Milind B. Gegward.
Thank you, sir. Thank you.
Thank you
Thank
for
you,
your
sir.
nice presentations. Now
Thank you, sir.
is the time of Nikhilesh Iyer.
Hello.
Nikhilesh Iyer.
Sir, am I audible?
Yeah.
Okay. Sir, I hope my presentation is visible.
Yeah. Visible.
Okay. Sir, so first of all, thank you for this wonderful opportunity. And it's a small presentation on using a very simple projection method to understand certain surface phenomena. As in chemistry, the interface is where most of the action happens. So how can we see that, visualize that, so that we can correlate with the theory and especially propagate the knowledge of chemistry even to younger children, to younger generation. So that being the objective, certain methods were developed. The tool is very simple. We need just a dark room and a clear flat ceiling, and a stand to hold a transparent sheet or a petri dish where we can add some liquid, a transparent liquid, oil, water, or anything, and a mobile torch source. So this is all that is needed to perform the experiments, and using simple triangles, and in this case simple cones, similar cones are formed, and we obtain a magnified image of whatever object we are having here onto the ceiling. So with this simple setup, I'd like to show certain video demonstration of the activity that has been carried out. So this blob of light we see in the top is actually the water droplet which is projected onto the ceiling. Using the torch source, it is passing through the water, and I'm just adding a few drops of oil in that. And that clearly manifests the miscibility gap between oil and water. And the edges are highlighted because the light is bending from rarer to denser medium and making the edges of both water and oil very clearly visible. And along with the miscibility gap, if we have to break it, we are just adding a little bit of detergent. And we can just clearly see how it's as if the center nucleus gets broken and opened up. And maybe the video would not be good. The best way to see it is right at home, live by doing the demo. The clarity will be much more than what is there in the video. So in this way, the whole concept of polar, non-polar bonds, and why certain things mix, why certain things don't mix, that can be described as well as shown as a demonstration. So what else can be studied? We can study the dissolution of salt and sugar, the kinetics of dissolution, how it is affected by the particle size, and how color or dye disperse in a solvent, and certain aspects like solvent extraction of metals or colorful metal ions from water to oil. Such things can also be demonstrated, and turbulent lamellar flow, capillary action, many such simple interfacial phenomena can be magnified and visualized using this method. And I would like to also show a little bit about certain experiments which I'm doing in my PhD project, which involves extended X-ray absorption fine spectroscopy. And although this is a pretty advanced method involving a lot of theoretical input, visualization of what is happening here can be like at least understood using this method. So primarily, when we put X-rays, high energy X-rays, it knocks off inner shell electrons and creates photoelectron waves, central spherical waves of photoelectron, which get scattered by the nearby atoms. And by observing the scattering patterns of constructive and destructive interference, we get an idea about the neighborhood of the atom. Although the detail involves a lot of mathematics and theoretical inputs from DFT calculations and all that, and other spectroscopic techniques, to get a basic idea of the visualization, we can take use of this method. So again, it's the same setup. A petri dish, I have placed some marbles. There is just a simple mobile torch on the top and a ceiling where the whole phenomena is being projected. So this is a pattern we see when there is only one marble in the center, describing how the waves, spherical waves, undisturbed spherical waves. In this case, we are seeing light surface waves. In EXAFS, it is spherical waves of photoelectrons. So that is the we are trying to visualize. And if we keep neighboring marbles or neighboring atoms, there is change in the interference pattern. This gives an idea about where exactly the atoms are, which we cannot see by any other techniques. So the EXAFS is a tool which gives us input about the coordination number of the central metal ions and the ligands which are surrounding it. So with that, I would like to end my presentation, and thank you for the wonderful opportunity.
Thank you, Nikhilesh Iyer. Now it is the time for question answer. Request audience, please, if you have any questions, ask Nikhilesh. Yeah, there is no questions. So Nikhilesh, thank you for your nice presentations.
Thank you, sir.
Yeah. Now next is, I hope it is a student of Dr. Najia A. Rasidi.
Yes, sir.
Yeah.
So can I share my slides?
Yeah. Please, yeah.
Okay, sir. Thank you. Just a second, sir. I'm sharing. Yes, sir, I'm sharing the slide. Is it visible, sir?
Yeah.
Okay. Thank you.
Please,
Yes.
please make it full screen. Adam.
Just a minute, please. Now is it okay, sir?
Still, it is very.
Actually, to my side.
Yeah. Is fine.
Okay. Good evening to all. I, Dr. Nazia Akhtar Rashidi, from Munsaji Maharaj Mahavidyalaya, Dharwad, and I'm here to present my paper titled as Green Synthesis of Cobalt Nanoparticle using Hibiscus rosa sinensis. At the outset, I am thankful to the organizers for giving me this opportunity for the presentation of my paper. The objective of the present work is nothing but the green synthesis of the cobalt nanoparticle using Hibiscus rosa sinensis and its characterization. So let's move to the introduction part. Friends, all of you know that nanotechnology is one of the most active and promising technology, and it is applied in the field of science since from the last 4 decades. And the research on the nanoparticle have been developing rapidly due to its unique property and application in various fields. Also, it is literature survey revealed that the nanotechnology is increasing more and more. At present, nanoscale particles have noteworthy impact in almost all the area of science. These materials have created high interest in recent years by virtue of their unusual magnetic, optical, and electrical properties. There are the various methods available for the synthesis of nanoparticles, and out of the available methods, that is the chemical method, physical and biological method, that is the scientists always prefer to do the biological synthesis because it is a green synthesis and it is safer. No toxic chemicals are used for this, and it is the time that is the cost effective, simple and eco-friendly, we can say. And among the biological synthesis, generally the plant extract, that is the use of the plant for the synthesis of nanoparticle is nowadays in very much exciting way for the synthesis of nanoparticle. Recently, various plant extracts have come out as a novel resource for their capacity to produce non-toxic and safe nanoparticles. In the present work, Hibiscus rosa sinensis plant is chosen for the synthesis of this cobalt nanoparticle because this Hibiscus rosa sinensis is used from the ages in Ayurveda also, in medicines to cure many ailments. They are used to cure cough, cold, and other treatment like loss of appetite and disorder to treat the disorder of respiratory tract, etc. Also, it has the antioxidant property and helps in the reduction of cholesterol. So, with this aim, we have seeing the important use of medicinal property of this Hibiscus rosa sinensis. Scientists were more interested for using this plant for the preparation of cobalt nanoparticles. Now let's move to the methodology. For the preparation of this plant extract, We have chosen the Hibiscus rosacea as a plant, and we have taken the 30 gram of the sample of this and cut by scissor into small pieces, and they can taken into the extractor. Extraction was carried out in 100 ml deionized water on heating metal at about 200 degrees centigrade, and the extract of Hibiscus rosacea was cooled down and then filtered with the Wortmann filter paper number 1. Now comes to the main objective of this, that is the synthesis, green synthesis of the cobalt nanoparticle. And for that, we have chosen the cobalt salt, that is the cobalt fluoride. First of all, the 1 millimolar solution of the cobalt fluoride was prepared, and then it is kept in the dark to avoid the photoreduction reaction. And then 10 ml of the prepared plant extract was mixed in the 90 ml of 1 millimolar solution of cobalt fluoride, so that the concentration of the solution will maintain, that is 1 millimolar, and that is mixture is concentration of the mixture is maintained. Again, this mixture is then packed with the rubber cork, and then it is wrapped with the silver foil and again kept in the dark to avoid the photoreaction. And after 24 hours, it was found that the fine powder of the dark reddish color powder were obtained, and that was nothing but the powder of the cobalt nanoparticle. And the next was the characterization of the biosynthesized cobalt nanoparticle, and mostly structural characterization of this is done by the UV visible spectroscopy, FTIR, and XRD analysis. Here we have chosen the material, that is the Hibiscus rosaceaensis plant, and the for the preparation of cobalt nanoparticle, we have chosen the cobalt salt, that is the cobalt fluoride hexahydrate. As a part of the result, we can say that the first figure shows the cobalt solution, cobalt fluoride hexafluoride solution in the deionized water, and second show the mixture of the cobalt with the plant extract, and a distinct color change is observed after the addition of the aqueous extract to the cobalt fluoride salt solution, and that color change to the dark reddish color, indicating after 24 hours kept after keeping it in the dark, we got the cobalt nanoparticle. As a part of the conclusion, we can say that in the present study, cobalt nanoparticle and cobalt nanocolloidal solution, they are prepared chemically by the reduction process. The reduction of the cobalt salt to the plant extract. Nanospecies we have characterized by UV visible spectroscopy, and prepared cobalt nanoparticle were used to determine the characteristics of the nanoparticle. Cobalt nanoparticle were characterized, especially structural characterization was done by UV visible spectroscopy, and characteristic absorption peak for the cobalt nanoparticle was obtained within the range of 400 to 500 nanometers, and there was no obvious change in the peak, in the position of the peak, even after the 30 days that depict the, or that reveal the stability of the cobalt nanoparticles. So whatever be the cobalt nanoparticle synthesized by this biosynthesis method, that was quite stable, and the cobalt nanoparticle has gained considerable interest. That is, we were interested to prepare this cobalt nanoparticle using the plant extract because of the applicability. It can be used for the water treatment. It has antimicrobial. It can be used as an antimicrobial property. So this was all about my paper. Thank you.
Thank you, madam. Now it is the time for question answer. If anyone have questions, then please ask. Madam, I have one question. In your nanoparticle synthesis, how fresh this hibiscus you have used? It is just taken out from the tree, and then you take the solutions and use it, or even if it is old, we can use for our synthesis?
Yes, sir, we can use it directly also, or we can dry the leaves first. We can hold it also.
Okay, means
In any way we can use for the preparation of cobalt nanoparticles.
okay, okay.
Hello.
Okay.
Thank
If anyone has any questions, please ask.
Including question answer.
Okay.
Time ka problem.
Yeah. Now next, thank you, madam, for your nice presentation. Next is S. Murugan.
বলে দিন 10 মিনিট question answer.
Okay, okay, I understood. I'm calling S. Murugan. I think he is not here. Next is Dr. Raj Badekar. Dr. Raj Badekar. Am I audible? Next one, next one, D.T. Sakhir. Next presenter is D.T. Sakhir. I'm calling again S. Murugan. Mr. S. Murugan. Next one, Dr. Raj Badekar. D.T. Sakhir. Oh, Sakhir. Next one, Dr. Hina Q. Sek. Dr. Hina Q. Sek. Dr. Hina Q. Sek, I'm requesting you, please present your work. Next one, Dr. Najia A. Rasidi. Dr. Najia A. Rashidi. So next I am repeating again, Mr. S. Murugan, please present your work. If you are in this audience, please start to your presentations. Next, Dr. Raj Badekar. Dr. Raj Badekar. Am I audible? So please, if you are present in this house, please start your presentations. Next one, Mr. D.T. Sakhere, Mr. D.T. Sakhere, next one, Dr. Hina Q. Sheikh, and Dr. Najia A. Rasidi. Dr. Najia A. Rasidi. It is my request to this researcher, if you are present in this house, please start your presentation. I'm calling against Mr. S. Murugan, Dr. Raj Badekar, Mr. D.T. Sakhere, Dr. Hina Q. Sheikh, Dr. Najia A. Rasidi.
Sir, I think Dr. Nazia is present. She has 2 presentations in this session. She just presented.
No, ma'am. I have present only one.
Her voice is cracking.
Ma'am, I have done, ma'am. I will present only one.
Okay,
Sorry.
only one. Okay, okay. Okay. I hope this researcher are not present here. So again, calling once more, let's check. Mr. S. Murugan, Dr. Raj Badekar, Mr. D.T. Sakher, Dr. Hina Q. Sheikh.
So you can conclude the session.
Okay, so nice all of you who has presented this, presented their work in the sessions. Thank you all for your nice presentations, and thank you audience for your kind presence. And now I'm handing over the session to Mrs. Suveksa Tama.
Thank you, sir. We shall now begin the invited session 3 from 5:30. The session will be chaired by Professor D.C. Deka, ACT, and Dr. Joydeep Biswas, SMIT. The invited speaker is Dr. E. Ponnusamy, Millipur, USA.
Good evening, everyone. As announced, that our next session, that is at 5:30. Our invited speaker, Dr. E. Ponuswamy from Millipore Sigma, USA. He will be joining at 5:30. I request all the participants be online so that we can start the session in time. And Professor D.C. Deka and Dr. Zaidip Biswas will share the session. Thank you all. I hope Dr. Swami has joined. Is it? Am I audible?
Hello.
Yes, sir. Yes, sir.
Okay, so we are
Very
connected.
good morning. I think very good morning to you, sir.
Yeah, there's no problem. Good evening, good afternoon for you, or late afternoon for you.
Yeah.
So we are going to start in another 5 minutes, or?
Yeah. We'll start, sir. We'll start.
Okay, let me get this. Let's check the presentation. I can share with you, or let's see, screen share. You see my screen?
Yes.
Okay, so let me put it in a
Yeah, it
slideshow.
is visible. It is visible, but you can convert it to presentation mode.
Yeah. Just a second. Slideshow. Works, right? I just move all the slides to the end and then come back and
Yes, it is okay.
Okay. No technical issues. That's good news. So you are all based in Sikkim area, or where you are all based?
Yeah, presently I am in Sikkim, but our colleagues from Sikkim, but since people are joining from the all over the country, that means from India, various corners of the country.
Oh, okay. Yeah, I understand.
Few from Mumbai, maybe Hyderabad, like that, in Delhi also. In Kolkata also, various parts of this country people are joining. And today morning we have started from 10 o'clock. Now your session is the last session.
Last session, yeah. I am between dinner.
Because your timing, we have to adjust accordingly, since it is now, I think, 6 o'clock morning in your place.
Yeah, it is 5:30 now, 5:26 right now.
Okay. Thank you very much, sir, for accepting
no problem,
just joining with us.
Yeah. It's okay. I
Sir,
mean, it's not
by another 5 minutes, we will start.
Okay. No problem. So I just let me know when, then I will start. My presentation will be not more than 30 minutes. So.
Okay. And I think Didi Prabhu sir is also online. Sir is the secretary of Association of Chemistry Teachers. Sir.
Hello. Nice meeting you all.
Hello,
Virtual
Dr.
world.
Nice to meet you.
Yeah, nice to meet you too. So.
You are giving a talk in our national convention.
Yeah. Okay. Yeah, that's what Dr. Nayan.
Yes.
When we sent the invitation, so.
Yeah. Dr. Nayan has done a wonderful job.
Oh yeah, you all. I mean, I saw that program. Unbelievable number of people speak on that. So.
Yes. Right.
It's a marathon job to arrange all those things virtually.
Online conference is a big job.
Yeah.
Thank Dr. Nayan and SMIT for doing a
So, how was the first day? So this is the end of the day today. So for you, so it went overall good.
Everything went off very well.
Oh, great.
The lectures have gone on well. We had some presentations by our teacher participants, 10 minutes presentations of their research work. And so everything has gone on very well. We are looking forward to your talk, sir.
Okay. Looking forward to myself too.
Yes.
Are you, your people are aware of green chemistry, or just I am talking?
It's very much a part of our college syllabus, and now it is going into our school syllabus also.
Oh, that's fantastic.
Second year of graduate studies, final year MSc, green chemistry is a very big part of our syllabus.
Okay. So
many practicals have become green chemistry practicals.
Yeah. it's not a green chemistry, it's a separate field. It's just a chemistry with a little bit thinking of do we need to do this way or we can do better way. That's
yes.
So is it the 12 principles of green chemistry? People are aware of it?
Yes, definitely.
Okay.
Definitely.
Because my whole talk is based on the 12 principles of green chemistry.
Yes. In fact, every 2 years we have a conference on green chemistry, sponsored by one industry, where us and John are always coming as the guest speakers.
Oh, that's nice. Yeah, I know John used to tell,
yes.
John and myself are close friends. John, Paul, we all work together and many projects. So he tells always, but the COVID came now, everybody is frozen.
Normally we have this conference every year in the offline mode, but this year because of this COVID, and even last we are having it online.
Yeah, understand.
That we could listen to a number of good speakers from abroad. So that was a plus point of this online conference.
Yeah, I think it's no matter if COVID gone or something, this virtual is going to stay.
Yeah, I think this hybrid nature will stay, I think.
Yeah.
It has its advantages, of course.
Yeah, good. That's probably only good part of COVID.
Yeah. That's true.
Okay, then I will now hand over to Dr. Joydeep Biswas to chair this session. Then we will start this invited talk from Swami sir. Please take on.
Okay, good evening, everyone. So the next session is basically presented by Dr. E. Panuswamy sir. So Dr. E. Panuswamy completed his PhD at the University of Madras in 1982 in polymer chemistry and a postdoctoral study at University of Illinois, Chicago. In 1988, he joined Sigma Aldrich as an R&D scientist and worked on many high-value projects at various capacity. Currently, Dr. Swamy is Global Manager of Green Chemistry at Millipore Sigma, Germany, leading the Green Chemistry Initiative. Dr. Swamy has over 35 years of industrial and academic research experience in developing new products, greener process development, polymer processing, green manufacturing from laboratory to pilot plant scale, utilizing green chemistry principle. Dr. Swamy is the founder of the worldwide green chemistry team at Sigma Aldrich in 2007. Dr. Swamy has published over more than 45 scientific papers and awarded 6 US European patent. I request Dr. Swamy to deliver his lecture. Over to you, sir.
Thank you for the nice introduction. Let me put it on the slideshow mode. You all see my screen, right?
Yeah.
Okay. Okay. Good evening. I don't know if you say good evening or good afternoon for you. Okay. Good evening. Good afternoon. I am in a good morning area. I am at 5:30 a.m. for me. Thanks for inviting me to give a presentation to your what is that, NCCT conference. I really appreciate. My talk is going to be a dozen 2.0, a quantitative green chemistry evaluator for a sustainable future. What is dozen? There is no word like that, right, in English. So this is nothing but a 12. We made it as a trademark, taking the E out. So the dozen is based on the 12 principles of green chemistry. So I have to tell a story how we arrived this dozen. Few years ago, we did a study with our key customers. We have over 1 million customers in our company. So there is a global advisory panel who identify who are all the key customers, and we send that study to those customers to get their customer feeling on green chemistry. The results were very interesting and unexpected. Customers were asking us, what is the metrics behind the green chemistry? Because I say my product is better than others. Others say their product is better than ours. There is no metrics. That's opened up our eyes, and we looked into what is available in the marketplace, which we can just buy and adopt. But there is no comprehensive tool available even today other than dozen to give economically find a way to get the green score for a process, both either biological or a chemical process, using readily available information. Like the process information, we all know, we are all scientists, we know how to make X, Y, Z. That is on hand. And then the remaining is the GHS, globally harmonized system, and the STS safety data sheet information, which is connected with the tool, so which pulls internally and gives out score. So I will talk in detail. I'm just giving you a preview of what I'm going to talk. Let me move on to my slides. Okay. So the overview of my talk is, briefly I mentioned what is our greener alternative platform, and then jump into how dozen works, and then how applying dozen system on that algorithm we developed with the product examples applying dozen, and there is a 2-minute short video how to use the dozen system, and then close it with advantages. Our greener alternative platform has 4 different groups of products. One category we call re-engineered. So the re-engineered means the product we already offer, we critically look into the process, and we re-engineer to make it more environmentally friendly or sustainable. That process, we apply our dozen tool, we give the score for the old process versus the new process. I will show some examples later. The second category is 12 principles aligned products. 12 principles of green chemistry. If a product adheres to one or more of the 12 principles of green chemistry, we call that as 12 principles aligned product. For example, we have greener alternative solvents, greener alternative catalysis. So we call those are all 12 principles aligned products. The third category is enabling technology products. These products enables greener research like alternate energy, solar and wind. These products go into that category. We call that as enabling technology products. The fourth category is the brand new one. This applies to the packaging related sustainability. So the product which reduces more plastic waste going into the landfill. So that's called design for sustainability products. Those products identified, we give this right side globe with reverse arrow. No, not reverse arrow, the real arrow. We changed recently, sorry. So this, if you see this symbol in our website, that products are all greener alternative products with the supporting documents, why it is greener. There will be a published paper attached in the paper in the product page. So those who are not familiar, these are the 12 principles of green chemistry. I heard from Dr. Nayan and others, so you guys are very familiar with this. So I just skip this. How dozen works? I'm going to show you the algorithms, how we came up with this, because we are using with our readily available information, process information, and then the STS GHS information to come up with a score. So this is the algorithm for principle 1, waste prevention. I'm not going to read this. If you have questions, we can discuss at the end. So here, primarily, you design in a way you don't create too much waste, prevent the waste. The second principle is atom economy. In pharma industry, they call that as a process mass efficiency, which is critical, and they use heavily in these principles. Now, when we all know more atom goes into the final product, that means we get more yield, so create less waste. It's an efficient process. The third principle, less hazardous chemical synthesis. Here, the term comes H score. H is a health hazard score. So how health H score is implemented here. So the H score comes from GHS scale 1 to 5. So those who are aware, not aware, GHS is nothing but globally harmonized system which Europe uses, and the STS rest of the world uses. Principle 4, designing safer chemicals. So at the design phase, make sure we try to design in a way reduce the environmental footprint. So here also H score is involved. Another principle with the safety related, safer solvents and auxiliaries. Here also H score. Okay, then sixth principle is the energy efficiency. Here comes severity factor for temperature and severity factor for pressure, and then the time and mass of raw material we apply for the calculation of energy efficiency. Come on. Use of renewable feedstock. If we use more renewable feedstocks, then our process is more sustainable, so our score will be better. Reduce derivatives. We all do knowingly or unknowingly a lot of derivatization in our work, because some of the publications are very old publications. We don't critically think. So we have to look into the thing whether we really need to do this kind of derivatization, and then protect, deprotect, and create a lot of waste. So this principle addresses that part. Then catalysis. So we know catalysis increases the efficiency, the yield. So as far as possible, try to apply catalysis. Design for degradation. Here comes a new term called B score. B is a biohazard score, which also comes from the GHS scale 1 to 5. This is like an acute aquatic toxicity, bioaccumulation, exposure, persistence, etc. Then the last principle is real-time analysis for pollution prevention. If we have an automated system attached to any process, the chances of uncontrolled reaction, accident, those things are minimal because there is an alarm comes, so people go and address it. So that's what this principle talks about, the 11th principle. The last one, I think I misspoke. The last one was the 12th. So this is the 12th principle. So inherently safer chemistry for accident prevention. So here is a new term called P score. It's a physical hazard, like a pyrophoric. There are 16 categories in the GHS scale: explosives, flammable, aerosol, pyrophoric, corrosive, all those things in the GHS scale. So now we have all the 12 principles algorithms. So we linked all these 12 principles algorithm with the GHS and the STS internally. And we only think what the user needs to do is input the process information. How doesn't works? If we look at 12 principles of green chemistry, 6 principles talks about improved resource use. So the principle 1, 2, 7, 8, 9, and 11 are the resource related principles. We group them, these improved resource principles, and the sum average the score of, we call this as a group 1. And then the Second group is energy efficiency, which stands alone because any process, energy is the major contributor for the greenhouse. So that's greenhouse gas emission. That's why we give 1/3 of the weight for the energy. The last group is safety of human and environment. Principle 3, 4, 5, 10, and 12. We average the score of these 5 principles. We get the group 3 scores. But if we give it 12 scores, you as a customer or user, it will be confusing for you, right? So how do you know, is this with the 12 numbers, is this product is really greener, or how do they come up? So to address that issue, we did this, grouping them based on the resource, energy, and the hazards. But get an aggregate score, single score, we have to normalize this group score. So we sum the group 1, 2, 3 scores and normalize it, divide by 50 to get the score of 0 to 100. 50 is an arbitrary number here. Based on our experience with the tool, the lowest score we got was single digit. The highest score we got was 5,000. In order for us to get the aggregate score in the range of 0 to 100, 0 being the most desired, we did this way. Down the road, when many hundreds of thousand products scored, if the higher score comes, say 10,000 or something, we may have to readjust this normalizing factor to bring the green score. So this is the score we are getting is not an absolute number. It is an aggregated score to give a feeling on users how green there's a relative numbers. Our dozen system was verified and validated by third party, and we also published in ACS Sustainable Chemistry and Engineering Journal. And at the closing, I'll tell how our tool works right now in customer hand. Applying dozen 2.0 is simple. Just you have the data process information, so collect the data and then enter into our system and then press a button, score calculation. It gives in just, if you have a 2-step process, it takes the first time, maybe it will take 2 hours because of the learning curve. Once you learn the thing, then it's just a simple thing. Currently, we are working on automating this with electronic notebooks, those kind of things. So in that way, you don't have to even enter anything. So it will pull automatically. But it's in work right now. Product examples. The beta amylase in an enzyme commonly found in sweet potatoes, which is used for hydrolyzing starch into sugar. The process we use is an old process published in 1950s. That process utilizes 6,000 pounds. So, we are in the US, we still use pounds and gallons. Rest of the world, we use another system. So that's why the process, it shows like this. That process utilizes almost 2,000 gallons of acetone, and we have to use it, apply it at a boiling point. So significant electricity is used. Any natural product, polyphenolic compound comes out. To remove the polyphenolic compound, solvent is the better olden days because there is no sustainability lens those days. So the original inventors of the process, they applied acetone. So we were using without questioning. When the scale went up, it was a safety nightmare for our company. So we looked into a safety angle, we addressed this. I'll show you the new process, which reduced 1/3 of the raw material, no solvent at all, no additional electricity used for heating the solvent. So no hazard, everything is water-based. How we addressed it? The same polyphenolic compound issue comes in beer and wine industry. They don't use solvents to remove those polyphenolic compounds because the barley, all those grains gives out also polyphenolic compounds. They use polyvinyl polypyrrolidone, which is a biodegradable polymer, to scavenge this polyphenolic compound, and then they treat everything with water. So our scientists worked on this process. Just within 2-3 months of bench work, we were able to scale up, and now we produce this using less amount of the raw material, no solvent, no additional electricity utilized. And I will show you the score of the applying our dozen tool. You can see we put it in green so that it's a greener process, but green is kind of not readable that much. You can see on the bottom right corner, the new process score is 1. So 0 is the most desired. Of course, 1 is also as good as 0. The old process gave 57 score. You can see each principal scores improvement. Atom economy, 93% improved. Waste prevention, 97%. Energy efficiency is 100% improved. Overall, this process was 98% improved. And I show some more examples of the process we re-engineered. Say new score, the first product aminobenzotriazole, 93, old score, new was 46. You can see all over the numbers. The last one, nitrophenyl beta xyloperoxide, old was 100, new was 49. So there are many products. We just showing you some key products. I'm going to show you a 2-minute video how this thing works. There is no audio in the video, just only you can see how you enter, how you create an account, how you start applying it. So first step, it will say you have to create an account with our sigmaltech.com/green, and then once you create the account, then you will be approved within 48 hours. Then the tool is yours to use it. This demo video will show sodium acetate as a 2 raw material going into the process, how you score it. Let me put the video on. So you click the launch dozen tool, then it will take you to the create account registration, then create account, sign in, then you enter your product, final product you are making. Then if you have more than one product, you have to have a co-product, but in this case, no. Enter the reaction conditions, time, temperature, raw material, one at a time. B score is a biohazard score found in STS page. So save and calculate, it gives the score for each principles and aggregate score. And then you can download the data on the right top corner. It will show. You can see the Excel sheet also. You can see what was which one is contributing more. I know it went very fast, but if you are interested, we are ready to help you to get started on your own time. Sorry. We have resources in India, Bangalore, India, so we can help you get started on this on your time zone, not like late in the evening or early in the morning. So advantages of dozen 2.0 is we are using the measuring Measurement is very easy because we are using the hands-on data. The calculation is easy because we are using the well-defined metrics of the 12 principles of green chemistry. Now we can communicate to customer like you transparently. This is the metrics we use. This is what our process is. The key thing is data privacy. Users can evaluate the process in a safe and secure manner. Your data is yours. Nobody else can see your data. This is a free web-based tool available in our website. Anybody can go and register and use it free of cost to improve your overall sustainability. Our system was verified and, sorry, it's jumping up. Verified, validated by third party and published, as I said earlier. This is the ACS Sustainable Chemistry and Engineering Journal. Our tool was awarded Project of the Year for 2020, Environment and Energy Leader, and also Merck's CFO Global Excellence Award in 2021. Thank you for your attention. I am available to take questions. Hello.
Yes, sir. So it was a really nice presentation enlightening us about green chemistry and DOZN 2.0 tool. So the house is open for questions and any query about DOZN 2.0 tool. Any question from any participant or okay, if there are no questions, I'm thanking Dr. E. Panuswamy sir for his wonderful lecture and enlighten us. Thank you, sir.
Oh, thank you very much for inviting. So I give my email address. You could share with your participant.
Yes, sir,
they can reach out to me if they, and if we use this in the US and other. In fact, in India also, like this, and Bangalore, there's called RV College of Technology. It's based in Bangalore, and they apply this tool for their curriculum. So I encourage you all try to use it in your curriculum, and we will help you to get started. Any technical issues, we have local resources. We have our people work in Bangalore, so they can help in your time zone to establish that.
Yes, sir, definitely.
Yes, sir. We shall contact you, sir. We shall contact you.
So if the goal why we are giving out free is if the more people uses and applies, it's better for the environment. You know that UN sustainable goal to reach. We all have to pitch in. That's what we are doing. As a global citizen of our company, we want to give it out the tool to people
Can
to
we
use.
organize workshop for students, sir?
Oh, sure, yeah, we can.
Yeah.
So let us know. I mean, we can arrange you at your time zone with our. We have people from India. My team, they are over there, so they can help to class time. She can give how to utilize the tool more detailed way.
Yeah.
Because I went in a crash course type of thing because the timing was 30 minutes. So
I'm from Bihar.
We can do a workshop also. They just let me know, then I will connect with my team and they can help you.
Sure, sir. We shall contact you.
Thank you, sir. Thank you very much. Okay, sir. Thanks a lot for joining with us.
Thanks for organizing a great conference, and I wish you all good luck in your conference and a happy new year. Hope we get a new year, good resolution for this COVID.
Yeah. Thank you, sir. Thank you. We'll be in touch through email, sir.
Sure. Thank you. Bye.
Thank you, sir. Okay. Now we are at the end of the session, but from the previous session, if any participant left, they can give the presentation. Since we have maybe 2-3 slots free around 10-30 minutes, we can now utilize. If any
So
participant
should I leave
left-
now? Should I leave
Yes, sir.
now or?
Yes, sir.
Okay. Thank you all. Wish you all a
Yes, sir.
happy holidays and happy new
Thank
year.
you, sir. Thank you, sir.
Bye.
Thank you, sir.
Thank you.
If any participant left from the previous technical session 2, I hope I have seen the 2 participants, that is D.T. Sakhere and Dr. Najira. Yeah, Dr. Najia. No, Dr. Hina. Yeah, Dr. Hina. If they want to present, if you want to present, definitely you can present your paper.
Yes, sir, I would like to present. This is Dr. Hina Sheikh.
Yes, yes, yes. Okay, please go ahead. Let me call the same chairperson. Just a minute. Sir, you are online? You are online, sir? Yeah, you can be online there. Okay, you can continue. Please start. Dr. Hina, right? Yes. Dr. Hina, paper number
Yes, sir,
15.
Dr. Hina Sheikh.
Q15.
Okay, shall I start, sir? My screen is visible. I'm audible.
Yeah. Yes.
So just wait for 1 minute. We'll start.
Okay, sir. Okay.
Just wait for. Okay, Dr. Hina, you may start.
Very good evening, all of you. My name is Dr. Hina Sheikh. I'm from Wilson College, Mumbai. The topic of my presentation is in vivo study of the topic of my presentation is in vivo study of immunomodulatory effect of Melina arborea, rocks, and Callonche pinnata. So my work is on 2 plants, Melina arborea and Callonche pinnata. This is my study protocol. The animals which I used for my study is Vista albino rats. The body weight I chose for the animals was 180 to 200 grams. Then for doing immunization of the animals, I used 1% of sheep RBC. The reference drug which was used was cyclophosphamide. This was given through injection and the amount given was 30 mg per kg body weight. Dose of the reference drug which was given was septaline. This was given orally and the amount given was 500 mg per kg. Next, my plant sample I gave 500 mg per kg of hydroalcoholic extract of Melina arborea and 400 mg per ml of Callonche pinnata, respectively, reconstituted with distilled water. And this study I did for 14 days. The various parameters which I evaluated in my studies were humoral immune response, cell-mediated immune response, complete blood count, CBC, and histopathy. These are the test groups of the animals which I used for the study. So for my study, I divided my animals in 6 groups, each group containing 8 animals. The first group of 8 animals was normal control, like they were given normal food. The second group was given only antigen. The third group was given immunosuppressant, cyclophosphamide. This is available in the market and it is known to suppress the immunity. The fourth group was given septaline, which is immunostimulant, which is known to increase the immunity. The fifth group was given the hydroalcoholic extract of my first plant. The sixth group was given hydroalcoholic extract of my second plant, Kalonche pinnata. So this is how the groups were divided. The first group was not given anything. The second group was given SHIP RBC. The third group was given, A stands for administration. So third group was given SHIP RBC along with cyclophosphamide, which decreases the immunity. The next group was given SHIP RBC, that is an antigen, along with septalin, which is known to increase the immunity. The next group was given SHIP RBC along with my first plant extract, and the next group was given SHIP RBC along with my second plant extract. So basically what I wanted to find out is, one group I made normal, the second group I gave only an antigen, next group I gave a known immunostimulant, which is known to increase the immunity. So third group immunity is going to increase. The fourth group animals immunity is definitely going to decrease because it is given cyclophosphamide, which is known to decrease the immunity. So now what I want to see is what happens to my animals, the animals which are administered with my plant extracts. So that's what I wanted to see. This is my first method. The first method was humoral immune response, which is also called as HAHI test. What I did in this test is I used increasing concentration of my plant extract, and it was added to antigen. Now the minimum concentration of the of my plant extract required to do the precipitation that I wanted to find out, that is called as agglutination. So minimum concentration of the plant extract required, the lower the amount required, higher would be the effect of the plant. So what I observed after doing this test is, I observed the fifth group, which was given my first plant extract, it shows increase in the immunity. The sixth group, which was given the second plant extract, shows decrease in the immunity. The second test which I did was cell-mediated immune response, which is also called as delayed high-type hypersensitivity. In this, what we do, we give injection SHIP RBC to the rat on its leg. So foot. So on the right foot of the animal, SHIP RBC was given. So because of that, what happens? There is a swelling which is observed. For all the animals, there is a swelling in the foot. And then we give them our plant extract to see how the swelling reduce. Okay, so the rate of reduction will tell us how effective is the plant extract. So if the swelling reduces quickly, it means my plant extract is increasing the immunity so that it is healing, the swelling is healing fast. So after doing this test, I observed that my first plant extract is showing increase in this delayed type of hypersensitivity. So it is an immunostimulant in nature. And second plant extract, it shows reduced type of reduced delayed types and hypersensitivity, means the second plant extract is actually decreasing the immunity. The next test which I did was CBC, complete blood test. So RBC, WBC and platelets I found out. I observed that the fifth group, which was administered the first plant extract, it increases the overall count of RBC, WBC and platelets, means it increases the immunity. And the second group, it shows little decrease in the amount of RBC, WBC and platelets, so it decreases the immunity. This is the histopath results which from animals again the study, and histopath was done over in the liver or in the spleen of the animals. So that or my plant it will many conclude that plant effect of Melina arborea, it increases the overall immunity. It is an immunostimulant. And the second plant extract, Kalonche pinnata, it decreases. It showed decrease in all the tests. So it is a immunosuppressive in nature. These are my references. Thank you so much.
Okay, it was a nice presentation by Dr. Hina. So the house is open. The house is open for questions or any query you have. Any question from any participant? Just quick 1 or 2 questions. Okay, if there are no questions, I'm thanking Dr. Hina for his nice presentation.
Thank you so much, sir. Thank you so much.
Okay, please unshare your presentation. Now over to Dr. NKB.
Hello. Okay, I think we have one more presentation that will come. But before that, I think Professor Deka sir has joined. Sir, am I audible? Professor DC Deka sir, sir, am I audible? Sir, you please unmute.
Yeah, Deka sir, please unmute. Okay, ask this fellow, you know, probably it has been done from our side, from this side, I mean, the operation side, right, yeah. Okay. Nayan, please ask Sunny to unmute him to Dr. Deka.
No, sir, the power is given.
Okay.
Power is given. I think he can unmute, sir.
Professor Dibakar, you can do yourself. It is not happening that side, I don't know. Let us ask Sunny. Let us ask Sunny, you know. Sunny, can you hear?
Oh, now it is done, sir. Now
it is done. Okay, Doctor, it is done.
Deka sir, am I audible? I think network problem. I think network problem. Anyway, I think there is one more speaker available.
No, what Sunny is saying, what Sunny says.
So let me speak once directly.
Look, okay. Please call Sunny, sir, please. Dr. Dibakar, just 2 minutes. Anyway, he's trying from his side also.
I think you can phone up Professor Deka and ask him what is his problem.
Nayan, meanwhile, please call Sunny.
Yes, sir, I'm talking to him. Sunny, can you unmute Professor DC Deka? Professor.
Namaskar, yeah. This guy is trying from this side. Yeah, I can hear you. Yeah. So this fellow, you know, is trying to do something from this side. Yes. Yeah. Yes. So thus Nayan Kamal has spoken. Nayan has spoken to the Sunny, and he is working on it. Yeah. And meanwhile, we are watching you.
Sir, please forward the Deka sir's number to me, sir.
Okay. 1 minute.
Yeah. Since I think there is problem, since Sunny has given all rights from his side, he's telling that rights given to unmute. And it is unmuted also. I think the voice not coming means there is some problem.
So I just WhatsApp.
Yes, sir. Yes, sir. By the time, sir, there is one
Yes.
speaker. Let us continue, sir.
Yeah. Your browser is preventing. Okay. So anyway, only few seconds. Okay. Okay. But Nayan Kamal is saying that he has spoken to Sunny, and Sunny says from his side he has done. No. Okay. So computer browser is preventing. Let me speak to that fellow, Sunny. 1 minute.
Sir, actually, I think sir has to download. That means install this Zoom. He has tried from the browser directly. I think that type of case, the problem is there.
Okay.
Anyway, sir, please forward the phone number. Let me speak first, and by the time one speaker is left, let him continue.
Let him speak. Okay, no problem. Yeah.
Sir, please forward the phone number.
I'm forwarding the number.
Yes, sir. Yes, sir. Yes. Sorry.
Okay, Dr. Hina, can you unshare your screen? Dr. Hina. Dr. Hina. Dr. Hina.
Sunny can do it. Let us ask to Sunny. He can also do that.
Okay, Sunny, can you unshare the screen?
Hello, Professor Deka.
Okay, so there is one more presenter, DT Sakhere. Are you there, sir? Dr. DT Sakhere? Dr. DT Sakhere, are you there? Or any presenter of session 2, right? If available, he or she can present. S. Murugan, Dr. Raj Badekar, okay, sir. Okay. And this is tripod file. Install Sakhere. No, okay, stop.
Okay, we are at the end of the today's session. Today, we started with the inaugural function. Then there were two invited speakers. After that, again the oral presentation. After that, in the second half, two invited speakers followed by the oral presentations. And finally, the invited speaker, Dr. Sami from Millipore, US. Tomorrow, we will start the session from 9 o'clock. Initially, oral presentation will be there from 9 to 10:20, and invited speech that is from 10:30. Dr. Venkat Narayan from USA, he will be joining at 10:30 morning. Thank you all the participants. Thank you all. And I request all the EC members of SCT to join at 6:30. Professor, should we keep the meeting at 6:30?
Okay, no problem.
Then at least
As announced, it at 6:30.
6:30, yes, sir. Then we will get
So the link is the
time.
same. Nayan, link is the same.
That let me speak to Sani, sir. I will update.
No, in case you know, if it is different, then immediately you have to send to all the EC member in one go. Yeah.
Okay, sir. Okay, let me speak to Sani, sir. And I think Dekka sir has tried. I have spoken to Dekka sir. He was trying. The problem was from the browser. He now he has installed, I guess. Dekka sir, now are you online? I think same problem. Anyway, sir, I have spoken to sir.
Okay.
Dekka is muted. He should unmute himself.
Participants can leave the meeting. All the participants. Thank you all. Can leave the meeting.
Thank you, sir.
Tomorrow, request everyone to join tomorrow 9 o'clock for the oral presentation followed by the invited talk. Participants can leave the meeting. Thank you,
sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you. Thank you all.
Thank you very much.
Thank you, sir.
Thank you.
Just ensure about the link, you know. Ensure about the link.
And for tomorrow, yeah, I will share the link. I think Dekka sir now. No. Dekka sir, can you unmute, sir?